All right, people. I believe everybody is doing great, nice, and absolutely fine. Okay. So, welcome to Unacademy NEET English. Welcome to Unacademy NEET English. Please let me know in the chats if I'm perfectly audible, visible to each and every single student. Everyone means everyone. I want you guys to let me know in the chats if I am perfectly audible, if I am perfectly visible to each and every single student. Everyone means everyone. Come on, guys, quick. Okay. And today's session is going to be extremely important. I would want you guys to listen to me very carefully for a moment. I will teach you the chapters gravitation. Okay. I will teach you the chapter, I would say, mechanical properties of solids, mechanical properties of fluids. I will teach you thermal properties of matter, thermodynamics, KTG, SHM, waves from the scratch. Trust me, guys, you will understand each and every single thing if you keep your mind in the class, if you give me your 100% attention. Okay, doesn't matter if you have studied these chapters before, but trust me, my dear NEET aspirants, you are going to understand each and every single thing. That is my guarantee. And trust me, and I'll be showing you all the problem patterns, whatever you have from the scratch. Okay, whatever the concepts are there in these particular topics, I'll be showing you all those. Okay, and I'll be completing all of these chapters in just one session. So be there till the end, my dear NEET aspirants, okay? So that we can smash the entire session. Let the people join, okay? And we will be starting this particular session. We will be starting this particular session accordingly. Let everybody come. And make sure you smash the like button because liking the session is mandatory. Liking the session means marking the attendance. Liking the session means marking the attendance. Keep that thing in your mind. Keep that thing in your mind. Okay. Yes, that's great. So, my dear NEET aspirants, let's dive into the session. Let's dive into the session. Okay. Let's understand each and every single topic. Okay. Let's understand each and every single topic over here. Okay. From the scratch, from the basics. Keep that thing in your mind, my dear NEET aspirants. From the scratch, from the basics. Okay. Yes. Now, guys, we have the class 11th part 2. We have the class 11th part 2. And in this particular session, my dear NEET aspirants, I would want you guys to listen to me very carefully. When it comes to the first chapter that I'll be taking over here, when it comes to the first chapter, listen carefully, listen carefully. When it comes to the first chapter that I'll be taking over here, first we'll go with gravitation. Okay. Then we'll go mechanical properties of solids. Okay. And then we will go, my dear NEET aspirants, fluids. Okay. Then, my dear NEET aspirants, gravitation, solids, fluids, we say thermo. Okay. Thermodynamics. Then we will move on to the KTG. Okay. Then we will move on to the KTG. And my dear NEET aspirants, then we will move on to the thermal properties of matter. Thermal properties of matter. Okay. Then we will move on to SHM. And then we will move on to waves. Waves. These are the chapters that we are going to cover in the today's session. And trust me, if you have not studied before, doesn't matter. You will understand each and every single thing if you keep your mind here, if you give me your 100%. Is that clear? Is that clear, guys? Is that clear? Now, boys and girls, let's first start with the chapter that is gravitation. The first chapter that I'm going to start with will be the gravitation. Okay. And the first topic of the gravitation is gravitational force. Okay. Gravitational force. What does this gravitational force actually mean? What does this gravitational force actually mean? Listen to me very carefully. Listen to me very carefully. Now, my dear NEET aspirants, since we start the gravitation chapter, I need to make you understand what gravitation is. Listen. Let's suppose we have a mass m1 over here. Understand very carefully. You will be able to understand. That is my guarantee. Okay. Let's suppose I have a mass m1 over here. And I have a mass m2 over here. This is the mass m1 and m2. Like you have two spherical objects, one spherical object, another spherical object. Placed at certain distance, let's suppose r. Placed at certain distance, let's suppose r. We said these two spherical objects actually, these two masses actually attract each other with a force, And that force is what we call the gravitational force. So whenever you have two masses in this universe, sir, will they apply force on each other? Yes. What kind of force? Gravitational force, sir. I have this object. I have this object. Sir, are they attracting each other with a force? Yes. But what force? That force is what we call gravitational force. Okay. And if you ask me, sir, that gravitational force, listen to me very carefully. We say it is proportional to, I would say, product of the two masses, m1, m2. If I say I have two bigger masses, they will apply more gravitational force. If I say I have two smaller masses, they will apply less gravitational force. So my dear NEET aspirants, this gravitational force is inversely proportional to r square. What does it mean? If you increase the distance separation between the two masses, we say gravitational force is going to decrease. Okay? Gravitational force is going to decrease. Now, if you combine the two equations, what you can write over here, F is proportional to m1, m2. Okay? And then we say divided by r square. F is proportional to m1, m2. Then you say divided by r square. Okay. F is proportional to m1, m2 divided by r square. Now, my dear NEET aspirants, in this particular case, what you are going to do, you will replace this proportionality with a constant. That constant is g. And then I say m1, then I say m2 divided by, I would say, r square. Divided by, I would say, r square. Okay. Is this clear? Is this clear, my dear NEET aspirants? So this is the gravitational force actually between the two objects. This is the gravitational force between the two objects. Whenever you have two objects, m1, m2, okay, they apply a force on each other. That is called gravitational force, and that is equal to g m1, m2 by r square. Now, what is this g? This g is actually universal gravitational constant. If you ask me what is the value of this universal gravitational constant, my dear NEET aspirants, we say value of this g is 6.67 into 10 raised power minus 11. Okay. Then we say Newton meter square upon kg square. This will be the value of the g. This will be the value of g. And few more points I just want to say. Guys, this force will be acting along this line. The line which is joining the center of the two masses. Okay. This mass and this mass. It is joining the center of the two masses. Okay. Okay. So we say this force will be along this line only. This is called central force. Central force. And it will be attractive in nature. Okay. It's a central force. I'll mention this over here also. Central force. Central force. And we say it's just attractive in nature. Attractive in nature. Okay. It cannot be repulsive in nature. Okay. Now, my dear NEET aspirants, let's move on to the questions. We have the first question on screen. I would want you guys to understand this very carefully. See guys. In this particular case, what does the question say? Find the net force on the fourth mass. Okay. You have this mass, you have this mass, you have this mass, you have this mass. You have to find the net force on any of the four masses. See guys, whenever you have two masses, they apply the gravitational force on each other. We said this mass is going to attract this mass towards itself. Okay. This mass is also going to attract this mass towards itself. This mass is also going to attract this mass towards itself. Because whenever you have gravitational force, whenever you have masses, there will be gravitational force. Now, my dear NEET aspirants, on this mass, I would say force will act in this direction. Let's suppose this is F1. And we say, my dear NEET aspirants, this will also attract it with the force F1. Why, sir, F1? Because this mass is similar to this mass. This mass is also similar to this mass. So whatever is the force between the two, that will be the same between the two. Okay. Now, if I say, what is the value of force F1? Guys, we said this F1 is equal to F2 will be equals to G M1 M2. That is M into M becomes M square divided by, I would say, what is the distance between the two? That is A square. GM square by A square is the force between the two masses. And then, my dear NEET aspirants, if I say, what is the force between these two? You'll simply say, sir, this force, if I say this side is A, this is going to be root 2A. So this force, I can say this is F3. Now, my dear NEET aspirants, this F3 in this particular case will be, guys, G M1 M2, that is M square divided by G M square divided by, what is the distance between the two, my dear NEET aspirants? Distance between the two. So I can say, sir, this is a root 2A. So that is a root 2A whole square. So you'll be like GM square divided by, I can say 2A square. And guys, this F1 and F2 are basically similar. If F1 and F2 are similar, so I call this as F. Now, can I say on this fourth mass, okay, on this fourth mass, I would say one force is acting in this direction, another force is acting in this direction, and I would say this is the another force. This is F, and this is this F3, and let's call this as F dash. Yes. Now, guys, before this, I need to tell you something which is extremely important, Listen carefully. See guys. What is that? Listen. You'll be remembering one thing. My dear NEET aspirants, if you have two vectors, let's suppose there is a force F1 and there is a force F2. These are the two vectors, or these are the two forces. Okay. And angle between the two forces is, let's suppose, F. Okay. And my dear NEET aspirants, we say they have got the net force something like this. If somebody asks you what is the value of this net force, you say simply net force is under root of, I would say, F1 square plus F2 square plus 2 times of F1, I would say F2, and then I say, my dear NEET aspirants, cos of theta. This is going to be the net force between the two. This is the resultant of the two vectors. We can understand it like that. Now, my dear NEET aspirants, directly remember from now onwards, if the angle between the two vectors, if theta is equal to 0 degrees, in that particular case, I can say net force will be, guys, if theta is equal to 0 degrees, means if you have a force acting in this direction on this block, let's suppose this is a block, and on this direction, this is F2 is F. And both the forces are same, F and F. We say in this particular case, net force will be 2F. Directly, you'll be remembering from now onwards. Sir, where did you get this? I got this from this particular equation. Put the value of F1 as F, F2 as F, then 2 times of F1, F2 cos of theta. Okay. Then, my dear NEET aspirants, if I say theta is equal to 180 degrees. What does 180 degree mean? Like you have got a block. On this block, on the right side, forces acting. On the left side, forces acting. Two forces are in the opposite direction. So in this particular case, I can say net force is 0. Absolutely. So you can put it over here. F square, 2 times of F cos of 0. Okay. Then, my dear NEET aspirants, what you can further say, if theta is equal to 90 degrees. Remember this, my dear NEET aspirants. Like this is the block. On this block, forces acting in this direction. On this block, forces acting in this direction. So we say resultant of these two forces, I can say in this particular case, net force will be a root 2 of F. You'll be directly remembering this from now onwards. Net force will be root 2F. Okay. Then my dear NEET aspirants, if I say this is a block, on this block force is acting F, angle between the two is, I would say, 60 degrees. In this particular case, my dear NEET aspirants, what I can say, net force over here will be under root 3 of F, Okay. Then if I say, my dear NEET aspirants, this is the block. On this block, force is acting in this direction. Another force in this direction. Angle between the two is, I would say, 120. Here, net force will be F only. I hope you got the crystal clear feel of this particular slide. Please tell me in the chats if this is crystalline clear. Come on, guys. Tell me in the chats if this is crystalline clear. At 0 degrees, you'll be remembering, I would say, 2F. Okay. At 180 degrees, it is 0. Guys, give me the signal in the chats with the fire emojis. Come on. At 90 degrees, you'll be saying, sir, root 2F. At 60 degrees, a root 3F. At 120 degrees, I would say F. Is this clear? Give me the signal in the chats. And make sure you smash the like button, because liking the session is mandatory. Everybody out there. Okay. Yes. Now let's move on to this particular question once again. Now guys, tell me. On this mass, I would say, how many forces are acting, sir? F1, F2 and F3. Sir, this is the value of F1, F, F2 is F, and this is F dash. Now tell me, my dear NEET aspirants, since now you have become intelligent, can you tell me what is the resultant of this force and this force since they are at an angle of 90? Sir, resultant will be in this particular case root 2F. Absolutely. So now, can I say, guys, on this particular object, on this particular mass, I would say in this direction root 2F is acting, and in this direction F dash is acting. Two forces. So can I not say in this particular case net force will be simply, that is root 2F plus, I would say, F dash. Root 2F plus, I would say, F dash. Absolutely. Now, my dear NEET aspirants, net force will be in this particular case. Guys, this is a root 2. And then what is the value of F? F is this. I can say simply that is G m square divided by a square over here. Then plus, what is the value of F dash? That is G m square divided by 2a square. Now you can say, guys, in this particular case, G m square divided by a square, you can take common. So it is root 2 plus 1 divided by 2. This is the answer to the question. Okay. Even you can keep it here also, or you can further keep it. You can take it to this also. You can further simplify it like this also. I hope this is crystal and clear to each and every single student. Okay, now guys, let's move on to this question first. This is a simple question. Let's suppose you have got a square over here. On the square, you have mass m. Here it is mass m. Here it is mass m. Here it is mass m. Now, if I am asking you what is the net force, my dear NEET aspirants, listen to me very carefully. I am asking you, what is the net force? On this mass? You will simply say net force will be force due to this, it will attract. 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 So how many masses are attracting? 4 masses in total. So I would say this is F, this is F, this is F, this is F. Okay. Now tell me, I have recently told you, when the two forces are in the opposite direction, since this force and this force are opposite, so their net will be 0. This force and this force will be opposite. Their net force will be 0. What is the net force on the center mass? Absolutely, sir, 0. 100%. Without a shadow of doubt. Okay. Let's talk about this one, guys. Sir, this mass is attracting it towards itself with a force F. This mass is attracting also towards itself with a force F. This mass will be attracting it towards itself with a force F. This one will be attracting with a force F. This one will be attracting with a force F. This one will be attracting with a force F. Don't you think in this particular case also, my dear NEET aspirants, we can say this will be cancelled, this will be cancelled with this will be cancelled with this will be cancelled with this. What is the net force on the center mass? I would say 0 in this particular case. Net force on the center mass in this particular case is 0. I hope this is crystal clear to each and every single student. Sir, what about this one? What about this one? What about this one? Guys, here also I would say net force on the center mass will be 0. Now see, the logic is even if you keep the triangle also, M, M and this M, here also net force on the center mass will be 0. Guys, see, what is the logic behind this? What is the logic behind this? The logic is, if at, listen carefully, if at every single corner mass is present, if at every single corner mass is present, this one, an identical mass is present. See, if this is M, this is M, this is M, this is small m. If identical masses are present at every single corner, then net force on the center mass is going to be 0. If identical masses are present at every single corner, then net force on the center mass is going to be 0. Guys, what about this one? What about this one? Listen carefully. What about this one? Sir, you have to find net force on this mass. See. If this is 2m, this is m. Oh, guys, tell me in the chats if this is clear till over here. Come on, quick. Give me the signal in the chats if this is clear till over here. Quick. Is this clear till over here? Cool. Now, guys, take a look. We have to find the net force on the center mass. Since when we talk about this mass, it is going to attract this mass towards itself. So it will attract it towards itself with 2F. Okay. And then, my dear NEET aspirants, why? Because this is 2M. 2M is going to attract it with 2F. This M is going to attract it with F. Oh, sir, amazing. This 4M is going to attract with 4F. And this 3M is going to attract with 3F. Absolutely, sir, without a shadow of doubt. Now tell me, my dear NEET aspirants, what is the resultant of this force and this force? You'll simply say, sir, these two are in the opposite direction. When you have in the, see. If the two forces are in the opposite direction and are equal, then they cancel out with each other. F and F, they cancel out. But since they are not equal, so you'll subtract 3F minus F. So, my dear NEET aspirants, at the center mass, I would say it will be 2F in this direction. 3F minus F is 2F. And the direction of net will be along the direction of bigger force. This is the bigger force. Similarly, in this particular case, I would say this 4F, 2F. What is the resultant of 4F and 2F? That will be also 2F, my dear NEET aspirants. Okay, sorry. Direction will be the direction of bigger one. So that will be 2F. This is 2F. And always remember, my dear NEET aspirants, this is, I would say, 90 degrees over here. Okay, this is 90. Now, if this is the force, angle between the two is 90. Could you please tell me what is the resultant of the two? Guys. If this was F, this is F. What is the resultant 2F? Okay, if this is 2F, this is 2F. In this particular case, what is going to be the resultant? I would say that is a root 2 of 2F. Hey, if this is x, angle is 90, root 2x. If this is y, resultant is 90, root 2y. If this is 2F, this will be 2 root 2F. This is going to be the net force in this case. Okay. I hope this is clear till over here. Now, my dear NEET aspirants, let's suppose you have find the force between the hollow sphere and a point mass. This is a hollow sphere. Hollow sphere means football, which is hollow from inner side. And this is the point mass over here. Point mass is at what distance? H. You'll be directly using the formula over here. Guys. Assume the mass of the hollow sphere at center. Assume the mass of hollow sphere at center. Now use the formula. F is equal to G m1 m2 divided by r square. Now F is equal to G. What is the value of m1, my dear NEET aspirants? Capital M. What is the value of m2? That is small m, divided by what is the distance between the two, my dear NEET aspirants? That is r plus h, because you are assuming the mass of the hollow sphere at the center. That is r plus, I would say, h, its whole square. Its whole square. Done, sir. Okay, what about this one? What about this one, my dear NEET aspirants? What about this one? What about this one? If I say this is the hollow sphere, this is the hollow sphere, okay, and this is the mass present on its surface, m, okay. Now this is the radius r, mass of this is m, and radius of this hollow sphere is capital M. Guys, see, this is a hollow sphere, mass of this is m, okay, and radius is r, this is another mass. Now you guys are supposed to tell me what is the force on this mass. You'll be simply saying, sir, assume the mass of the hollow sphere at the center. F is equal to G capital M small m divided by what is the distance between the two? That is r square. Simple. What about this one? What about this one? Guys, see, in this particular case, you have a hollow sphere. Understand this very carefully. Hollow sphere means football. It says that find the force between the point mass and hollow sphere. In this particular case, you can clearly say mass is present inside the hollow sphere. Mass is present inside the hollow sphere. It is not outside. It is not on the surface. Whenever you have a question something like this, my dear NEET aspirants, simply say, we say net force on the mass will be 0. On this mass, on I would say mass M. Why? Because we assume effect of mass of this hollow sphere. See, when you talk about the football, in case of football, we say mass is present on its surface. It is not present inside. In case of football, we say mass is present on its surface. It is not present inside. So due to that mass, there will be no effect inside. Effect will be only from the outside. So that is the reason we say if there is no effect inside, so force on this mass will be 0. Force on this mass will be 0. Okay. Now, my dear NEET aspirant, this is a solid sphere. This is a solid sphere. Solid sphere. Sir, can you give the example of a solid sphere? Solid sphere can be the cricket ball, which is not hollow from inner side, which is filled from inner side. Sir, in this particular case, could you please tell me, what will be the force on this mass, which is present inside the solid sphere? Will it be also 0? No. Your mass is present inside. If you ask me what is the force on the mass which is present inside, listen carefully, my dear NEET aspirants. And inside at what distance? It is present at inside r distance, small r. And capital R is the radius of this. Capital R is the radius of this. Listen carefully, please. You'll be simply remembering in this particular case, my dear NEET aspirants, force will be G, capital M, small m. Capital M is the mass of the solid sphere. Mass of the solid sphere. Small m is the mass present inside. Into R. R is the distance of that mass where it is present inside from the center. Divided by capital R cube. Capital R is the radius. So there is a long derivation for this. I want you guys to skip. I would say remember directly. Guys, tell me in the chats if this is crystalline clear. Everybody out there, if this is crystalline clear, tell me in the chats. Quick. I need the signal in the chats, and make sure you smash the like button. Is this clear? Okay. Now, guys, let's talk about the equilibrium position. Let's talk about the equilibrium position. What does equilibrium position actually mean? Listen, guys. We say, let's suppose I have a mass over here that is m. I have another mass over here that is n times of m. This is n m. This is n times of m. Okay. This is n times of m. Okay. Yes. Distance between the two masses is r. Distance between the two masses is r. This is the distance between two masses. I am asking you, where should I place the third mass so that net force on it is zero? Where should I place the third mass so that net force on it is zero? Okay. Sir, let's place it over here, third mass, m naught over here. Let's check if the net force on this mass is zero or not. Now, my dear NEET aspirants, this mass is going to basically attract it towards itself, okay, with a force, let's suppose F2. The first mass, this mass is also going to attract it towards itself with a force, I call that F1. Since the two forces are in the same direction, is there any possibility that net force can be zero? No, sir. Why? Because in this particular case, the two mass forces are in the same direction. Net force cannot be zero. Let's talk about here. Net force can only be zero when the two forces are in the opposite direction. This m1 is attracting it towards itself with a force F1. This second mass is also attracting it towards itself with a force F2. Here also two forces are in the same direction. Net force cannot be zero. Net force cannot be zero. Okay. Now, my dear NEET aspirants, what I am trying to ask you over here is, let's place the third mass over here, somewhere over here. Now, in this particular case, listen carefully. This m is going to attract it towards itself. Let's suppose F1. This another mass will attract with F2. Since the two forces are in the opposite direction, so we say at this point, net force will be zero. Sir, is this exactly at the center? No. It is towards the smaller mass. It is towards the smaller mass. Sir, at what distance? At what distance? I would say this distance in this particular case is x, at x distance. So at x distance, net force on third mass is zero. Net force on third mass is zero. Now, if somebody says, sir, what is the value of this x? You say x is simply, that is r upon under root of n plus 1. R upon under root of n plus 1. N is this. Okay. N is this. R is this distance. Okay. I hope this is crystalline clear to each and every single student. Tell me, guys, is this clear? Is this clear? So simply you'll be remembering, if you have two masses, where should I keep the third mass so that net force on it is zero? Sir, I'll keep it at x distance from the smaller mass. That x is equal to this. That x is equal to this. R upon under root of n plus 1. Now, let's take a look at the question. 2 point masses of m and 4m. You have 2 point masses m and 4m. This is m and this is 4m. M and 4m. Okay. Are separated by a distance d on the line. This is the distance d. A third mass m naught is to be placed on the line. Third mass we need to place on the line such that net gravitational force on it is zero. Such that net force on it is zero. So where should we place it? So distance of that point from the mass m is At what distance? X. Now, if you ask me, sir, what is the value of X? R upon under root of n plus 1. Okay, just a second, guys, just a second. Okay, so in this particular case, this one. Now, if you ask me what is the value of n over here, n in this particular case is 4. So I'll be simply writing this is the value of r, that is d upon under root of 4 plus 1. So root 4 is, I would say, 2. 2 plus 1 is 3. So it will come out to be d by 3. Is this clear, or tell me in the chat? So let's suppose if I give you one more question of the similar pattern, Let's suppose you have something like this. Understand, guys. Question is, you have 25m, okay, and you have 36m. 25m and 36m. Now, in this particular case, this r is given as 11 meters. Where should I keep the third mass so that net force on it is 0? Where should I keep the third mass so that net force on it is 0? Okay. Sir, I need to keep the third mass m0 over here. At what distance, sir? X distance. Sir, what is the value of this x? X is r upon under root of n plus 1. Sir, how do I find the n over here? I will tell you. N means actually how many times this bigger mass is bigger than smaller mass. N is how many times bigger mass is bigger than smaller mass. And how do you find n? See, n is bigger mass is how much? 36m. Smaller mass is how much? 25m. Simple. Bigger mass by smaller mass. This and this will cancel, so n will come out to be 36 by 25. Now put it over here. R upon under root of 36 divided by 25 plus 1. Now this will be r upon, and how much is basically r? R is 11 na, upon. Root 36 is 6. Root 25 is 5 plus 1. So it will be like 11 upon 5 into 1 is 5. 5 plus 6 is 11 divided by 5. This and this will cancel, so it will come out to be 5 meters. At a distance of 5 meters, you need to keep it so that net force on it will be 0. Please tell me in the chats if this is clear. Or give me the signal in the chat. So is this clear with the fire emojis? Quick. Yes, 5 meters from the smaller mass. And if somebody says, what is the distance from the bigger mass, guys? How much is this? How much is this? 11. How much is this? 5. So 11 minus 5. How much will be this? 6 meters. Distance from the bigger mass will be how much? 6. Okay. So guys, actually my screen was not working. Okay, there was some issue with the smart board. That's why I'll fix it by tomorrow or day after tomorrow. I have spoken to the team already, so we'll get it fixed, and then next session will be on the smart board, by the way. Okay, next session will be on the smart board. But I hope this setup is also fine. Huh? You are able to understand every single thing. I believe so. Okay, now guys, one more important question. Okay, that is mass m is at the center. Mass m is at the center. Mass m is at the center. This mass m is placed at the center. Okay, it is capital M. Capital M is placed at the center. And small m is moving around it. Small m is revolving around it. Okay, this is small m revolving around it. And then, my dear NEET aspirants, it says that find the time period. Find the time period. Time period means in how much time it will complete one cycle. Like this is a small capital M. Small m is revolving around it. Small m is revolving around it. It says in how much time it will complete one cycle. One cycle means if it starts from this point, it will have to reach the same point once again. That's called one cycle. The point from where it is starting and the point where it is exactly reaching once again, that is called one cycle. Okay. Now, my dear NEET aspirants, whenever you have the question of this sort, what will you do in this particular case is CC. We say first, this is the distance R. First of all, gravitational force will act over here. We say gravitational force will act over here. Okay, because you have two masses kept at R distance. And whenever the object is in the circular motion, we say centripetal force will also act. And the point is centripetal force and gravitational force both will be equal. Due to two masses, gravitational force. Due to circular motion, centripetal force. So in this particular case, my dear NEET aspirants, gravitational force will be G, capital M, small m divided by R square is equal to. Centripetal force will be, that is M V square divided by R. And I will write this equation of centripetal force, mr omega square. This is also the centripetal force, mr omega square. Yes, sir. So whenever a mass revolves around another mass, we say centripetal force will act, gravitational, both will be equal. Now take it over here. So we can say omega square will be G capital M small m divided by, okay, G m1 m2 by R square and mr omega square. This and this will be cancelled over here. Okay, so this will be, just a second guys. So this m and m will be cancelled. So this will be Gm divided by R into R becomes R cube. Now omega, take this root over here. So this will be actually under root of Gm divided by R cube. Okay. And we can also say omega is 2 pi divided by T. Please remember this, omega is 2 pi by T. So it will be under root of Gm divided by R cube. Okay. 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 Now guys, in this particular case, do the reciprocal over here. So can I say 2 pi? So basically I'll do this. I'll do it like this. See guys, I'll do it like this. I can say that is T divided by 2 pi will be under root of R cube divided by Gm. So T will be equals to 2 pi under root of R cube divided by Gm. Okay. Please tell me in the chats if this is crystalline clear. Please tell me in the chats if this is crystalline clear. Come on guys, quick. Is this clear? This is the time in which it completes one cycle. This is the time in which it completes one cycle. Let's move on to the gravitational field intensity. See, what does gravitational field intensity actually mean? Listen carefully. Listen carefully. See guys, let's suppose, listen guys, let's suppose if I say, just a second. Okay. See guys, if I say I have actually a magnet over here. This is a magnet. This is a magnet. I have a magnet over here. This is a magnet. If I place a coin over here, what is going to happen with the coin? Sir, it will be attracted towards the magnet. If I place the coin here, it will be attracted. If I place the coin here, it will be attracted. If I place the coin here, it will be attracted. If I place the coin here, it will be attracted. Here, it will be attracted. So, my dear NEET aspirants, in this particular case, can I not say, if you place a coin around the magnet, it is getting attracted? Yes. So, can I say this magnet is creating some sort of field around it? That field is called magnetic field. Magnetic field. If in that magnetic field some other coin comes, We say it is attracted. It is attracted. Absolutely, sir. Now, my dear NEET aspirants, what I am trying to tell you over here is, listen carefully. If let's suppose you have a mass, if you bring another mass, test mass over here, near to this mass, near to this mass, near to this mass, what is going to happen? This will be attracted. If you place it over here, it will be attracted. It is going, if you place it over here, it will be attracted. If you place here, it will be attracted. If you place here, it will be attracted. If you place here, it will be attracted. So means this mass M also is creating some sort of field around it. And in that field, if some other mass comes, it experiences force. This field is what we call the gravitational field. This field is what we call gravitational field. Gravitational field. So can I say gravitational field? See. What does the definition say? Simply, it is a space around a mass. It is a space around a mass in which another test mass comes, experiences force. Please tell me if this is clear. Please tell me if this is clear. Please tell me if this is clear. Come on. Quick. Come on, guys. Okay. So a mass, from now onwards, you'll be remembering one thing. A mass creates a field around it. That field is what we call the gravitational field. That field is what we call the gravitational field. Now let's suppose, my dear NEET aspirants, if you have a mass, point mass, since you said, sir, it will create the field around it. What is the field due to this at r distance? See, what will you do? In order to find the field at r distance, you'll bring a point mass at r distance, m naught. Done, sir. Done, sir. When you brought the point mass at r distance, check the force acting on it. Done, sir. So what is the force acting on this point mass? You say, sir, G, this M, this M, this M, and this M naught, M1, M2, this M, M naught divided by R square. This is the force. Okay. Then divide this force with the test mass itself. In order to find the field intensity, how much stronger field is at r distance, or there's a mass, it creates field around it. At r distance, if you have to find the field, bring a test mass, find force on it, divide that force by test mass, F divided by m naught, it will give you field intensity. We represent gravitational field intensity with I. So this will be, what is the value of force? G m naught divided by r square into m naught. M naught will be cancelled. So I will come out to be G m divided by r square. So this is the gravitational field intensity. Even I would write minus Gm by r square. Why? Because its direction is towards the mass in the left. That's why we consider it negative. Now guys, see, if I draw the graph between I versus R, see. I'll write mod of I versus R. Since I would say this mod of I is inversely proportional to R square. So what is going to be the graph? Rectangular hyperbola. But if I say I is proportional to minus R square, graph will be same, but will be from the lower side. From the upper side plus I, from the lower side minus I. That's why I am saying graph will be same, but from the lower side. This is the magnitude of I versus this R. But this is actually graph between I versus R from the negative side, because it is I is proportional to minus 1 by R square. Please give me the signal in the chats if this is crystal and clear. Come on, guys. Give me the signal in the chats. Quick. Tell me, guys. Sir, you look like Sandeep Reddy Vanga. That's a he's the actor from Tamil Nadu, I guess, huh? I'm not sure. Or Andhra. Hmm? Am I right? Now take a look, guys. Take a look. Gravitational field intensity due to hollow sphere. You have a hollow sphere. Hollow sphere means football. Hollow sphere means football. Field intensity, sir, I didn't understand why to bring the test mass. This is the procedure to find the field intensity. Don't bring test mass. Don't bring test mass. Directly remember, field intensity. Sir, if this is a point mass, M, at r distance, how much field intensity it is going to create? Gm by r square. Directly remember. Directly remember. Okay. Now, guys, take a look. Take a look at this. Gravitational field intensity due to a hollow sphere. Okay, gravitational field intensity due to a hollow sphere. I want you to understand this very carefully. Listen, guys, I want you to understand this very carefully. Everybody out there. See, this is the hollow sphere. Hollow sphere means football. Football. Mass is present on the surface only. And how much is the mass of this hollow sphere? Capital M. How much is the radius? R. You have to, guys, from now onwards, you'll remember one thing. If this is a mass, it is going to create field. Whenever you have a mass, it will create field. Sir, similarly, now we are studying hollow sphere. We have to first find what is the field due to this hollow sphere outside. Outside. Imagine I'm giving you the hollow sphere. You are looking at this hollow sphere from a very large distance. It will appear to you as a point mass. From a very large distance, it does not look like a big hollow sphere. No, it will look like a point. So if I say what is the field intensity due to a hollow sphere outside, it is going to be Gm by r square only. Gm by r square only. Okay, at outside point, what is the field intensity? I would say, sir, and I would keep minus Gm divided by r square only. Because from a very large distance, we consider it a point. Then if I say, my dear NEET aspirants, listen carefully. I'll make you understand. See, outside minus Gm divided by r square. R is the distance where you are finding. Okay, this R. R is from the center. R is from center. If I say on the surface, what is the value of this R? Sir, on the surface, value of this R becomes capital R. So don't you think on the surface, my dear NEET aspirants, I can say this gravitational field intensity on the surface will be minus Gm divided by capital R square. Absolutely, sir. Absolutely, sir. Outside it is going to be Gm by r square. Okay, small r square. On the surface, we say Gm by capital R square. And inside, my dear NEET aspirants, what is the mass present inside? Nothing, sir, zero. So field intensity inside will be zero. Inside will be zero. Okay, so two formulas only. Outside, minus Gm divided by small r square. Surface, minus Gm divided by capital R square. Inside, I would say it is zero. If you make the graph between the two, guys, if you make the graph between the two, see the graph. We say inside, this is C. What is the value of small r at the center? Zero. So means this is center. Oh, listen. If you move from this point towards to outside point, so we say r will increase. If you move towards center, r will decrease. At center exactly, small r is zero. Okay, so if at center small r is zero, so this point will be on the graph, this is going to be the center. So on the graph, if this is going to be the center, from center to the surface, we can say field intensity is zero. We recently studied. From center to surface, field is how much? Zero. This is inside. And when we reach the surface, what is the value of small r? Value of small r becomes capital R. So at capital R, I would say field intensity. This is going to be the field intensity on surface. Gm by r square, mod of gm by r square. Keep this magnitude because it is negative. And then if we move outside, what is, guys, what is the field outside? I is inversely proportional to small r square. So that's why graph is this. That's why graph is this. This is outside. I hope, and my dear NEET aspirants, so the actual graph would be something like this. Actual graph would be something like this. This is I, from lower side it is minus I. So basically from center to surface it will be 0. Okay. Similar graph, this will be surface. This will be surface. Field intensity on surface, this is outside. I hope this is crystal and clear. I hope this is crystal and clear. I hope this is crystal and clear. Tell me, guys, if this is crystal and clear. Tell me in the chats. Quick. Come on. Tell me, guys, if this is crystal and clear. Okay. Let's talk about solid sphere. In case of solid sphere, my dear NEET aspirants, in case of solid sphere. Okay. Gravitational field intensity due to a solid sphere. Solid sphere means cricket ball. First, we'll talk outside. Guys, even if you have a hollow sphere or solid sphere, from a very large distance, both will look like a point. So, field due to a solid sphere outside. It will be again minus gm divided by r square, because at outside r point, gm by r square. On the surface, I can say value of small r is capital R. So I can say on the surface it will be minus gm divided by capital R square, without a shadow of doubt, sir. Sir, surface and outside is same as hollow and solid. Absolutely. And when I say inside, my dear NEET aspirants, I in, it will not be 0 right now, because in case of a solid sphere, mass is present inside also. So inside, in this particular case, my dear NEET aspirants, what I can tell you over here is, inside it is going to be minus gm, m is mass, r is the distance, I'll tell you, and capital R cube. This is inside. Sir, inside means inside at any point. Okay, at this point, let's suppose at what distance? R distance. R is variable, bro. For center point, R is 0. For surface point, R is capital R. For outside, I would say for outside point, I would say R is greater than capital R. For inside point, I would say R is less than capital R. Absolutely, sir. Without a shadow of doubt, I can say this will be outside. Sorry, this will be surface. This is going to be outside. And this is going to be inside. Please tell me in the chats if this is clear. Negative sign I am using because field direction is towards the mass. That's why for that I am using negative sign. Field is towards the mass only. Field is field. If I say, sir, this is the mass, it is producing the field around it. What is the direction of the field at this point? Towards the mass. Okay. I believe this point is also crystal and clear. Okay. Guys, let's make the graph. Mod of I versus R. First of all, if you check inside, this field is directly proportional to small r. So if field inside, this is R is equal to 0 center. So from center, let's suppose this surface R is equal to capital R. From center to surface, I can say field is intensity is directly proportional to small r. Okay. And then, my dear NEET aspirants, this is the surface. And outside, it is inversely proportional to small r. Outside, it is inversely proportional to small r. Okay, so this will be outside. I is inversely proportional to small r square. This is outside. This is inside. Okay. Now, my dear NEET aspirants, since we take it negative, so this will be I versus R. Same graph, but will be from the lower side. Same graph, but will be from the lower side. Okay. Okay. Yes. I hope this is clear. Oh, guys, give me the signal in the chats. We'll move on to the next topic. We will move on to the next topic. Come on. Give me the signal in the chats. We'll move on to the next topic. Okay, that's great. Now we have a ring. Gravitational field intensity due to a ring. You have a ring. The mass of the ring is actually m. The mass of the ring is actually m. Radius is r. You have to tell me, and what value of x over here is 0. Because as you move away from the center of the ring, x increases. You have to tell me field due to this at x distance. You have to tell me field due to this at x distance. Simple. I would say field due to this, that's what we call gravitational field intensity due to a ring on its axis. We have to find the field on its axis. Okay, yes. Now, my dear NEET aspirants, if I say field due to a ring on its axis, I can simply say in this particular case, field due to this ring on its axis will be, that is G. Okay, G is the universal gravitational constant. Then we say M is the mass of the ring. Then we say X is the distance where we have to find, upon, I would say R square plus X square whole raised power 3 by 2. R square plus X square whole raised power 3 by 2. Now, my dear NEET aspirants, can I say, if you move to the center of the ring, what will be the value of X? That is 0. So put the value of X is equal to 0. We say at center, value of X is 0. So I can say this gravitational field intensity will be Gmx. X will be 0. So field intensity at the center will be 0. Now, if I say case 1 is very close to the ring. Case 1 is very close to the ring. Now, my dear NEET aspirants, if this is the ring, radius is R. If I say very close to the ring, this will be X, very close to the ring. In this particular case, X is much less than R. And if X is much less than R, my dear NEET aspirants, we remember one thing. If this quantity is very small, its square will be more small. If this quantity is very large, its square will be very large, more large. So you are adding a very small quantity to a very large quantity. Will it create any difference? Absolutely not. It is like adding a bucket of water to the ocean. Ocean has got billions of liters of water. If you add one bucket of water to the ocean, it will not create any difference. So I can say in this particular case, my dear NEET aspirants, so this will be, we can neglect this over here. So I can directly write gravitational field intensity will be gmx upon, I would say, r square whole raised power 3 by 2. You can write it like this. Now guys, this 2 and 2 will be cancelled. So this will be gmx divided by r cube. This is the gravitational field intensity due to a ring very close to the ring. If I say next case very far from the ring, this is the ring, its radius is r. Okay, well, let me make it a bit small. This is the ring, its radius is r. Very far from the ring, this is x. Now here x is much greater than r. So here in this particular case, which one will you neglect? R is small as compared to x. You will neglect r. So you will be writing over here I is equal to gm x upon. Sir, in the numerator we don't have to neglect x. No. Why? Because that is in multiplication. If the small quantity is in addition or subtraction, then you neglect. I would say r square plus x square. R you neglect, so it will be x square whole raised power 3 by 2. Now what you can cancel over here, 2 and 2 will be cancelled. So I will be equals to gmx divided by x cube. 1x and x square remains over here. So I will be equals to gm divided by x square. Please tell me in the chats if this is crystalline clear. Guys, quick, tell me in the chats if this is crystalline clear. Gravitational field intensity due to a ring on its axis, very far and close to the ring. Yeah, negative also. In every case, we'll be mentioning negative. Because it is at every point, it is towards the ring, na? That's why. Okay. Now, if you have to make the graph, guys, see. I mod of I versus R. When I say mod of I means I consider I positive. So when I say I, graph will be similar but from the lower side. Just do that. Just do that. See guys, very close to the ring. Take a look. Very close to the ring. I is directly proportional to X. I versus X we are supposed to make. I versus X. I is directly proportional to X. And very far from the ring, if you say I is inversely proportional to X square. I is inversely proportional to X square. Okay. 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 Now, my dear NEET aspirants, in this particular case, listen to me very carefully. Listen to me very carefully. We say very close to the ring. Sir, here value of X is 0 means center of the ring. So very close to the ring, graph would be like this. I is proportional to X. Very far from the ring, graph would be like this. Okay. I is inversely proportional to X square. Join the two with a smooth curve. This will be the graph over here. This will be the graph over here. This is the graph. This is the gravitational field intensity due to a ring. This is the graph between I versus X. Okay, here it is mentioned. Now let's move on to the concept that is what we call acceleration due to gravity. This is important. Acceleration due to gravity. See guys. My dear NEET aspirants, I want you to understand this very carefully. I want you to understand this very carefully. Oh, gravitational field intensity is nothing but it is field only. We say, sir, there is a mass, it creates the field around it. Now, how much intensity it will have, how strong field it will have at this point, we gave that name as gravitational field intensity. Intensity means the amount of strength How stronger is the electric field? Don't get confused. It is same. It is same. Okay. Now, guys, listen to me very carefully. What does acceleration due to gravity actually mean? Let's suppose this is Earth. Its mass is m. The topic is acceleration due to gravity on the surface of Earth. Let's suppose this is Earth. You have got Earth over here. Okay. And there is the object which is present on the surface of Earth. Okay. Now, if I say, or we say above the surface of Earth, just like here. If I say, what is the force acting on this mass? You say force acting on this mass is simply force acting on this mass is simply F is equal to, I would say, G, mass of Earth, mass of that M divided by R square. Now we have studied when there is force, there is acceleration. We say, sir, acceleration is force divided by mass. So we say acceleration is force is G capital M small m divided by R square divided by mass. This and this will cancel. So this is the acceleration Gm divided by R square. Can I say this is the acceleration due to this gravitational force? Obviously, acceleration is force by mass. Which force you are putting over here? Gravitational force. We say this is the acceleration due to gravity. This is the acceleration due to gravity. Where is the object placed? Surface. On the surface of Earth. On the surface. This is the acceleration due to gravity on the surface of Earth, my dear NEET aspirants. Okay, yes. Now, what if I tell you in this particular case? Listen, guys, what if I tell you in this particular case? What is that? That is, we represent this acceleration due to gravity on the surface of Earth with G naught. With G naught. So, can I say this G naught is equal to G m divided by R square? This is the acceleration due to gravity on the surface of Earth. And when you put the value of G, universal gravitational constant, when you put the value of mass of Earth, when you put the value of radius of Earth, you will get the value of this G naught as 9.8 meter per second square. 9.8 meter per second square. Okay. Okay. Is this clear, my dear NEET aspirants? Is this clear? Is this clear? Now, guys, listen to me very carefully. This is the acceleration due to gravity in terms of mass of Earth. Please listen very carefully. I'll not be deriving this over here because it is just going to waste our time. Okay, it is just going to waste our time. See. So we got this acceleration due to gravity over here in terms of mass of Earth. Now, if I say acceleration due to gravity, guys, listen carefully. Acceleration due to gravity on the surface in terms of density of Earth. In terms of density of Earth. Now, guys, see. This acceleration due to gravity on the surface of Earth in terms of density is 4 by 3 pi. G is the universal gravitational constant, density of Earth, okay? And then we say radius of Earth. Don't ask me, sir, how did you get this expression? There is a derivation for this. I am not going to do that. Please do remember it directly. Please do remember it directly. I hope this is crystal and clear to each and every single student. Now, guys, see. You got two expressions of acceleration due to gravity. In terms of mass, you have got this G me by Re square. In terms of density, you got this. Absolutely, sir. Absolutely, sir. Now, here you see this acceleration due to gravity is directly proportional to radius of Earth. This acceleration due to gravity is inversely proportional to radius. Sir, which one is correct? Both are correct. Let me show you. In this graph, I have discussed both. See. I'll explain here. When I say G naught is equal to 4 by 3 pi rho e G, and then we say RE. Let's suppose if in a question, you have a question, if we say if density is given as constant, let's suppose you are given two planets. I'll show you the question after some time. Please listen now. If you are given two planets, the density of the planets are constant. Then in that particular case, if density is constant, this 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 becomes the direct relation. We say G naught is directly proportional to the radius of a radius. I'll write radius. So in that particular case, my dear NEET aspirants, graph is going to be the straight line. G naught is proportional to radius, graph is going to be the straight line when density is constant. And second one is, we say G naught is equal to Gm divided by R square. We say, let's suppose mass of the two planets is constant. In that particular case, G naught becomes inversely proportional to radius square. In that particular case, graph is going to be this, that is this one. It depends upon the condition. I'll show you the question also. Before that, please let me know in the chats if this is crystalline clear. Come on, guys. Quick. I want you guys to tell me if this is crystalline clear. Quick. Tell me. I'll show you the question also. Don't worry. Is this clear? Let's take a look at the question. This will clear the confusions out. See, this is the question. What does the question say? Take a look. Two planets having same density. You have two planets, this one and this one. Density is same, but different radii. The acceleration due to gravity would be, tell me now, if density is same, acceleration due to gravity is directly proportional to radius. Now, what would you say? The one which has got small radius, the planet which has small radius, acceleration due to gravity would be small. The one which has got large radius, acceleration due to gravity will be large. What does it say? Greater on larger planet, absolutely. Same on both the planets, no. Greater on smaller, no. So which option is correct? Option C. Okay, so for notes, guys, join my Telegram channel. That is I'll mention over here. My Telegram channel and all the updates is t.me/Yawar Manzoor. t.me/YAWARMANZOOR. This is my Telegram channel. You can join this Telegram channel so that you get all the questions, updates. Okay, I'm placing it over here. Now let's take a look at this question. A planet has same density and same acceleration due to gravity as that of Earth. Okay. There is a planet. This planet. Okay. There is one more planet. This is Earth. This is planet. The planet has same density and same acceleration due to gravity. So means this acceleration due to gravity of planet G is equal to acceleration due to gravity of Earth. Okay, density of planet is equal to density of Earth. And universal gravitational constant G is 2 times that of Earth. Okay, G of planet is 2 times G of Earth. This is the, now if you say, sir, G is same everywhere. In question, if they are saying G is 2 times of Earth, assume it. Okay. Then the ratio of radius will be radius of planet divided by radius of Earth. This is what you are supposed to find. Now, first of all, you tell me which equation will you prefer? Guys, I have recently told you 2 equations. This one and this one. Which one will you prefer? A density one, obviously. Why? Because density is given as constant. So if density is given as constant, my dear NEET aspirants, we say density is constant. If density is constant, you'll simply say, guys, you say acceleration due to gravity is going to be, that is 4 by 3 pi g rho, and then we say radius, this formula. Now in this particular case, the one which is constant, eliminate that. 4 by 3 is constant, pi is constant. Okay, density is also constant, radius is also constant. In this particular case, I would say G naught over here is constant. I would say G naught over here is constant. I would say G naught over here is constant. Okay. G naught is given as constant. Okay. In this particular case, just a second. Okay. Now, guys, let's get back to the question. So G is given as constant. G naught is given as constant. Okay. Density is also constant. Okay. Constant. Now, my dear NEET aspirants, can I not say in this particular case, guys, this is constant, this is constant, this is constant, this is constant. Eliminate these two constant, these four constants. Now, this and this will be having relation. So we can say here, G into R is equal to constant. Yes, absolutely. So can I not say this radius will be inversely proportional to universal gravitational constant? Absolutely, sir. Now tell me what I can say in this particular case, guys. Radius of planet divided by radius of Earth. Can I say in this particular case, radius of planet divided by radius of Earth? What I can write over here, we say gravitation, radius of planet is, I can say, guys, we say it is inversely proportional to universal gravitational constant. So instead of radius of planet, we can write 1 upon 2 times of GE. Upon 1 upon, I can say GE. Because this and this are having inverse relation. So can I say in front of this, we can write 1 divided by G. In front of this, we can write 1 divided by GE. This is GP. And instead of GP, I am writing 2 times of G. Okay. Now, what you can do in this particular case, this will come out to be here, this and this will cancel. So what is going to be the answer? 1:2. Please tell me in the chats if this is clear. Tell me, guys. Is this clear? Tell me, everybody. Is this clear? Shall we move on to the next? I hope acceleration due to gravity is clear. Now, guys, this is important. Please listen to this very carefully. Give me your 100% attention now. Acceleration due to gravity above the surface of Earth. Till now, we were studying surface of Earth. Now, if you go above the surface of Earth at height h, guys, what is the acceleration due to gravity on the surface of Earth? We say gm divided by r square. Now, if you go above the surface of Earth, now what is going to be the distance? R plus h. So you'll be writing gm upon r plus h whole square. Simple basics. In terms of G naught, Okay, listen. We recently studied g naught is equal to, this is acceleration due to gravity on the surface of Earth, gm divided by r square. Now take it over here. G naught into r square will be equals to gm. Absolutely, sir, without a shadow of doubt. Now can you put this over here? So what will you get? You'll get from this, you'll get, sir, this gh will be equals to, instead of gm, what will you write? G naught into r square divided by r plus h whole square. That is mentioned over here. Simple, simple, simple. No complications, no complications at all. So basically, you'll be directly remembering, at height h, if mass is present, acceleration due to gravity will be, we say gm by r plus h whole square. In terms of g naught, it is going to be g naught into r square upon r plus h whole square. Already calculated. Now, my dear NEET aspirants, please, please, if I say this height is much less than RE, height is much less than RE. Okay, now in that particular case, guys, height is very small. Height, what is radius of Earth? Radius of Earth is 6,400 kilometers. If you say height is 5 meters, 10 meters, 1 kilometer, up to 5 kilometer, we say height is much less than RE. Okay, now see, this height is very much small than RE. Can I neglect this h? Absolutely, sir. Can I neglect this h? Absolutely, sir. So what will you get in that case? GH will be equals to, guys, G naught into r square divided by h will be neglected, r square cancel. It is G naught. Sir, amazing, sir. Means if height is much less than RE, in that particular case, acceleration due to gravity at height h will be same as the acceleration due to gravity on the surface. Oh. Sir, amazing. Crystal clear, sir. Crystal clear, sir. Now, my dear NEET aspirants, see. Second case, when height is much less than RE. First one was much less than RE, means height was 0 meters to 10 kilometers. 0 meters to 10 kilometers. Okay. Now, my dear NEET aspirant, if I say height is something 16 kilometer, 32 kilometer, because we say a radius of Earth is 6,400 kilometers. Okay. If I say height is 16 kilometer, we say 32 kilometers, 64 kilometers, or 128 kilometers, something like that up to this. This is the case. Please remember directly, I will not be deriving. Acceleration due to gravity at this height will be g naught into 1 minus 2h by r. G naught into 1 minus 2h by r. This is valid only when your height is between 10 kilometers to 500 kilometers. Please tell me in the chats if this is clear. Please tell me in the chats if this is clear. Please tell me in the chats if this is clear. Is this clear? Oh, give me the signal in the chats. Everyone means everyone. Quick. Yes, in the first case, radius is much lesser. In the second case, radius is lesser than, much lesser than. Now, percentage change in acceleration due to gravity. See, what does it say? See. Let's suppose if I say object is on the surface. If I say object is on the surface of the Earth. If I am saying I am taking this object, I am taking this object to some height h. Okay. Here acceleration due to gravity is g naught. I am taking this object to the height something h. How many percent in percent acceleration due to gravity will change? Sir, when you take the object here, we say 5% acceleration due to gravity will change. So here it was G. Here 5% acceleration due to gravity will increase or decrease. How many percent it will change in terms of percent? You'll get to understand right now. Please do remember this, because I'll be showing, once I show you the question on this one, you'll be able to understand. So percentage change in acceleration due to gravity at smaller height will be, that is delta G divided by G naught into H. This is called percentage change in acceleration due to gravity. Percentage change in G. Percentage change in G means how many percent G will change when you change the height. Because acceleration due to gravity changes when you change the height. So if you increase the height, acceleration due to gravity will change. How many percent it will change? 5%, 10%, 20%. That can be calculated using this formula. Minus 2h by r. H is the height, r is the radius of Earth, and this is 100. 100 is which comes after 99. That is 100. Is this clear? Please tell me in the chats. Is this clear? Please tell me in the chats. Okay, let's take a look at this question, guys. Let's take a look at this question. Let's take a look at this question. This will make you understand over here every single thing. See. At what height above the surface of Earth? At what height above the surface of Earth, the value of acceleration due to gravity decreases by 2%. Listen. At what height? See guys. Let's suppose on the surface of Earth, acceleration due to gravity is G naught. Now you are taking this object to some height. With this question, you will understand. You are taking this object to some height, let's suppose h. And how much is the decrease in? It says value of, okay. How much is the decrease in G? Acceleration due to gravity decreases by 2%. 2% decrease in acceleration due to gravity. What will be the value of this height? At what height acceleration due to gravity decreases by 2%? We recently studied the formula. What is the formula? Delta G by G into 100 is equal to minus 2h by r into 100. We say delta G divided by G into 100 is equal to minus 2h divided by r into 100. So what does this minus actually represent over here? Minus says if you increase the height, acceleration due to gravity will decrease. That is the significance of minus here. Now, how much is the percentage change in G? Percentage change in G means delta G by G into 100. This is given as 2%. Because decrease in the G, that is called percentage change in G, that is given as 2%. This is 2% is equal to minus 2h by r into 100. Okay, 2h divided by r into, I can say 100 over here. This is 2%. Now guys, in this particular case, this is 2 and 2 will cancel. Okay. So radius of Earth, this is radius of Earth is 6400 kilometers. So this will be over here 6400 is equal to, this will be h into 100 in this particular case, 0, 0, 0, 0. So h will come out to be 64 kilometers. So if you go at a height of 64 kilometers, acceleration due to gravity will decrease by 2%. I hope this question has cleared all the confusions out. Now, there is a question. I would want you guys to solve this particular question. See, a body weight 144 Newton at the surface of Earth. See guys. This is the surface of Earth. This is the surface of Earth. Okay. This is the surface of Earth. Weight of the body. What does weight actually mean? Weight means mg. I have told you this in the Newton's laws of gravitation. Weight means the gravitational force with which Earth attracts the objects. That is mg. So mg on the surface of Earth, it is given as 144 Newton. Weight at the surface of Earth is 144 Newton. When it is taken to a height of h is equal to 3r, If you take this to a height of h is equal to 3r, here, h is equal to 3r. If you take this mass to a height of h is equal to 3r, my dear NEET aspirants, where radius, r is the radius, its weight would be, it says what will be the weight over here? That will be m into g dash. Array, sir, I'll write g, not g dash, m into gh. Because if weight is mg, on the surface it is m into g naught. At height h, it is m into gh. Yes or no? Now tell me, how can I write this? You'll be saying, sir, this is m into gh. What is the acceleration due to gravity above the surface of Earth? I have recently told you, my dear NEET aspirants, when it comes to the acceleration due to gravity above the surface of Earth, how much is that? That is g naught into r square upon, I would say, r plus h whole square. Acceleration due to gravity above the surface of Earth, na? Here, this one. G naught into r square into r plus h whole square. Yes. Now tell me what I am going to write over here. Now guys, what is the value of m into g naught? M into g naught is 144. So I'll be writing over here, instead of mg naught, 144 r square divided by r. R is the radius of Earth, plus h. At what height you are taking it? 3r. H is equal to 3r. So 3r wholes, okay, h is equal to 3r. Then it is whole square. Okay, what I can write in this particular case, 144 r square divided by, this is 4r whole square, that will be 16r square. 144 divided by 16, that is 9 Newton. So weight of this object at height h is equal to 3r would be what? How much? That is 9 Newton. That is 9 Newton. Tell me guys, is this clear? Is this clear? Give me the signal in the chats if this is crystalline clear to each and every single student. Come on guys, and smash the like button if you are not liked the session yet. Okay, now acceleration due to gravity below the surface of Earth. Acceleration due to gravity below the surface of Earth. So my dear NEET aspirants, when you say acceleration due to gravity below the surface of Earth, means this is the Earth. This is the surface. Below the surface of Earth at depth d, this is the depth d. If you place, okay, at depth d, or from the center, it is at distance r. Please. Below the surface of Earth at depth d, above the surface of Earth at distance r, small r. And this is the radius of Earth, that is capital R. Can we write one thing over here? This radius of Earth is equal to small r plus d. Yes, sir, we can say. Now at this point, we are supposed to find acceleration due to gravity. See guys, this is the acceleration due to gravity below the surface of Earth. Okay, in terms of r. R is the distance from the center to that point. Okay, this is the acceleration due to gravity below the surface of Earth. Okay, at r distance from the center. In terms of r, it is mentioning. Okay. Now guys, my dear NEET aspirants, can I say, guys, how much is total capital R? How much is this D? This is D. So, okay, from this, could you please tell me what is the value of this R? That will be capital R minus D. So could you please put it over here in this one? So it will become gm upon r cube instead of small r, r minus d. This is the acceleration due to gravity at depth d. Sir, what is the difference between this formula and this formula? This is the acceleration due to gravity inside the Earth at r distance from the center. Please listen to my language. This is the acceleration due to gravity below the surface of Earth at depth d. Both are same, but language is different. Okay. In terms of G naught. Okay. Always remember, we say Gm is equal to G naught into R square. Okay. Now directly you mention over here, in terms of G naught, you can write acceleration due to gravity below the surface of Earth. It is G naught 1 minus d by r. D is the depth from the surface to that point, r is the radius, r is the radius, r is the radius, r is the radius. I hope this is crystal and clear to each and every single thing. Okay, guys, this is the surface of Earth. Okay, this is the surface of Earth. We say at depth d, what is the acceleration due to gravity? What is the acceleration due to gravity? Sir, at depth d, this is the acceleration due to gravity. Sir, from the center to distance small r, what is the acceleration due to gravity? This is the acceleration due to gravity. Okay, okay. In terms of g naught, g naught means acceleration due to gravity on the surface. This will be the acceleration due to gravity. Directly remember, I'll show you the questions. Percentage change in g. Sir, let's suppose, see. Let's suppose an object is placed on the surface. If you take it to the depth d, how much percent will be the change in acceleration due to gravity? How many percent will be the change in acceleration due to gravity? That is what we call percentage change in acceleration due to gravity. And here it is equal to delta g by g into 100 minus d by r into 100. So this will be the percentage change in g. So over there, percentage change in g was different above the surface of Earth. Below the surface of Earth, it is going to be different. Below the surface of Earth, it is going to be different. I hope this is crystal and clear. Now guys, take a look. Now guys, take a look in this particular case. Take a look. If the radius of Earth shrinks by 1.5%, okay, radius of Earth shrinks by 1.5% means radius of Earth decreases by 1.5%. Then the value of acceleration due to gravity changes by, see here we need to develop the equation. Listen to me very carefully. Guys, see, we say as, what is the acceleration due to gravity on the surface? We say gm by r square. Absolutely, sir. Okay. Now, if I say, how do we find the percentage change in g? Always remember, if I say y is equal to x, y is a physical quantity which depends upon x. If x changes, y changes. How do we find the percentage change in y? Like this, we write delta y by y percent. This is called percentage change in y. It will be equals to, that is delta x by x into, we say 100. This is called percentage change in x. So if x changes, y changes. Now if I say y is equal to x raised power n, how do you find percentage change in y? Delta y by y percent will be equals to n down, power down, delta x divided by x into 100. This is called percentage change in this. Now, my dear NEET aspirants, let me move these to the side. Okay, yes. Now, here in this particular case, we say this g is proportional to r square, inversely proportional to r square, because it says radius of Earth shrinks by 1.5%, mass remaining the same. If mass is same, g is same, so both are constants. Remove these constants. So can I say, guys, g is proportional to r raised power minus 2? Absolutely, sir. Because if you take this in the numerator, this is very important, I'm showing you. Now find percentage change in g. Delta g divided by g percent will be equals to, here power down, minus 2 down, delta r divided by r into 100. This is the equation that I created over here. This is the equation that I created over here. Means, my dear NEET aspirants, we say this negative sign tells you if radius is decreasing, we say acceleration due to gravity will increase. If radius is increasing in this, because it is minus percentage change in g. So in this particular case, guys, what does the question say? If radius of Earth shrinks by 1.5%, radius of Earth, how much is the percentage change in radius? 1.5%. So what is given? Delta r by r into 100. Its value is 1.5%. Now tell me, how can I find percentage change in g? So I can say percentage delta g divided by g, it will be equals to minus 2 delta r by r into 100. So that will be 1.5%. Okay. So 2 into 1.5% is how much, my dear NEET aspirants? Okay. Okay. So that will be 3%. So in this particular case, it will be 3%. Is this clear? Please tell me in the chats. Okay. Is this clear? Is this clear, guys? Tell me. And most importantly, my dear NEET aspirants, listen to me very carefully. It says delta R by R. Guys, radius shrinks by 1.5%. So delta R by R, you need to take negative over here. Okay, I forgot to take negative. So this is also negative. Because if radius is decreasing, my dear NEET aspirants, so we say this and this will negative and negative will be positive. So this will be positive, I would say something like this. Is this clear? Is this clear? This is percentage delta G divided by G. Yes. Plus 3. Sorry, plus 3. Because if it says radius is shrinking, shrinking means radius is decreasing. So decreasing radius means negative we need to take. So delta R by R into 100 is negative. So negative into negative is positive. Let's take a look at this question. If the density of the planet is doubled than that of the Earth, the radius of the Earth is 1.5 times that of the Earth. The acceleration due to gravity on the surface would be. Okay. If the density of the planet is doubled than that of the Earth, there is a planet, its density is doubled. Okay. Okay. See, if the density of the planet is doubled, this is a planet. I'll make it over here. This is a planet. This is Earth. This is planet. This is Earth. Density of planet is 2 times density of Earth. Then what does the question say? And radius is 1.5 times that of Earth. A radius of planet is 1.5 times a radius of Earth. The acceleration due to gravity on the surface of the planet would be. Acceleration due to gravity on the surface of the planet would be. Now guys, listen carefully. What is the acceleration due to gravity on the surface of Earth? Tell me quickly. You say, sir, it is 4 by 3 pi g rho and then we say r. Okay. If I say what is the acceleration due to gravity on the planet? 4 by 3 pi g. Density of planet, a radius of planet. Absolutely. So you'll be saying, sir, this will be 4 by 3 pi g. What is the density of planet, my dear NEET aspirants? That is 2 times density of Earth. What is the radius of planet? That is 1.5. 1.5 means 3 by 2 times a radius of Earth. Arey, 1.5 is given na? Check here na? 1.5 means 3 by 2. Okay. Now, what can you cancel in this particular case? 2 and 2 you can cancel. So, acceleration due to gravity would be. Okay. Take this 3 out. It would be 4 by 3 pi g rho e r e. So, what is this? This is acceleration due to gravity on the surface of Earth. So, of planet, it will be 3 times of g naught. I hope this question is also clear. On the planet will be 3 times of gravitational planet on Earth. Okay. Now guys, tell me the answer of this question. At what depth below the surface of Earth is the value of g same as the height this? Okay. Tell me guys. This is a question. Okay. So this I'll keep you as homework. This is simple. Please do check it from your end. This is your homework. Now, okay. Acceleration due to gravity, graph of g versus small r. Acceleration due to gravity versus small r. Okay. See guys, I want you to understand this very carefully, very carefully. I'll make you understand this. Let's move on to the acceleration due to gravity over here. Okay. Yes. See guys, take this formula. This is acceleration due to gravity below the surface of Earth. Okay, from the center we are starting. Okay, yes. Now take this formula. What is the relation between acceleration due to gravity and small r? Sir, acceleration due to gravity is directly proportional to small r, and it is inside the earth, inside the earth. Absolutely cool, sir. Now come on to outside. See guys, this is h and this is ra. Can I write this as total of small r? A small r is variable, bro. So for outside point, small r would be re plus this h. So r would be r plus this h. So can I write this formula as gh is equal to g naught into re square divided by, I can say, or I can write it over here only. Just a second. So here we say gm divided by, I can say, r square. Or here I can write g naught into re square divided by, I can say, r square. So outside, can I say this acceleration due to gravity is inversely proportional to small r square? And come here, again. Inside, this g naught is directly proportional to small r. G naught is directly proportional to small r. Okay. Now, my dear NEET aspirants, how am I supposed to make the graph? See, if I say inside it is directly proportional to small r, outside it is inversely proportional to small r. Oh, yes or no? Yes. Okay. So can I not say in this particular case, my dear NEET aspirants, if I make the graph between g versus small r, this is the center. From center to surface, this will be inside Earth. From center to surface. So graph is going to be the direct straight line because it is directly proportional. Outside, I can say this g is inversely proportional to this r square. It is rectangular hyperbola. Please give me the signal in the chats how many of you understood this. Please give me the signal in the chats how many of you understood this. Is this clear? Oh? Is this clear? So this is the graph between acceleration due to gravity versus r, and this graph is extremely important. It was asked many times in JEE. Sir, can we consider Earth as a solid sphere? Do you think you will consider it as a hollow sphere? Obviously solid sphere, na? And that's what we do actually. Gravitational potential energy. Okay. Now, today I will give you the feel of gravitational potential energy. That is going to be something amazing. You are going to love it. That is for sure. See, okay. Let me just give you the feel of gravitational potential energy. Gravitational potential energy like never before. Gravitational potential energy like never before. Okay. See, guys, understand this very carefully. Understand this very carefully. At least before our break, we need to finish two chapters, gravitation and solids. That is my goal. Let's see how it goes. As of now, just keep studying. I'll give you the break at the proper time. My dear NEET aspirants, listen to me very carefully. Let's suppose if I say I have got a mass over here. Okay, yes. You are lifting this mass to this height h. Now, could you please tell me in this particular case, are you doing any sort of work? Absolutely, sir. Who is lifting this object mass m to height h? Sir, it is me. Who are you, external agent? You are using your own energy. Sir, I am lifting this object to the height h. I am using my own energy. Now, will that energy go into the waste? No, sir. That will be stored in the form of potential energy. So we say here its potential energy is 0. At its topmost point, its potential energy will be mgh. So this potential energy was stored because of the work done. So we say, sir, work done is equal to change in potential energy. When you did the external work done, when you applied the external force over here, okay, and mg is in the downward direction. When you, guys, whatever I am saying over here, just remember that. Don't be like the physicists, sir, where does this come from? Where does that come from? Now is not the time. I'm finishing 6, 7 chapters in one go. So if I say at this point of time, you need to remember this, you have to remember this. These questions you can ask in the regular class. Okay, not right now. And one more important thing. If I say something, remember means remember. Okay, because I'm going like in a crispy manner. Okay, I'm telling you every information, but in a crispy manner. So if I say at some point you remember this, it is going to help you remember that. So if I say, my dear NEET aspirants, at this point of time, if I say at this point, if I say, if you take this object from this point to this point, are you doing any sort of work? Absolutely, sir, I'm doing work. Work done by external force. Due to that work done, you see potential energy was 0. Now it is mgh. Potential energy has changed. So we can write it like this. Work done is equal to change in potential energy. Now this is the work done by external agent. When work is done by external agent. Now what is the force acting in the downward direction? Mg. It is opposite to this. So we say here, this external force is exactly equals to mg. Whatever is the work done due to external agent, same will be the work done due to mg, but we consider it negative. Okay. Yes, sir. So work done by external agent, you will be saying positive of change in potential energy. Work done by conservative force or mg will be negative of change in potential energy. Just remember, because they are opposite. This we have studied in work, power and energy. Since we are into the gravitation, now let's move on to the gravitation. See, guys, let's suppose you have a mass m over here. This is m1. This is mass m2. This is at infinity. Now, if I am saying you bring this mass from infinity to this point at r distance, you bring this mass from infinity to r distance. So when you bring this mass from infinity to r distance, listen to me very carefully, my dear NEET aspirants, you'll have to do the work done. While you were bringing, this was the gravitational force, because, guys, this is attracting this mass towards itself with the gravitational force. So you always apply the external force opposite to the gravitational force. Okay, so like here, gravitational external is upward, gravitation is downward. Same here. Gravitation is this, external is this. So in this particular case, you brought the mass from infinity to r distance. Here its potential energy is going to be UR, and here its potential energy is going to be U infinity. At infinity, we assume it's zero. We assume it's zero. So the work done in taking the mass from infinity to r distance, will that go into the waste? No, that will be stored in the form of potential energy. Okay, so I'll write this. The work done, the work done in bringing the mass from infinity to r distance is stored in the form of potential energy. And if I say, guys, if I say, sir, from here to here, when you took the object, how much potential energy is stored? mgh. If I say, how much potential energy is stored here when you take the mass from infinity to r distance, you say at r distance, potential energy is going to be, that is minus g m1 m2 divided by r. This is the potential energy stored at r. Now, what was the potential energy stored at potential energy as infinity? Zero. When you brought the mass from infinity to r distance, is the potential energy changed or same? Sir, it is changed. So how can I say due to the external work done here also potential energy is changed? Absolutely, sir. 100%. And guys, we say this external force is in this direction, gravitation is opposite. Whatever is the work done due to external, same will be due to gravitation, but it is opposite. So we say here in this particular case, external force is equal to, I would say, gravitational force. So my dear NEET aspirants, I can say in this particular case, can I not say work done by gravitational force means conservative force? Okay, directly remember conservative force. It is negative of change in potential energy. Please, I need the signal in the chats if this is clear. Guys, I need the signal in the chats if this is clear. These are the only two equations that you need to learn in this one. Tell me quickly. Is this clear? Come on, guys. Is this clear? We'll take the break at 7 o'clock, okay? At 7, we'll take the break. Is this clear or tell me in the chats? Now, my dear NEET aspirants, listen to me very carefully. Listen to me very carefully. In this particular case, I would add few more points over here. What is that? Listen, guys. let me make you this understand. See, in this particular case, what I am saying over here is, listen guys, what I'm saying over here is, we say, this is the work done by conservative force. If you do, see, if you bring, just a second, let's suppose this is one mass, this is another mass. If you bring this mass from here to here, you have done a large work. If you bring this mass from here to here, you are doing a small work. From here to here, work is large. From here to here, work is small. So can I say if you do the small work done, there will be small change in potential energy? So I can say due to small work done, there is, due to small work done, there is small change in potential energy. So how do you write the small work done? Small work done will be dW is equal to small change in potential is minus du. And if you say what is the formula of work done, small work done, it is, how do you write the work done, sir? Force, okay. So we say work done is equal to force into displacement into cos theta. Small work done will be force into small displacement, and then we say cos of theta. Okay. Yes. Now let's suppose cos theta is 0. So dW in this particular case will be FDS. Yes. So my dear NEET aspirants, it will be force into small displacement is equal to minus du. So can I say in this particular case, my dear NEET aspirants, this F will be equals to minus du divided by ds? Absolutely, sir. Minus du by ds. So this is what we call a relation between force and potential energy. Even from this equation you can get, one more thing. That is integrate both sides. So when you integrate both sides, you will get integration of f ds will be equals to integration of minus du. So take this minus over here. So integration of du will be delta u is equal to minus integration of f ds. So this is change in potential energy, my dear NEET aspirants. So change in potential energy is equal to integration of force into displacement f ds. I hope this is also crystal and clear. These two equations are also important. Now, since we got the equation over here, when you bring the mass from infinity to r distance, how much is the potential energy stored between the two masses? Minus g m1 m2 by r. Let's do one thing. So you'll be remembering from now onwards, if you have m1, if you have m2, distance between the two is r, potential energy will be g m1 m2 divided by r. This will be the potential energy between the two. Now guys, let's talk about this particular question. You have to find the net potential energy of the system in this particular case. What is the net potential energy of the system? You have over here mass m, m, m and this m. What is the net potential energy of the system? Guys, first you need to write potential energy between these two, then between these two, then between these two, then between these two, then between these. Okay, diagonal pair will be 2 and on the corners there will be 4. Let's find potential energy between these two masses. We can write this will be G m1 into m2. M into m becomes m square divided by what is the distance between the two? That is L. So this is L square. G m square by L square. Now how many pairs are there? Side pairs, I would say 4. So I'll write over here 4 gm square by L square. Okay, 4 gm square by L square. Now my dear NEET aspirants, in this particular case, what I am going to do is that, how many diagonal pairs are there? Sir, 1 and 2. Okay. Oh, it is not L square. Sorry. Okay. It is just L. Now plus, and this is minus. Diagonal pair is G, this M1, this M2. That is M into M becomes M square divided by How much is the diagonal, guys? If this is L, diagonal is root 2L. So it is going to be root 2L. And how many diagonal pairs are there? There are two diagonal pairs. That's why I'm mentioning two over here. There are two diagonal pairs. This will be the net potential energy of the system. If I say what is the net potential energy of this system? Sir, this is M, this is M, this is M. This is side A, this is side A, this is side A. When I say net potential energy of the system, it will be between these two, I can write G. M into M becomes M square divided by, I can say A minus. Between these two, don't you think there will be similar potential energy? Yes. Between these two, don't you think there will be similar potential energy? Yes. So how many pairs are there? There are three pairs. So I can write over here 3 times of Gm square by A. This is the net potential energy over here. Okay, one more important question which I want to show you over here. Guys, see, 4-point objects placed at a corners, 4-point objects placed at a corner of a square. Okay, 4-point objects placed at the corner of a square. This is the square. This is M, this is M, this is M, and this is M. And then it says, fifth mass is at the center. This is the fifth mass which is at the center. Find the work done in taking this mass from center to infinity. If we take this mass from center to infinity, how much work is to be done if we have to take this mass from center to infinity? Now, my dear NEET aspirants, I told you, whenever you have to find the work done, you find change in potential energy. Because work done, we recently studied change in potential energy. Can I say work done will be final potential energy minus initial potential energy? So finally it is at infinity, so final potential energy is going to be 0. Okay, let's talk about initial potential energy. Guys, see, initially this mass is at center. If this side is A, how much will be this distance from center to this? This will be A by root 2. Half of the diagonal is always A by root 2. So when this was at center, potential energy will be created between this and this, between this and this, between this and this, between this and this. So let's write this potential energy. That will be G. M into M becomes M square divided by, how much is the distance between the two? A divided by root 2, and it is minus. Now, how many times, sir? 4 times, because 4 pairs are created. So you'll be saying in this particular case, it will come out to be, take this in the numerator, it will become minus 4 under root 2 G M square divided by A. Now guys, final potential energy in this particular case will be 0, minus initial potential energy will be minus 4 under root 2 G M square divided by A. So this will be 4 under root 2 G M square divided by A. This is going to be the work done. So guys, what I'm trying to say is that whenever you have to basically find the work done, you find change in potential energy. You find change in potential energy. Keep that thing in your mind. Keep that thing in your mind. Then we say gravitational potential. What does gravitational potential actually mean? Let me make you understand gravitational potential. See guys, what does gravitational potential actually mean? Okay. Okay. Let's understand gravitational potential. Okay. Is this clear till over here? Oh? Tell me in the chats, everybody out there. Tell me in the chats, is this clear till over here? Give me the signal in the chats. Is this clear till over here? Tell me. Okay. That's great. Guys, smash the like button if you're not liked this session yet. Quick. Okay, let's define gravitational potential. Everybody out there, listen to me very carefully. What does gravitational potential actually mean? See, guys, I'll make you understand. What does gravitational potential actually mean? Gravitational potential means it is the amount. Okay. See, guys. Let's suppose you have a mass over here, m. Okay, this is a mass m. And there is another mass m naught, but its value is 1 kg. Okay, its value is 1 kg. So when its value is 1 kg, we call it unit mass. Unit mass. Okay. Now it is placed at infinity, and at infinity potential energy is 0. If I want you guys to bring this mass from infinity to r distance, somewhere around over here, infinity to r distance, you bring it over here, this m naught. So while bringing this mass from infinity to r distance, you will have to do some work. That work will be stored in the form of potential energy. Okay. And that potential energy at r distance will be g m1 m2 divided by r minus g m1 m2 by r. So this will be u is equal to minus g, value of m1 is m, value of m2 is, how much is m2? 1 kg, that is 1, m naught, it is 1 kg divided by r. So u is equal to minus g m divided by r. Now this potential energy in bringing 1 kg mass from infinity to r distance, this is what we call potential. This is what we call potential. If you bring 1 kg mass from infinity to r distance, if you bring 1 kg mass from infinity to r distance, the potential energy which will be stored, that is going to be this much. This potential energy is named as potential. So can I say, guys, can I write it like this? It is the amount of work done by the gravitational force in bringing a unit mass from infinity to that point. How much amount of work you did in bringing a unit mass, that means 1 kg mass, from infinity to that point, that is called potential. So can I say, sir, potential is nothing but potential energy? Absolutely. But potential energy of 1 kg mass, that is the potential energy of 1 kg mass. Okay, so on bringing this mass from infinity to this point, okay, so we say potential energy is minus gm by r, and this is what we call potential. This is the potential energy of 1 kg mass. Okay, this is the potential energy of 1 kg mass. So one more important thing I just want to make you understand over here. So from now onwards, you'll be saying potential due to mass is minus gm divided by r. Potential due to a mass is minus gm by r. And one more important thing, guys, you can write potential. Potential is nothing but potential energy per unit mass. U divided by m. Potential energy divided by mass. And if I say what is the potential energy, sir, G capital M, this M, m naught divided by r into this m naught. See, this and this will cancel, so v will also come out to be minus gm by r once again. So you can write it like this also. Okay, so if there is a mass at r distance, how much will be the potential? Sir, that is minus gm by r. Sir, is this potential a potential energy? Yes, but in bringing how much mass? 1 kg mass. So in bringing how much 1 kg mass, the amount of potential energy stored will be the potential, Now guys, let's suppose you have this one. Let's suppose you have this question. If I say what is the potential energy of this mass at this distance? Okay, like you have 1, 2, 3, 4. You have to tell me what is the potential energy at the center. Guys, see. We say, what is the net potential at the center? It will be simply, listen carefully. Due to this mass, potential at the center is going to be simply minus gm divided by, how much is this distance, by guys? This will be L divided by root 2. That is L divided by root 2. Now similarly, due to this mass also it will be minus gm upon L by root 2. Due to this mass also it will be minus gm by L by root 2. Due to this mass also it will be minus gm by L by root 2. So can I not say in this particular case it will be multiplied by 4 times. So it will be minus 4 root 2 gm upon, I would say, L. This will be the net potential at the center due to this. Okay, this is the net potential. Even you can find the gravitational field intensity at the center. Gravitational field intensity at the center will come out to be 0. Because that is a vector quantity. See guys. Listen, if you have this mass m, this mass m, this mass m, this mass m, at this point center point, gravitational field intensity is always towards the mass, which I told you recently. This is I. Due to this mass, it will be towards m. To this mass, it will be I. Due to this mass, it will be I. So this will be cancelled with this. This will be cancelled with this. So I can say net field intensity will be 0. But when it comes to the potential, my dear NEET aspirants, it is a scalar quantity. It does not have the direction. You simply have to add. Guys, tell me, is this clear? So simply you will be remembering potential due to a mass at r distance will be minus gm by r. Okay. Yes. Now this is a question. It's a very famous question. I want you guys to listen to this very carefully. See, what does the question say? Infinite number of bodies, each of mass 2 kg. Infinite number of bodies, each of mass 2 kg, are situated on x-axis at distance 1 meter, 2 meter, 4 meter, 8 meters. Okay. So guys, this is the mass over here. That is 2 kg. It is at 1 meters. This is another mass over here. Okay. This is 2 kg. It is at 2 meters. This is 2 kg. It is at 4 meters. Okay. This is another 2 kg. It is at 8 meters and so on. These are infinite number of masses. Now, my dear NEET aspirants, what does it say? Let's suppose they are all placed on x-axis. You are supposed to tell me what is the net potential at this point, at origin, 0, 0. Understand this. When it comes to net potential at the origin, see guys, we say net potential at the origin will be simply, what is the potential due to the first mass? Guys, it will be minus gm by r. G is G, mass is 2. We say G m by r. M is 2, r is 1. R is the distance from this point to this point. Then minus, what is the potential due to second mass? G into 2 divided by, from here to here it is 2. Then minus, what is the potential due to third mass? G into 2 divided by 4. Then minus G into 2 divided by 8. You can write it like this. Now in this particular case, what you can take common, guys, you can take common minus 2g. In the first term, it is 1 minus 1 plus 1 by 2 plus 1 by 4 plus 1 by 8 plus so on. Something like this. Now guys, can I write in this particular case, I want you to understand, this is what we call GP series. This is what we call GP series. Okay. So how do you find, you need to add these. How do you find the sum of GP series? Sum is A upon 1 minus R. A is what we call the first term. Okay. A is what we call the first term. And R, and what is the first term here? R is common ratio. How do you find the common ratio or common term? Take any term, let's suppose 1 by 4, divide it with the term which comes before it, that is 1 by 2. Take any term, divide it with the term which comes before it. 2 ones are 2 twos are, so it will be 1 divided by 2. Now, if I say sum is equal to A is 1 upon 1 minus R. R is 1 divided by 2. So it will be 1 upon 2 into 1 is 2. 2 minus 1 is 1 divided by 2. So take this in the numerator, it will be 2. So means, my dear NEET aspirants, sum of all of this is basically 2, because this is the formula to find the sum of this GP series. So I can write net potential in this particular case will be minus 2G, and instead of all of this, I can write 2. 2 into 2 is minus 4G. Minus 4G. I hope this is crystal and clear. I hope this is crystal and clear. Okay. So as of now, my dear NEET aspirants, what you guys are supposed to remember is, please listen to this. Please listen to this. That is, in just one slide, I'll tell you. We say potential, if you have two masses, M1 and M2, potential energy between the two masses is U is equal to minus G M1 M2 by R. If you have a mass, potential at R distances V is equal to minus Gm by R. Potential is defined for only one mass. Potential energy is defined for two masses. Okay. One more important thing. Work done by external agent is equal to positive of change in potential energy. When external agent does the work, due to that potential energy will change. And work done by conservative force or gravitational force, it will be negative of change in potential energy. And one more equation I told you, force is equal to minus du divided by dr. Okay, or du by ds. Okay, so this also. I hope these equations are crystal and clear. Let's move on to the gravitational potential due to a hollow sphere. Is this clear? Tell me in the chats, everybody out there. Come on. Is this clear? Give me the signal in the chats. Is this clear? Give me the signal in the chats. Quick. Is this clear? Give me the signal in the chats. Come on. Okay. Now, let's talk about gravitational potential due to a hollow sphere. See, guys. So, now you will be remembering, if there is a mass, due to this mass, there will be potential. Now, if there is a hollow sphere, it has mass. Due to this hollow sphere, what is the potential outside at small r distance? Directly remember, outside it is going to be minus Gm by R. R is the distance where you are finding the potential outside. Okay. Then you say at surface, value of small r is equal to capital R. So put over here capital R, potential on the surface will be minus Gm divided by capital R. And my dear NEET aspirants, when I say inside, right now inside it is not 0. Inside it will be minus Gm by capital R only. Sir, what you are trying to say is that whatever is the potential on the surface of a hollow sphere, same will be on the surface. Absolutely. Whatever is surface, same will be inside. Yes, absolutely. Now, if you check the graph, guys, see, in this particular case, potential, graph of potential V versus R. Sir, here value of R is 0 means this is center. Sir, we recently studied from center to surface, it is constant. See. G is constant, M is constant, mass of solid sphere is constant, radius is constant, so it is constant. So from center to surface, we can say it is constant. It is constant. Inside. And then when you check outside, my dear NEET aspirant, see. Outside potential is inversely proportional to R. So when you move outside of this, outside it is inversely proportional to R, minus Gm by R. It is outside. So this graph is very important, my dear NEET aspirants. So you can make it like this also. Okay. Because it is minus. From the upper side we write magnitude, from this side we write it like this. Potential due to a solid sphere. Solid sphere means cricket ball which is filled. Here also we need to find potential outside, surface, and inside at small r distance. Small r is variable. For outside, small r is greater than capital R. For inside, small r is less than capital R. For outside, it will be same. Okay, minus Gm by small r. Consider a point mass at outside point. On the surface, what is the value of small r? Capital R. So on the surface, it will be minus Gm by capital R. And when I say inside, inside you need to remember here. Inside potential is minus Gm divided by 2r cube. Then 3r square minus small r square. See guys, I'll tell you the trick to remember this. Potential inside a solid sphere. Okay, this is minus Gm divided by. First you write 2, then r cube. Okay. Then interchange the position of this and this. So you write 3r square. 2r cube, 3r square. 2r cube, 3r square minus r square. That's it. This is the potential inside. This is the potential inside. Okay. Okay. So I believe this is crystal and clear. Now, my dear NEET aspirants, if I say, what is the potential at the center? Sir, I believe at center value of small r is 0. Put the value of small r is 0. Potential at the center will be minus Gm divided by 2r cube. Then we say 3r square minus the 0. Now this r square and cube will cancel. So it will be, take this 3 here, 3 divided by 2, Gm divided by r. Array, sir. Potential on the surface came out to be, at the center came out to be 3 by 2 Gm by r, minus 3 by 2 Gm by r. And minus Gm by r is potential on the surface. So you can write 3 by 2 potential on the surface. Okay. So in case of a solid sphere, guys, this one is outside, this one is surface, this one is inside at random point, this one is at the center, this one is at the center. Okay, absolutely, sir. Now see, guys, I'll make you understand. Potential outside minus Gm by small r. Potential surface minus Gm by capital R. Potential inside minus Gm upon 2r cube, 3r square minus r square. This is the random point inside. Oh, this is not a fixed point. It can be anywhere inside. Potential at the center minus 3 by 2 Gm divided by r. Now, if you compare this and this, where is the potential large? This is 3 by 2. 3 by 2 means 1.5. So 1.5 is greater than 1. So potential at the surface center is greater than potential on the surface. Okay, magnitude wise. Okay, now guys, take a look. If you make the graph between potential versus R, I would say this is center. Don't you think at center we say potential is large? Absolutely. So graph will start from here and it will reach here. Then it reaches on to the surface. Potential at surface is less than potential at center. So till here it is inside. And then it becomes outside. My dear NEET aspirants, when you move outside, what is the relation between V0 and R? Inverse relation. So V is inversely proportional to R. Inverse relation. I believe this is crystal and clear to each and every single student. Now the similar graph from the lower side would be something like this. Please give me the signal in the chats. I hope this is crystal and clear. Please give me the signal in the chats. Guys, smash the like button if you have not liked the session yet. Please give me the signal if this is crystal and clear. I'll give you the break. Wait, please. Please give me the signal in the chats if this is clear. Now guys, see, potential due to a ring, potential due to a ring on its axis, potential due to a ring on its axis. This is a ring, its mass is m and its radius is r. If I say what is the potential due to this ring at x distance, you'll be simply saying, sir, potential due to the ring at x distance is minus gm upon under root of r square plus x square. R is the radius and x is the distance. This is the ring. Guys, you can imagine it like this. This is the ring. At x distance from the ring, you have to find potential. Okay. Now, if I say at center, what is the value of x at center? 0. Put it 0 here. So now square and root will cancel. So it will come out to be gm by capital R at center. Then I say very close to the ring, very close to the ring, very close to the ring. Okay, very close to the ring, my dear NEET aspirants, means this is the ring, this is R, and just this outside point. So here, okay, this is very far from the ring. This is very far from the ring. Very close is this much, this one. Okay, very close to the ring, very close to the ring. Okay. When you say very close to the ring, my dear NEET aspirants, we say x is much less than r. X is much less than r. And my dear NEET aspirants, listen to me very carefully. If this x is much less than r, you can neglect x. Okay. So what I'll show you over here. I'll show you over here. Guys, see, potential at x distance is minus gm upon under root of r square plus x square. Very close to the ring, I would say x is much less than r. Neglect x. So v will come out to be minus gm divided by r square root. This and this will cancel. Minus gm divided by r. And my dear NEET aspirants, if I say, what is the, at x, when x is much greater than r, what will be the potential in that case? In that case, you will be neglecting this r. So that will be minus gm upon under root of x square. This and this will cancel. So minus gm upon, I would say, x. So this is the potential very far. This is the potential very close to a ring. And this is the potential at center. This is the potential at x distance. And if you make the graph, guys, graph between mod of v versus r, we say here it is center of the ring. Okay, so from center to very close point, listen carefully. If I say this is the ring, from center to close point, if you clearly see, guys, see, this is the close point, minus gm by r, g is constant, mass of ring is constant, radius of ring is constant. So all are constants. Close center, g is constant, mass of ring is constant, radius of ring is constant. So means this is constant. So if I make the graph over here, my dear NEET aspirants, between mod of v and x, so from this to here, it is constant. And then outside, it is inversely proportional to x. So I would say it is inversely proportional to x. Or directly you can remember this is the potential due to a ring, v versus x. V versus x, v versus x. Is this clear? Is this clear, guys? If the potential at the center of the ring, is this clear, or tell me? If the potential at the center of a solid sphere is assumed to be 0. Okay, potential at the center of a solid sphere is assumed to be 0. Okay. Then find the potential between the surface and this. Okay. This is a very important question. I want you guys to understand this very carefully. See, guys, I'll make you understand this particular question. Listen to this very carefully. So it says that potential at the center of the solid sphere is assumed to be 0. See, guys, potential at the center of the solid sphere is assumed to be 0. Okay. Now in this particular case, if the potential at the center of the solid sphere is assumed to be 0, potential at center is assumed to be 0. Okay. And potential at the surface you have to calculate. Guys, see, this is according to the question. Remember, this is a very important question. Let me show you how to tackle these questions. Now, let's suppose what we have studied till now. Listen, guys. If you have a solid sphere, you know what is the potential at the center. You know what is the potential at the center. Okay. As we know, potential at the center of the solid sphere is 3 divided by 2 minus 3 by 2 gm divided by r. Recently we studied. Okay. And potential of the surface will be minus gm divided by r. Yes, this we know. Sir, how did you get these expressions? These expressions we got after deriving. I did not derive here, but we have done the derivation previously. And this derivation is only possible when you assume the potential at infinity as 0. This point is very important, guys. If you say, my dear NEET aspirants, potential at this point is minus gm by r, it is only you are saying when you are assuming the potential at infinity as 0. Then only you are getting this. If you say potential at the surface is this, when you say potential at infinity is 0. This is done in the derivation. So, my dear NEET aspirants, if you have these expressions, it is because you are assuming the potential at infinity as 0. But right now it is saying you, sir, potential you are assuming here 0. What will be potential at this point? Then it will not be this. One thing I want you to remember in this, what is that? We say potential difference will be the same. Delta V is equal to delta V in first case is equal to delta V in second case. Potential difference is not going to change. Potential, remember directly, potential difference in both the cases is going to be the same. Okay. Now, my dear NEET aspirants, listen to me very carefully. This is the trick we do. Now, in this particular case, find the potential difference between these two. Find the potential difference between these two. Solve. Done and dusted with the question. Sir, potential difference between these two, that is potential at center minus potential at surface is equal to potential here at center minus potential at surface. Now, in this question, potential at center there want you to assume 0. So, this is 0 minus potential at surface is equal to potential at center minus 3 divided by 2 gm divided by r. Then minus potential at surface is minus gm divided by r. Done. Done and dusted. So, this will be minus Vs is equal to minus 3 by 2 gm divided by r. Minus into minus is plus gm divided by r. Okay. Okay. Now, guys, in this particular case, when you solve this, Vs will come out to be gm divided by 2r. Okay, I hope you can solve this. Take this gm by r common, 3 by 2 minus 3 by 2 plus 1. You can solve it. It will come out to be minus gm divided by 2r. Please tell me in the chats if this is crystalline clear. Please tell me in the chats if this is crystalline clear. Come on, guys. Quick, 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 quick. Is this clear? Is this clear? Is this clear? Tell me. So what did I tell you? Potential difference in this case is equal to potential difference in this case. Similar question I am giving you over here. Similar question I am giving you over here, but it is your homework. It is your homework. This question is important. That's why I gave you this question. Okay. Guys, I'm not leaving any sort of topic. Okay. Please stay till the end. Okay. Okay. I have distributed the time to each and every single chapter properly. Now, guys, gravitation is a big chapter. That's why it is taking a bit more time. Solid is a small chapter that will finish the solids in 1 hour. Now, gravitational potential energy. See, guys, listen to me very carefully. Let's suppose this is the earth you have over here. This is the earth. What is the potential energy of the mass at this point? If the mass is at the surface, sir, G, mass of earth is m, mass of this m is small m, then we say distance between the two is r. Without a shadow of doubt. When you take the mass to the height h, what will be the, let's call this as u1. What will be the potential energy at this point? G, mass of earth is m, mass of this is m naught, okay, because this is m naught, divided by here also m naught, divided by, I would say, r plus h. Yes, sir. Oh, now find the potential difference between the two. That is u2 minus u1. Find change in potential energy. Sir, u2 minus u1. When you find u2 minus u1, it will come out to be this. Done. So if you have an object on the surface, it will have some potential energy. If you take to the height h, it will have some potential energy. So here potential energy is u1, here it is u2. Find change in potential energy, that is u2 minus u1. That will be this. Directly you have to remember. Or it can be, we can write it in this form. Directly you need to remember. This was asked in NEET many times, I would say in 2019, 2017, 2021. This expression. Okay. Now guys, listen to me very carefully. What does the question say? Now, if the height is very, very small, if you take an object from the surface to a smaller height, that is, height is much less than this, like height of an object from the center is, from the surface is 2 meter, 3 meter, okay? So means, what is the radius of earth? 6400 kilometer. And height in this particular case is 2 meters. How much is the difference? Huge. So if you, height is very small, this is very large. So very small quantity by very large quantity, it will become 0. So 1 plus 0 becomes 1. 1 plus 0 becomes 1. So delta U is equal to mgh divided by 1. So delta U is equal to mgh. This is the potential energy at height h. Please tell me if this is crystalline clear. This expression is very important. Change in potential energy. So at small height, it is mgh. Now guys, let's suppose the question is this. An object is taken to h is equal to 2r. From the surface of earth. The increase in the potential energy will be, guys, if object is taken to h is equal to 2r, then increase in potential energy will be, change in potential energy will be, use this equation. We can say delta U is equal to mgh upon 1 minus h divided by r. Can I use this? Absolutely, sir. Now tell me, delta U will be mgh upon, and what is the value of h? That is 2r upon 1 minus 2r divided by r. R and r will cancel. So this will be 2mgr, okay, 1 plus h by r, so divided by 3, 2 by 3 mgr. Okay, what about this one? The change in potential energy when the body of mass m is raised to height n is h is equal to nr. So if the object is taken at h is equal to nr, what will be change in potential energy? That is mgh upon 1 plus h divided by r. Okay, so this will be mg nr upon 1 plus h divided by, okay, 1 plus, instead of h I can write nr divided by r. R and r will cancel, so it will be n upon 1 plus n. Then we say mg into r. This is the expression. Guys, give me the signal in the chats if this is clear. Come on, tell me. Is this clear? Come on, tell me. Is this clear? Come on, tell me, guys. Quick. Conservation of mechanical energy. Conservation of mechanical energy is simply total energy initially is equal to total energy finally. Directly remember this. Total energy means kinetic energy initially plus potential energy initially will be equals to kinetic energy finally plus potential energy finally. That is called a conservation, like we use here. Like we use here. In this particular question, we'll be using the conservation of mechanical energy. Take a look, guys. Take a look, guys. Take a look, guys. Okay? Listen to me very carefully. Listen to me very carefully. See, guys. See, guys. See, guys. In this particular case, my dear NEET aspirants, there is a mass M. There is a mass M. We are releasing this mass from infinity. This will attract it towards itself. Yes, sir. Now it will come, and it will collide over here. What will be the speed of collision? So what does the question say? If mass M is released, with what velocity it will hit the sphere? We can use the conservation of mechanical energy over here. Use COME. That means kinetic plus potential initially will be equals to kinetic plus potential finally. Now see, when I say initially, object is here. Initially, object is here. And finally, object is here. Okay. Initially, you know, sir, kinetic potential energy is 0 because at infinity it is 0. Even kinetic at infinity is also 0. Finally, guys, kinetic at initially is 0, potential initially is 0. Finally, what if when the object strikes here with velocity v, its kinetic energy will be 1 by 2 mv square. We are supposed to find. Potential energy will be minus. Guys, this is the sphere. This is another mass when it strikes. Mass of sphere is capital M. Mass of this is small m. Now, what will you write? Potential energy minus G capital M small m divided by R. R is the, because in case of the sphere, we assume the mass to be at the center. From here to here, it is R. Okay. Don't ask for the break, guys. It won't be possible for me to complete all chapters. Okay. You need to understand, na? It is just one day. It is only 3 hours I have taken as of now. Do you think it would be possible for me to complete all these chapters, and that too in detail? I'm not leaving any of the topics. You check my those one shots of every chapter. You see, I have covered the same topics in those also. Now take it over here. So this will be G capital M small m divided by R will be 1 divided by 2 mv square. M and M will cancel. So take this over here. 2gm divided by R will be equals to v square. So v will be equals to under root of 2gm by R. 2gm by R. This will be the velocity with which it will collide. So this was the question on conservation of energy. Now we have the concept of escape velocity. See, guys, what does escape velocity actually mean? Let's suppose this is the surface of Earth. Okay, this is the surface of Earth. And there is an object placed on the surface of Earth. Wait, guys, I'll give you the break at the proper time. Wait, like a few minutes, wait. Let's finish this now first. At least we must finish now. Wait. I will give you the break. See, let's suppose this is the object over here. This is the object over here. This is the object. If I say you throw this object in air, you throw this object in air. Sir, you are throwing this object in air, gravity is attracting, it falls back. Now I say give more speed so that it should not come back. Sir, I'm giving more speed. Now again it comes back. Because gravitational pull of this Earth is very strong. Now I am saying give more velocity. Now you are giving more velocity, more velocity. It does not come back now. Because you have given the enough velocity, strong velocity. This velocity with which an object goes out of the gravitational field of Earth so that it does not fall back, it does not come back. This is called escape velocity. The minimum velocity with which you can escape from the gravitational field of Earth. Okay, like this is Earth, mass m, radius r. We are given this object the escape velocity. Okay. So it is leaving Earth. It goes to the infinity. It does not come back. And how much is this escape velocity? We say under root of 2gm divided by r. This is the escape velocity. And this escape velocity is equal to 11.2 kilometer per second. If you launch an object at 11.2 kilometer per hour, that is going to be the escape velocity. And g is the universal gravitational constant, m is mass, r is the radius of Earth. Okay. Now, my dear NEET aspirants, this is the first expression of escape velocity. This is in terms of mass of Earth. Listen carefully. There is one more expression. And when I say, what is the relation between escape velocity and radius? Sir, relation is v is inversely proportional to under root of r. Okay. So if you say mass is constant, if you consider mass of an object constant, then we say v is inversely proportional to r. The graph is going to be like this. It depends, na? If you have two objects, if you have two planets, mass of both planets is same, then this will be inversely proportional to, escape velocity will be inversely proportional to a radius of those planets. So graph will be rectangular hyperbola. Now there is one more expression for escape velocity. That is this. Escape velocity in terms of density. This escape velocity in terms of density is VE is equal to R, radius of Earth, under root of 8 by 3 G or rho, and then we say pi. This is the escape velocity in terms of density, my dear NEET aspirants. This is the escape velocity in terms of density. Okay. This is the escape velocity in terms of density. Sir, what is the difference between this expression and this expression? This is the escape velocity in terms of mass. And here, if mass of the two planets is constant, this is inverse relation. Then graph will be rectangular hyperbola. And what is this relation, guys? Here, if density of the two planets is constant, if the density is constant, then we say V is, this will be also constant, this is constant, this is constant, this is constant. V is directly proportional to R. In that particular case, we say graph between escape velocity and radius will be direct, because when density is constant. These are the two expressions. Okay. Now the question, the ratio of escape velocity VE, the ratio of escape velocity at Earth is VE, to the escape velocity at planet is VP, whose radius and mean density are twice. Okay. Guys, see, it says you have a planet. See, guys, here you are launching escape velocities. This is Earth, VE. You have a planet. Here escape object is launched. Here escape velocity is velocity at planet. It says what is the escape velocity of Earth divided by escape velocity of the planet. What is given in the question? Where whose radius and mean density means a radius of planet is 2 times radius of Earth. And density of planet is 2 times density of Earth, whose radius and mean density are twice as that of Earth. Now tell me, first of all, what is given in the question? Density. Which formula of escape velocity you will prefer? This one, in which density is present. So you will be writing, we say as escape velocity is R under root of 4 by 3 pi rho 4 by 3 pi rho g. Now guys, tell me in this particular case, what is constant? 4 by 3 pi is constant, pi is constant, g is constant. Escape velocity depends upon radius and g. Now, my dear NEET aspirants, if I say escape velocity of Earth divided by escape velocity of planet, it will be radius of Earth, my dear NEET aspirants, that is RE under root of gravity. Okay, this density, it is density. Sorry, my mistake. It is density here. Then we say density of Earth upon, because g is constant now, upon. Then we say radius of planet divided by radius of planet. Radius of planet is 2 times radius of Earth upon density of planet, that is 2 times density of Earth. Okay. What can you cancel? You can cancel density of Earth, radius of Earth, radius of Earth. So 1 upon 2 root 2. I hope this is crystalline clear. I hope this is crystalline clear. Okay. Give me the signal in the chats. Is this clear, guys? Tell me quickly. Density. Okay. 8 by 3. Sorry. Still it is constant. Still it will come out. 8 by 3. Okay. Okay, that's great. Now satellite motion. Guys, what is a satellite? See, what is a satellite? This is Earth. This is the surface of Earth. Now you go at height h, at a large height h. Okay. Then you launch an object with a velocity v. And this object will keep on moving in the circle around it. This is what we call the satellite. An object which revolves around Earth. That is what we call satellite. Okay. So how do we actually launch a satellite? We basically go to the height h. At that height, we launch an object with velocity v perpendicularly. Then, now see, how does it move in a circle? Let me just tell you that. This is the object, you are launching it with velocity v. This is the gravitational force by Earth on this object. It wants to go in the forward direction, but Earth is attracting towards itself, so it will deviate the path. So when the object, let's suppose, reaches here, due to the velocity, it wants to go straight, but gravity is attracting towards itself, so it will deviate the path. And it reaches here. Now at this point, it wants to go straight. Okay, gravity is attracting something like this. Again, it deviates the path. So that's how it goes in a circle. Okay. Now, my dear NEET aspirants, if I say, what is the velocity with which it is revolving in the circle? The velocity with which it moves in this orbit, that is what we call the orbital velocity. And this orbital velocity is v naught is equal to under root of gm by r plus h. M is the mass of Earth. This is the capital M. Capital M is the mass of Earth. And at h is the height where it is launched at height h. So what is the difference between orbital velocity and escape velocity? Escape velocity is with which object escapes from Earth. Orbital velocity is with which it moves in the circle. I believe this is clear. Is this clear? Oh? Difference between orbital velocity and escape velocity. Now, what is important in this particular case is energy of a satellite. Okay, energy of a satellite. See guys. This is Earth. Okay. At height h, there is a satellite, M. Okay. Now, this is the radius of Earth and this is height h. And total, we are saying this is r. R is basically small r plus h. Sorry, capital R plus h. R is variable. Now, guys, since mass of Earth is m, this is small m. Whenever you have two masses at some distance, they have potential energy. So we said there will be potential energy between the two. Yes. Since this mass, this satellite is moving with some velocity, orbital velocity, it has mass velocity, it will have kinetic energy 1 by 2 mv square. So after derivation, we write its kinetic energy as, directly remember, G capital M, mass of Earth, mass of the satellite divided by 2r. R is the distance, small r it is, okay? It is the distance from the center to that object. This is the kinetic energy. And when I say potential energy will be U is equal to minus G capital M, mass of Earth, Small m, mass of satellite divided by r. Okay, distance from the center to the satellite. Okay. Now you can say kinetic energy is negative of potential energy divided by 2. Okay. Okay. Guys, you can write it like this now. You can write it like this now. You can write it like this now. This will be 1 divided by 2. G capital M small m by r. G capital M small m by r. Take this negative here. It will be minus u. It will be minus u. That's what I said. Kinetic energy is minus u divided by 2. Minus u divided by 2. Minus u divided by 2. Okay. Kinetic energy is minus u divided by 2. Or you can say kinetic energy is actually mod of u divided by 2. Mod of u divided by 2. When I say potential energy, total energy. Guys, how do you write total energy? Total energy is kinetic energy plus potential energy. How much is kinetic energy? G capital M small m divided by 2r. Minus. How much is potential? G capital M small m divided by r. Solve the two. This will come out to be total energy. So, energy of a satellite will be directly remembering like this. Kinetic energy is minus 2 G capital M small m. Sorry. G capital M small m divided by 2r. Potential. Array yaar. Kinetic is positive. So this will be minus G capital M small m divided by 2r. And total energies, that is minus G capital M small m divided by 2r. Okay, if you make the graph, my dear NEET aspirants, if you make the graph, energy versus R. Listen to this very carefully. Kinetic energy is positive, graph will be from the upper side. See, kinetic energy is positive, graph is from the upper side. Potential and total energy is negative. This is going to be the potential. This is going to be the total energy. It is from the lower side because from the upper side positive, from lower side negative. I hope this is crystalline clear to each and every single student. Is this clear? Is this clear? Is this clear? Tell me, guys. Is this clear? Oh, I need the signal, then only I can move forward. Is this clear? Yes. Now, guys, take a look. One more important thing. See, guys. An artificial satellite around a planet for which the gravitational force F varies with the distance, something like this. This is a good question. Guys, see. Please listen to this question very carefully. What does the question say? Okay. An artificial satellite, just a second. An artificial satellite moving around a planet for which a gravitational force F varies with the distance as F is given as F is proportional to R square. If its orbital velocity is V0, then you have to find the relation between orbital velocity and I would say R. Orbital velocity and R. This is the relation what you are supposed to find out in this particular case, my dear NEET aspirants. Okay. See, guys. F is proportional to R square. See, guys. We say, in this particular case, we say as, if it says gravitational force means F, okay, and artificial satellite revolves around a planet. When an artificial satellite revolves around a planet, we say two forces will act, gravitational force and Centripetal force. Centripetal force will act due to the circular motion. Gravitational force will act between the two masses. And both will be actually equal. So we say this gravitational force is proportional to mv square by r. Absolutely, sir. So I can say this gravitational force is proportional to mv square by r. And this gravitational force itself is proportional to r square. Array, sir. Amazing. Now, mass is constant. So can I say from this equation, v square is proportional to r into r square is r cube. Now take this 2 over here. V is proportional to r raised power 3 by 2. This is the relation between. Because when you write mv square by r, m is the mass of the satellite, v is the velocity, orbital velocity with which it is revolving. So a relation between orbital velocity and r, that is r raised power 3 by 2. Time period of a satellite. See guys, let's suppose this is Earth. At height h, there is a satellite. Its mass is m, its velocity is v. It started from this point and it completed one cycle. It completed one cycle. How much time it is going to take in completing one cycle? That is what we call time period of a satellite. That is called time period of a satellite. And this time period of a satellite, my dear NEET aspirants, is 2 pi under root of r cube divided by gm. This is the time in which it completes one cycle. Okay. Now, if you take the square root over here, it will become square. So we say t square will come out to be proportional to r cube. Absolutely, sir. T square will be proportional to r cube. See. I'll show you over here. I'll show you over here. So we can say t square will be equals to, okay, or first do one thing. I'll make you understand. It's something like this. I can write t divided by 2 pi will be equals to under root of r cube divided by gm. Something like this. Yes. Now take the square over here. So this will be t square divided by 2 pi square. Just a second. I'll add one more page. Now guys, you can write it like this. T square divided by 4 pi square will be equals to r square divided by, okay, it's r cube divided by gm. Okay, r cube by gm. Now guys, do one thing. Take this over here. T square will be equals to 4 pi square divided by gm into r cube. Can I not write it like this? Guys. T square is equal to k into r cube. Yes, I can write it like this. And where this k is called Kepler's constant. Kepler's constant. And what is the value of k? That is 4 pi square upon gm. This is the value of Kepler's constant. 4 pi square divided by gm. And this time period square is proportional to r cube. I hope this is called Kepler, and this is called Kepler's law. This is called Kepler's law. Time period square is proportional to r cube, where constant is 4 pi square divided by gm. So this is called the time period of a satellite. Okay. Now in this particular case, could you please tell me what is the answer? What is the value of k? K is equal to 4 pi square divided by gm. Take this here. So this will be k gm is equal to 4 pi square. Okay. A satellite of mass 400 kgs revolves around an orbit with a speed of 200 meter per second. Then we are supposed to find its kinetic energy and potential energy in this particular case. Okay. Now tell me guys, what is the kinetic energy? 1 divided by 2 mv square. You can find it with this because mass is given 1 by 2. What is the mass? That is 400 kgs into, this is 200 into 200. Because 200 square, na? Yes. Okay. So this will, when you solve, this will come out to be 8 into 10 raised power 6 joules. When you got the kinetic energy, what is potential energy? Guys. See, see, where did I write those equations? Yes, here. See, we say kinetic energy, this much is potential. Potential energy divided by 2. Yes. And if you check total energy and kinetic energy is exactly the same, but here it is negative. So can I say kinetic energy mod is equal to total energy mod magnitude makes positive is equal to is equal to is equal to I have, it is not 2 here, it is not 2 here, it is r, it is r, it is equal to, so that is 2 times of potential energy, 2 times of potential energy. Okay, so my dear NEET aspirants, we say this is u. Okay, 2 times of u by 2, u by 2, u divided by 2, u divided by 2, because it is potential energy divided by 2, because this much is the potential energy divided by 2. Okay, now come over here. So kinetic energy, from this you can say total energy, same as kinetic energy but negative, minus 8 into 10 raised power minus, sorry, 6 joules. And when I say potential energy, okay, it is 2 times of kinetic energy. So that is 2 into 8 is 16, minus 16 into 10 raised power 16 joules. Okay, okay, yes, 16 millijoule, 16 mj. Now guys, the time period of a satellite, I believe this is crystalline clear till over here. I believe this is crystalline clear till over here. The time period of a satellite in a circular orbit is t. Okay, there is a satellite, its time period is t, its radius is r, so time period square is proportional to r cube. The time period of another satellite whose radius is 4r, r dash becomes 4r, its time period t dash we are supposed to find out. Okay, now my dear NEET aspirants, how can you do this? Come on, tell me, how can you solve this? Time period t dash square, t square divided by t dash will be equals to r cube upon its radius will be 4r cube. Okay, so when time period is t, when radius is r, time period is t. Okay, when radius is r, time period is t. When radius is 4r, what will be the time period? Okay, you'll be simply writing in this particular case, that is, this is t square divided by t dash, its square, sorry, okay, is equal to, you can write over here, this will be r cube divided by 4 into 4 into 4, 64 r cube. This and this will cancel. So t dash square will be equals to 64 r square. So t dash will come out to be under root of 64, sorry, t square. So t dash will come out to be, that is square root cancel, 880. 80. Okay. If the potential energy, okay, of the satellite is 2 joule, okay, then the binding energy will be, binding energy is nothing but energy required to free the satellite. See guys, let's suppose this is Earth. Let's suppose this is Earth. And this is the planet. Sorry, this is the satellite which is revolving around the Earth. Let's suppose its total energy is minus 20 joule. Let's assume. Now, this is the energy with which it is bounded to this system. You can understand it like this. This is the energy because Earth is attracting it with a gravitational force. It is bounded to the system. It will not go away. Now, in order to free this satellite so that it can go away, it can go out of the gravitational field of Earth, how much energy we are supposed to give? We are supposed to give binding energy. And that binding energy is also 20 joule plus 20 joule. This energy. Sir, means binding energy is same as energy. Sir, total energy is that energy with which satellite is bounded to the system, to the Earth. Yes. And binding energy is that energy with which we can free the satellite. Yes. So we need to apply the same amount of energy. Yes. So in this particular case, I hope you got what the feel of binding energy is. So binding energy is the energy required to free the satellite. Free the satellite. Okay. Same as total energy. Whatever is the value of total energy, same will be binding energy. So binding energy is mod of total energy. If total energy is negative, binding energy has to be positive. Okay. So binding energy will be simply total energy is equal to, and total energy is how much? Potential energy divided by 2. What is the value of potential energy in this case? That is 2 mj divided by 2. So that will be 1 mj. This is the answer. With this, we have completed your first chapter. Okay. Guys, tell me in the chats if this is crystalline clear. Okay. Mechanical properties of solids. Tell me guys, is this crystalline clear? Sir, Kepler's 3 laws. Kepler's law I discussed over there only. Okay. Kepler's laws I discussed over there only. You want me to discuss those also because the question doesn't come from there. Huh? Okay. Just a second, ladies and gentlemen. Just a second, ladies and gentlemen. Mechanical properties of solids, gravitation. Okay. Okay. Let me discuss Kepler's laws also. Wait. It'll take 10 more minutes. 10 more minutes and we are starting the next chapter. 10 more minutes, we are starting the next chapter. Okay. Because some people are saying, give us the short explanation. Chill. Oh, I told you I'll teach everything. Don't worry about that. Come on. Thank me later after the NEET. Kepler's laws. First law is what we call the law of orbits. Law of orbit says all the planets move in an elliptical orbit with the sun at the foci of the ellipse. Like, this is the sun, my dear NEET aspirants. It says all the planets revolve around the sun. This is the sun, and it is not the circular path. It is the elliptical path. This path is the elliptical path. Okay. Now, my dear NEET aspirants, in this particular case, we say this is the Earth. This Earth is revolving around the sun in this path. This is called elliptical path. Now, guys, when the Earth is at this point, it is very far from this sun. This is the point when Earth is very far from the sun. This is called ephelion. Okay, and this is called a perihelion. And this is the maximum radius between Earth and sun. When the Earth is at this point, this is the minimum radius between Earth and the sun. So this is the farthest point between, this is the maximum distance between Earth and sun. This is the, sorry, minimum distance, this is the maximum distance. Okay. R max is the maximum distance between sun and Earth. R minimum is the minimum distance between sun and Earth. So we say this R minimum plus R maximum is equal to 2a. This is equal to 2a. This is equal to 2a, where a is what we call the semi-major radius, where a is what we call the semi-major radius. Okay. Yes. In the Phoenix batch, I'll be starting the classes from Monday onwards. And my dear NEET aspirants, in the next 30 days, I'll be completing your entire syllabus, 11th plus 12th. Okay. Till 15th of March, your syllabus will be done. Till 15th of March. Okay. And in terms of eccentricity, my dear NEET aspirants, we say R maximum is A plus 1 by 1 plus E, A into 1 minus E. Just remember these two, nothing, not important. P is the closest point to the sun and is called perihelion. P is the closest point of Earth to the sun and is called perihelion. This is called ephelion. Okay. This is what we call the law of orbits, Kepler's laws. Then we say law of areas, my dear NEET aspirants. When we talk about law of areas, what does law of areas says? See, this is the sun, this is the planet. Join the sun and the planet with a line. This is the line. Now, when planet moves forward, this line also moves forward. Now, this will be the line joining the sun and the planet. Now, this will be the area wiped or area covered by this line. Let's suppose it is this. This is the area. This much. Initially line is this, finally line is this. So, this much is the area wiped due to this line. It says that the line that joins any planet to the sun sweeps out equal areas in equal intervals of time. Means this line, if it is covering some area, okay, in 1 second, in the next second, let's suppose when the planet reaches here, it will sweep this area. So this area and this area will be same. It sweeps equal areas in equal intervals of time. Let's suppose in first second it covers this much, sweeps this area. In the next second when it reaches here, now this much is the area swept. So this area and this area will be same. Okay. dA by dt will be constant. This is the important thing in this particular case. Okay. dA by dt will be constant. Okay. So in every second, line joining the sun and the planet sweeps equal areas. And one more important thing also you need to remember here. I have derived this. So this is angular momentum also remains the constant in this case. When the planet revolves around the sun, angular momentum is conserved. Okay. Okay. So whenever the planet moves around the sun in an elliptical orbit, V and R also remains constant. Okay. Okay. I hope this is crystalline clear. In this case, this much is important only. This much is important only. dA by dt remains conserved. dA by dt remains conserved. Okay. Law of periods. Now guys, see, when we talk about law of periods, what does law of periods actually mean? Listen carefully. This is done now already. It states that the square of the time period of revolution of a planet is proportional to the cube of the semi-major axis of the ellipse traced out by the planet. That is what we studied in the satellite recently. Time period square is proportional to a cube. Replace this proportionality with k. K is called Kepler's constant and it is equal to this. Done. Over there, guys, in case of planets, we were saying time period is square, it's proportional to r cube. But here it is not r cube, here it is a cube. Because here path is elliptical. Sir, what is the difference between that and this? Here it is a cube. Path is elliptical. And what is a, sir, here? I'll tell you what is a, boys and girls. What is the distance between this and this? Sir, it is 2a. So what is half of this? This is a. So this is half. A means semi-major radius. Guys, from here, major radius, semi-major radius. So time period square is proportional to the square, time period square is proportional to cube of the semi-major radius. Okay. Semi-major axis of the ellipse traced out by the planet. Is this clear? Is this clear? A is the semi-major radius, my dear NEET aspirants. And this is the R minimum, this is R maximum. Okay. And we say when it comes to the average radius, you say R maximum plus R minimum divided by 2. What is R max plus R minimum? That is 2A divided by 2. 2 and 2 will cancel. See, this is A. Means, sir, means A is also called as average radius. Yes. Average radius means maximum radius plus minimum radius divided by 2. So maximum plus minimum is 2A. 2 and 2 will cancel, so it will come out to be A. Okay. I believe this is crystalline clear. And if somebody says, what is the relation between T square and R cube? If you put T square on y-axis and R cube on x-axis, graph will be straight. Because here we will consider power of this one. Here we'll consider power of this as one. And if somebody says, what is the relation between T and R? In this case, time period is proportional to R cube. Okay, so graph will be this. But when you put directly T square, here power is 1, power is 1. That's why straight line. Else this is the graph. Okay, these are the 3 Kepler's laws. Now tell me, is this clear, my dear NEET aspirants? Is this clear? Is this clear? I need the signal in the chats, then we'll start the next chapter. We'll take the break exactly at 8 o'clock. Please, please. Huh? From 8 to 8:40 or 8:45, I'll give you the break. From 8 to 8:45, I'll give you the break. Long break. This is not that hour, bro. Don't confuse yourself in this particular case. Just remember, here is the derivation. Here is the derivation. You can take the screenshot of this derivation also. But it is not required at this point of time. It is not required at this point of time. You'll get to understand from this one. It is V cross R. V cross R is actually constant. Okay, V cross R. You can take, but it is not required. Here, this much is enough. Okay. Let's start the next chapter, that is mechanical properties of solids. Okay, let me put up the message in the group. I'm starting the new chapter. Smash the like button, guys, if you have not liked this session yet. Come on. Now, first topic that we need to understand in mechanical properties of solids is that is stress. That is stress. Listen to me very carefully, guys. Stress. Listen to me very carefully. We'll take the break exactly at 8 o'clock. Okay. My dear NEET aspirants, let's suppose you have a conductor over here. Let's suppose you have a rod, not a conductor, you have a rod over here. Okay. You have a rod. You are pulling this rod with an external force. Okay. When you pull this rod with an external force, we say there is atoms, molecules. Okay. We said there will be separation created between the molecules over here. Okay, intermolecular distance is created. Due to that intermolecular distance, my dear NEET aspirants, we say a restoring force is developed. F restoring. Okay, understand this very carefully. You have got in this particular case an object. You are pulling this rod. Now, due to the pulling of this rod, due to the external force, we say intermolecular distance between the two atoms, distance is created because you are pulling it. So, due to that, a restoring force is developed. Now, that restoring force divided by area, how much that restoring force, okay, this is, let's suppose, a unit area. How much that restoring force is created on unit area, that is what we call stress. restoring force per unit area is what we call stress. See, what does it say? When a deforming force acts on a body, when a deforming force acts on a body, deforming force means which deforms the body, intermolecular distance changes. Okay, intermolecular distance changes. You have two molecules, their distance between them changes. Due to which restoring force comes into play. Comes into play. Okay, like here, external force is created, due to which a restoring force comes into play. That restoring force per unit area, how much that restoring force is created on the unit area, that is what we call stress, my dear NEET aspirants. That is what we call stress. Restoring force per unit area is how we define the stress actually. Restoring force per unit area is how we define the stress actually. Okay, yes. So I can say when we write this stress, it is simply a restoring force. A restoring force divided by area per unit area. Restoring force per unit area. That is what we call stress. Okay, yes. Okay, so I can say in this particular case, this stress is, that is FR divided by area is A. This is. Now guys, let's move on to the strain. What is strain? We say when deforming force acts on a body, there is a change in the configuration of the body. Means when you apply deforming force, it will change the length, configuration will change. We say when configuration is changed, length is changed. Let's suppose if it is a rod, we say body is said to be strained. When you change the configuration shape, body is said to be strained. Strain has taken place. Or body is said to be deformed. Body has deformed. Okay. So we say it is the change of configuration upon the original configuration. See guys, how do we define the strain? Strain, we say change in configuration. Change in configuration upon original configuration. Change in configuration upon original configuration. That is how we define the strain actually. Okay, so if I say strain, okay, let's write this much only as of now. So when you apply the deforming force on a body, we say its distance will change, intermolecular distance will change. So that change in intermolecular distance divided by original length, that is what we call strain. Okay. Now guys, let's first move on to in this particular case, that is normal or longitudinal stress and strain. Normal or longitudinal stress or strain. Normal or longitudinal stress or strain. Just a second, guys. Okay. Now see guys, normal or longitudinal stress or strain. See, in this particular case, I'll write when external force acts along the length. See guys, this is the rod. You are applying external force along the length. Restoring force is being created. Okay. A restoring force is being created in this particular case. Okay, yes. So my dear NEET aspirants, when external force acts along the length of the body, the stress or strain created is called a normal stress or strain. Guys, see, if you apply the force on the length like this, we say the stress developed here in this length is called a normal stress, and the strain developed here is called normal strain. Guys, see, if you apply the external force, restoring force is created and it will be strained. So how much length is changed? Delta L. So we say in this particular case, the stress and strain will be, guys, when you define the normal stress, normal or first strain, normal strain, it will be simply change in length divided by original length. Guys, it is along the length. That's why I'm saying normal stress and normal strain. Otherwise, it was change in configuration divided by original configuration. Okay. So we can say this will be, in this particular case, that is delta L divided by L, normal strain. Normal strain, delta L by L. And my dear NEET aspirants, if I say normal stress, normal stress is simply that is force divided by area. How much force you are applying, restoring force divided by area. Simple, simple. Then we say Hooke's law. Guys, see. We said due to the external force, listen carefully, guys. Due to the external force, we said deformation takes place. Deformation takes place, absolutely, sir. We said due to which strain is created. Due to which strain is created. Guys, when external force is created, applied, intermolecular distance change, means deformation is created. We say due to which intermolecular forces are developed, due to which stress is created. So what I'm trying to say is that when you apply the external force, due to that external force, strain is created in the body. Distance between the molecules change. And when intermolecular distance change, we say stress is created. So it is strain which is creating the stress. It is not stress which is creating the strain. No, it is strain which is creating the stress. So we say stress is directly proportional to strain. Stress is directly proportional to strain. Okay, so it is strain which is creating it. It is strain which creates stress. It is strain which creates stress. It is strain which creates stress. Okay, so we say stress is directly proportional to strain. So we can say in this particular case, stress is equal to, replace this constant of proportionality with the, replace this with proportionality with a constant. So that is what we call gamma, and this is strain. This is strain. And this gamma is what we call Young's modulus. This gamma is what we call Young's modulus. Okay, so Young's modulus basically tells us how much restoring capability a material has, okay, when strain is created. See. Due to the strain, stress is created. Stress means restoring force per unit area. Now, if I say this material, it has some value of gamma, Young's modulus. So that means if I say, sir, it has some value of gamma, means gamma tells us how much capability it has in restoring its shape when strain is created. When you create the strain here, sir, if gamma is more, gamma tells you how much strain is created. Some material may have large value of gamma, some material may have less value of gamma. So gamma decides, sir, how much restoring force per unit area is developed in this one. Please tell me in the chats if this is crystalline clear. Come on, guys, quick. Tell me, is this clear? Is this clear, guys? Then we say tangential stress, tangential or shear stress and strain. Okay, tangential or shear stress or strain. Now, my dear NEET aspirants, understand this very carefully. Let's suppose there's a rod over here. Okay, it is fixed with this. Now you are applying the force in this particular case. This is the force F you are applying over here. Okay, when you apply the force F, the rod reaches here. Okay. Now, in this particular case, it has deformed angularly due to this force. And this is the distance from here to here. Initially, it was here. This distance is delta x. Now, see. We say when the deforming force acting on a body is tangentially. When the deforming force acts tangentially, not normally, it acts tangentially. The stress and the strain developed is called tangential stress. Here, the stress will be developed. Guys, when you apply the force over here, we say in this case restoring force will be developed, which does not let this rod to go down. So we say the strain created over here, this strain created over here is called I would say shear stress or shear strain. Now in this particular case, my dear NEET aspirants, if you ask me what is the value of shear stress, you simply say it is force divided by area. It is simply force divided by area. If I say shear strain, okay, this shear strain will be, it is this theta, okay. Now if you have to find this theta, my dear NEET aspirants, this theta, you'll be simply saying that is angle is equal to, you can consider this as arc upon radius, this arc delta x upon radius, that is L. Okay, so that will be this delta x divided by, I would say, L. Delta x divided by L. Okay, yes. Now, my dear NEET aspirants, we say in this particular case, Hooke's law for this. Hooke's law for tangential stress and strain. Tangential stress and strain. Hooke's law for tangential stress and strain. What will you say? Sir, shear stress is proportional to shear strain. Shear strain. Yes. So here, this shear stress is equal to, here we'll say N neta times shear strain. Okay. And this neta is basically the modulus of rigidity. Modulus of rigidity. Guys, it depends how you are applying the force. If you are applying the force tangentially, then shear stress and shear strain will be developed. I have told you both. And here we define modulus of rigidity. Modulus of rigidity tells us how much restoring capability a material has to regain its shape. Okay. Like over there, Young's modulus. Here we use modulus of rigidity, which tells us how much restoring capability it has. If you pull the rod, here Young's modulus, how much restoring capability it has to restore its position. Okay. Okay. Now you can write it like this also, my dear NEET aspirants. You can write it like this also. That is shear stress. Shear stress means force per unit area is equal to, this is neta. Then we say shear strain delta x divided by L. Shear stress is force by area, neta times delta L by L. Then, my dear NEET aspirants, we say example of longitudinal and tangential stress. See guys, let's suppose you have a rod over here. On this rod, you are applying a force something like this. This is the force F at an angle theta. Force is acting at an angle theta. This force will have two components, this F sine theta and this F cos theta. Listen carefully. This F sine theta is the longitudinal force. It will create the longitudinal strain. Sir. This is the force which is tangential force. It is tangential to this. It will create the tangential strain, that is theta. Now, sir, in this is the perfect example to understand longitudinal stress in this particular case will be force is F sine theta divided by area in this particular case is A. Longitudinal strain, guys, it is strained by how much length? Delta L. It will elongate. It is strained by delta L divided by original length is L. Tangential stress, that is F cos theta divided by area is A. Tangential strain, or we say shear strain, that is, we say delta x. This delta x, my dear NEET aspirants, how much it has gone from here to here? Delta x divided by length L, original length L. Array, sir, this is the example which basically tells you The exact definition of longitude. If you pull the longitudinal stress. If you put the tangential stress. As simple as that. Is this clear? Please tell me in the chats. Guys, tell me, is this clear? Tell me, guys, is this clear? Then you have volumetric strain. Guys, volumetric strain. Okay. When it comes to the volumetric strain, my dear NEET aspirants, it is valid for liquids, gas, and solids. Okay. Yes. Now see, this is the body over here. On this body, you are applying the force. You are applying the force. Okay. This force. When you apply the force on a body, okay, this is the deforming force which deforms the body, and volume of the body changes. Okay. The stress and the strain developed over here will be volumetric strain and stress. That's it. See, when the deforming force acting on a body changes the volume of the body, the stress and the strain developed is called volumetric stress and volumetric strain. Okay. Now, if you define over here volumetric stress, you simply say it is force divided by area. If you say volumetric strain, it simply say that is change in the volume divided by original volume. Hey, if you say over there longitudinal strain, change in length divided by original length, here it is change in volume divided by volume. So use Hooke's law here. Guys, here also. Can I say volumetric stress? Volumetric stress is proportional to volumetric strain. Absolutely, sir. Because when you change the intermolecular distance due to the external force, due to that restoring force comes into play. That restoring force per unit area is stress. So this is force per unit area is equal to, this is beta, bulk modulus this is, and that is delta V divided by V, volumetric strain. We put the negative sign over here. Why? Because negative sign tells you when you apply the external force on a body, we say in that particular case, its volume decreases. When volume decreases, then restoring force is being produced. That restoring force is basically the stress. Okay. Okay. Yes. So negative sign indicates when body is compressed, change in volume is going to be negative. I hope this is crystal and clear in this particular case. Because in that longitudinal case, we were elongating the length, we were increasing the length. Okay. Yes. Now, my dear NEET aspirants, we are taking a break. We will be taking a break. Let's take a break, guys. Let's take a break, guys. Break till I would say 8:45. Okay. Break till 8:45. See you guys at 8:45. This is a long break. Get done with your dinner. Okay. Chalo. See you guys after the break, huh? Okay, guys, let's get back to business. Okay. Now, my dear NEET aspirants, let's talk about different versions of Hooke's law. Let's talk about different versions of Hooke's law. See, guys, I want you to understand this very carefully. I want you to understand this very carefully. Everybody of you, listen to me very, very, very carefully. In the first case, in the longitudinal stress and strain, what did we actually study? What did we actually study? We said, sir, force per unit area. Restoring force per unit area. That is what we call stress. Restoring force per unit area. That is gamma times of delta L divided by L. This is what we studied. Yes, sir. Okay. Gamma is the Young's modulus. Can I write it like this also? F divided by, instead of this area, I can say pi into r square also. Absolutely, sir. It will be equals to, that is gamma times of delta L divided by L. 100%, sir, I can write it like this also. Yes. Then, my dear NEET aspirants, can I write it like this also? See. I would want you guys to remember all of these expressions over here. Can I write this like this also? Force per unit area, it will be, that is gamma times of delta L means final length minus initial length divided by initial length. We can write it like this also. This Hooke's law. Absolutely, sir. We can write it like this also. Now, my dear NEET aspirants, we can say multiply with, I would say, A on both sides. Multiply with area on both sides. What we can write? F divided by A square. In this particular equation, I am multiplying A with both sides. F divided by A square. It will be simply, that is gamma times of delta L divided by A into L. So can I write this as F divided by A square? It will be gamma times of delta L divided by A into L. So delta L divided by area into length is volume. So we can write this also, because questions have been asked. That's why I'm giving you these expressions in this particular case. I hope you got the crystal clear feel of this one. Now take a look, guys. In this particular case, this is the question which was asked in J 2022. What does the question say actually in this case? If the length of a wire is doubled, okay, and radius is halved, if the length of the wire is doubled and radius is halved, then the Young's modulus of the material of the wire will become, when I say Young's modulus is same, guys. If the wire of Young's modulus depends upon material, my dear NEET aspirants, okay, we say this Young's modulus depends upon material. Okay, it says that if the length of the wire is doubled, if you double the length of the wire and radius is halved, okay, the Young's modulus, if you are doubling the radius and if you are doubling the length and halving the radius, so I can say in this particular case, material of the wire remains same, na? We say Young's modulus remains the same. Let's talk about this one. This is a question. From NEET 2020. A wire of length L, area of cross section A is hanging from a fixed support. Okay, is hanging from a fixed support. Let me just show you over here. This is a wire. Okay, its length is L. Okay, the length of the wire is L1 when a mass M1 is suspended from its free end. So basically, its length becomes L1 when mass is attached to it. Its length becomes L1 when a mass is attached to it. Okay, then it says from its free end. The expression of Young's modulus is, in this particular case, we are supposed to say what is the expression of Young's modulus. My dear NEET aspirants, listen to me very carefully. Can I use the force per unit area is equal to Young's modulus delta L divided by L? 100% I can use this expression, sir. Now, can you tell me what is the value of Young's modulus? This will be F into L divided by delta L into A will come out to be equal to Young's modulus over here. Yes, sir, I can write it like this. Then in this particular case, my dear NEET aspirants, this Young's modulus will be, what is the force acting over here? We say in this particular case, this will be mg. So instead of this F, I can write m into g, okay, divided by, multiplied by this L, m into g into L, upon delta L. Guys, what is the value of delta L? Delta L means final length minus initial length. This will be the delta L. So that is L1 minus L into area becomes A, into area is A. Okay, into area is A. This is the expression for Young's modulus in this case. Let's move on to this one. This is a question of JEE 2022. Now, what does the question say? The force required to stretch a wire of cross section. The force required to stretch a wire of cross section 1 centimeter square. The force required to stretch a cross section of 1 centimeter square to its length, to double its length will be, how much force is required? How much force is required? Now, my dear NEET aspirants, area of cross section in this particular case is given as 1 centimeter square. If area's cross centimeter is 1 centimeter square, 1 centimeter means 10 raised power minus 2 meters. So I can say this becomes 10 raised power minus 4 meter square if you convert to the meter square. Okay. Now, my dear NEET aspirants, in this particular case, it says length of the wire must be doubled. So means final length must be 2 times of initial length. So can you tell me what will be the value of change in length? Sir, final length minus initial length. So final length is 2 times of initial length minus initial length. That will be initial length, Li. This will be the change in length. Now, in this particular case, we are supposed to find the force F divided by A. Force required to double the length F divided by A is equal to gamma times of delta L divided by L. So we are supposed to find this F divided by, okay, and guys, it will be gamma into A. What is the value of delta L? That came out to be L, na? Divided by this L. So L and L will cancel. Oh, Li means L only. So F means simply gamma. What is the value of gamma? 2 into 10 raised power 11. And area is 10 raised power minus 4. So force comes out to be, that is 2 into 10 raised power 7 Newton. I believe this question is also clear. Guys, tell me in the chats if this is crystalline clear. Guys, tell me in the chats if this is crystalline clear. Guys, tell me, is this clear? Okay. This is the question I am keeping you. This is your homework. It is already solved. Please do check it from your end. Okay. This is a question of NEET 2018. Do check this question from your end. Its answer is mentioned over here. It is simple. It is simple. Okay. One question on bulk modulus. One question on bulk modulus. This is the question on bulk modulus, which I want you guys to understand over here. See, guys. In this particular question, what does it say? The bulk modulus of a spherical object is this beta. If it is subjected to a uniform pressure, then the fractional decrease in the radius will be. We are supposed to find the fractional decrease in the radius. Fractional decrease in the radius means delta V divided by V. We are supposed to find the answer of delta V by V. This is called a fractional decrease in the radius. Now, my dear NEET aspirants, in this particular case, we say simply force per unit area is equal to bulk modulus delta V divided by V. Force per unit area is actually pressure. Pressure is force per unit area. That is bulk modulus delta V divided by V. Now, in this particular case, it says that the bulk modulus of a spherical object is beta. If it is subjected to a uniform pressure P, then the fractional decrease in the radius will be. We are supposed to find the fractional decrease in the radius in this particular case. Now, guys, see. We say in this particular case, as what is the volume of the sphere? 4 by 3 pi r cube. This is the volume of the sphere. Okay. Now, my dear NEET aspirants, we say if volume changes, radius changes. If volume changes, radius changes. I'll write over here, if V changes, we say R changes. If volume changes, radius changes. And my dear NEET aspirants, 4 by 3 pi is constant. How do you write change in volume? Delta V divided by V will be equals to 3 down delta R divided by R. This is, I have told you the fractional change recently. Like this, y is equal to x raised power. And how do you find the fractional change? Delta y divided by y will be n down delta x divided by x. That's what I'm trying to say. Same thing I did over here. Okay. Now, my dear NEET aspirants, what I can write in this particular case is, from this equation, I can say P divided by beta is equal to delta V divided by V. Okay. Now, delta V by V. Okay. Delta V by V in this particular case, what we can write, we are supposed to find the fractional decrease in the radius. Okay. This equation first, this equation second. So, can I say from first and second? From first and second equation, I can find P divided by beta will be equals to 3 times delta R divided by R. So this is delta R by R is fractional decrease in radius. So delta R divided by R will come out to be P divided by 3 times of beta. Okay. P divided by 3 times of beta. Okay. Now comes the concept of compressibility. What does compressibility actually mean, my dear NEET aspirants? See, when it comes to the compressibility, we say it is defined as how much volume of a body is decreased when pressure is applied on it. That is what we call compressibility. Let's suppose you have a volume over here. You want to compress it. What you are supposed to do is, you need to apply the, we say, pressure. So when you apply the pressure on it, it will compress. Okay. How much volume of the body is decreased? That's what we call how much a body compresses. And my dear NEET aspirant, see. Let's suppose if you are compressing a body, what did we study about the bulk modulus? If you are compressing a body, we say volumetric stress is proportional to volumetric strain. This is the bulk modulus. What does bulk modulus tell you? What is the capability of a material to restore its original shape? So bulk modulus tells you how much restoring capability this material has. Now, don't you think that compressibility will be inversely proportional to bulk modulus? Why, sir? Because bulk modulus is the restoring capability of a body to regain its shape. And compressibility is you are compressing the material. Compressibility, how much is the capability to compress the body? So compressibility is inversely proportional to bulk modulus. Keep this thing in your mind. Okay. Now JEE 2022. See what does the question actually say in this case. The question says that the bulk modulus of a liquid is 3 into 10 raised power 10 Newton per meter square. Okay. The pressure required to reduce the volume of the liquid by 2% is. Bulk modulus is given. How much pressure is required to reduce the volume by 2%? Okay. Now, in this particular case, we say delta V divided by V into 100. This is the percentage change in volume. This is given as 2%. Okay. Now we say, guys, force per unit area is equal to bulk modulus delta V divided by V. As simple as that. So this is pressure is equal to bulk modulus delta V divided by V. I can write it like this. Now, my dear NEET aspirants, what I can say in this particular case, this is 2% over here. So this is what I can write. This is 2. Delta V by V into 100 is given as 2, means 2%. Now, what will be the value of delta V divided by V? This will be 2 divided by 100 now. Delta V by V into 100 means percentage change in the volume. So this will be 2 by 100. So this pressure will be equals to bulk modulus. Delta V by V will be 2 divided by 100. And value of bulk modulus in this case is given. So pressure will be bulk modulus is 3 into 10 raised power 10. 2 divided by 100 into 2 divided by 100. Okay. So pressure will come out to be 6 into 10 raised power 8. I hope this is crystalline clear. I hope this is crystalline clear. Tell me, guys. Is this clear? Is this clear? Let's move on to the next one. Is this clear? Okay. JE 2025. Okay. The fractional compression delta V by V of a water at a depth of 2.5 kilometers below the sea level is dash %. Okay. Bulk modulus given, density of water is given, G is given in this particular case. Okay. The fractional compression delta V by V we are supposed to find out in this case. Okay. To find delta V by V, we have to find, guys, the fractional compression delta V by V of a water at depth of 2.5 kilometers below the sea level is. Okay. So means we have to find delta V divided by V at 2.5 kilometer depth. Okay. Guys, we say pressure is equal to bulk modulus delta V divided by V. And in this particular case, my dear NEET aspirants, what I can write, this pressure divided by this beta, it will be equals to delta V divided by V. Okay. Now, my dear NEET aspirants, what I can say over here is, what is the value of pressure? As of now, you write it rho GH. I'll tell you after some time when we move on to the next chapter, how does this rho GH come? So divided by, I can say bulk modulus is equal to delta V divided by V. Okay. Now, my dear NEET aspirants, you got this equation. In this equation, density of water is given. Okay. Bulk modulus is given. Acceleration due to gravity is given. Okay. And height is also given, that is 2.5 kilometers. Now you guys can solve this from your end and you can find the value of delta V by V. Let's move on to the next question. Next topic, that is stress strain curve. Understand this very carefully when it comes to the stress strain curve. See, guys, what does stress strain curve actually mean? We say, see. This is the graph between stress and strain. This is point A over here. This is point B over here, topmost point. This is point C. This is point D. This is point E. Okay. Now, guys, from O to A, material obeys the Hooke's law. What does Hooke's law say? Stress is proportional to strain. Okay. The amount of strain you create in a body, same will be the stress. That's why we say direct graph. Whatever is the value of strain, same will be stress. Whatever is the value of strain, same will be stress. Whatever is the value of strain, same will be the stress. Stress is proportional to strain. And stress is equal to, instead of this proportionality, gamma times of strain, where gamma is constant. Gamma is Young's modulus. And if I ask you what is the slope of this graph, slope will be perpendicular divided by base. Perpendicular is stress, base is this, and stress by strain. Now, can you tell me what is the value of stress by strain? I can clearly say stress divided by strain. It is gamma. So from this, you got slope as stress by strain, that is gamma. So can you not say slope of this stress strain curve gives us gamma Young's modulus? Yes. Now, guys, OA graph, this OA shows whenever strain is created in a body, same amount of stress is developed. And my dear NEET aspirants, in this region, body behaves like elastic. So if you develop some strain, If you create some strain, same amount of stress is developed. We say body behaves like an elastic body. Body behaves like an elastic body. In this region, we say body behaves like an elastic body. Body behaves like an elastic body. Then, my dear NEET aspirants, you listen here. Point B is called the elastic. Point B is what we call the elastic limit or yield point. This point B is what we call the yield point or elastic limit. Up to this, body can show the elastic nature. Now, if the load is increased further, see guys, till here, if the load is increased further, what does it say? If the load is increased further, stress developed, then strain increases rapidly. Okay. Okay. Now in the region BD, in this region BD, B to D, in this region B to D, when load is removed, body does not regain its original dimensions. Even when the stress is zero, strain is not zero. My dear NEET aspirants, basically from here to here, we say body behaves like an elastic body. Because Hooke's law is followed, the amount of strain you develop, same amount of restoring force per unit area is developed. So which will restore the body. But once you reach this strain, once you reach this load, external, you have applied external load greater than this. After this, the body will not regain its shape. Okay, after this from B to D, body will not regain its shape. Body does not regain its original dimensions. This region beyond B is known as plastic region. First one is elastic. Elastic means body comes. See, this is a body. You are elongated. You are applying the external load. External. If you leave, it will come back. So means you are in the Hooke's region. You are in which region? You are in which region? O2. I would say A. Then again, so you increase, you leave it, it will come back. Again, you are in O to A region. The amount of strain, the amount of stress. Same amount strain, same amount of stress. But you have applied a large amount of load. Now the body has strained, it will not come back to the original position. Means you have applied large amount of load. Strain is large. Now the stress will not be large. It will not take the body back to the original position. That's why we call it the plastic region. This is the plastic region. And point D tells us the tensile strength of the material. This is the point D. Point D tells us the tensile strength of the material. Point D tells us the tensile strength of the material. Okay, and beyond point D, if more strain can be created in the material, the point reaches when the breaking point E is called the fracture point. Now, my dear NEET aspirants, if you further increase the load, you keep on increasing the limit, increasing the load, so it will not regain the original position, okay, because it is in the plastic region. Now if you further increase the load, it will break it, it will break it, okay, it will break it. That's what so E is called the fracture point. Okay. I hope this is. And my dear NEET aspirants, if the plastic region is large, then the material is ductile. If this plastic region is large, then the material is what we call the ductile material. So it has large plastic region. It is not breaking. When it breaks, now see. What is the difference between the two? These are the important graphs. If the plastic region is small, then the material will be brittle. Now see, in this particular case, this B to D region is small. You see here, B to D region is large. So this is ductile and this is brittle. Okay, here breaking point we will reach very soon. Here it takes time in reaching the breaking point. Guys, please tell me if this stress strain curve is clear. And this E is what we call the breaking point. Okay, this is breaking point. When the body breaks, fracture point, we say fracture point. Okay. Now, my dear NEET aspirants, let's take a look over here. Let's take a look over here. What does the question say? What does the question say? The stress versus strain graph for two wires, two materials A and B are shown in the figure. Okay. This is the graph shown in the figure. If gamma 1, gamma A and gamma B are the Young's model of the two material, then we are supposed to find. Guys. In this particular case, we know that in case of stress strain curve, what is the value of slope? Slope means gamma. So when I say gamma of A divided by gamma of B, what will you say? You will simply say slope of A. And how do you find slope? Tan theta. So that is tan of how much theta A is making? Tan 60 divided by how much angle B is making. See guys, this is the angle of B, and that is tan 30. That is tan 30. Okay, that is tan 30. So my dear NEET aspirants, what is the value of tan 60? That's root 3. Tan 30, 1 divided by root 3. Take it in the numerator. Root 3 into root 3 is 3 divided by 1. So you can say gamma A is equal to, multiply this over here, 3 times of gamma B. Gamma A is equal to 3 times of gamma B. This is the question over here. Now, in this particular case, what does the question say? The load versus elongation graph for 4 wires, A, B, C, for 4 wires. Okay. So 3 wires are given over here. Of same length, same material is shown in the figure. The thinnest wire represented by the line. Which one is the thinnest line represented by the line in this particular case? Tell me, my dear NEET aspirants. We say, see. In this particular case, this is a good question actually. See, you have got the 4 wires. This is the graph of 4 wires. Okay. Load versus elongation. In this particular case, my dear NEET aspirants, what I'm trying to say is that we say slope is F divided by delta L. Okay. What is the slope in this particular case? What is the slope? Slope is always perpendicular divided by base. If this is the graph, this will be perpendicular, this is the base. So slope in this case is perpendicular by base, F divided by delta L. Load divided by elongation. And if you apply the Hooke's law, use Hooke's law, my dear NEET aspirants, we say force per unit area is equal to gamma delta L by L. Now, in this particular case, can I say F divided by this delta L will be equals to this? Take this delta L here, take this area over there. F divided by delta L is equal to this. So I can say in this particular case, the slope will come out to be, that is gamma times of A divided by L. In this case, this is the slope in this case. It is not a stress strain graph. Okay. This is the slope in this particular case. Now guys, in this particular case, it says that same length is same. Same material, gamma is same. If material of the 3 wires are same, length is same. So we say slope will be simply proportional to this area of cross section. Slope is proportional to area of cross section because A is area of cross section. Now, my dear NEET aspirants, in this particular case, slope is area of cross section. So means the one which one has got the large slope? We say slope of C is large. So I can say area of cross section of C is large. C has got the large slope. So we say area of cross section of this is large. So A has got the less slope. I can say OA has less slope. So OA is thinnest. Is this clear? OA is thinnest. Okay. Now, my dear NEET aspirants, figure shows the graph between stress and strain for a uniform wire at 2 different temperatures. Okay. Then you guys are supposed to comment on the temperature. Which one has got more temperature, T1 and T2? Which one is more, T1 or T2? Now, my dear NEET aspirants, always remember when it comes to this gamma, it is inversely proportional to temperature. Okay, temperature, gamma is inversely proportional to temperature. Now, tell me in this particular case, this is the stress strain curve. So we say gamma here means slope. Okay, so now tell me which has got large slope. So T2 has got large slope. So T2 will have large gamma. Okay, so in this particular case, I can say slope gamma of this, let's suppose this is A, this is B. Gamma of A is greater than gamma of B. What is the temperature of A? That is T1. So T2 is less than T1. Because if this is more, that will be less. So T2 is less than T1. Because slope of T2 is greater than slope of T1. I hope this is clear. Slope of A is greater than slope of B. So the one which has more slope will have large gamma, and the one which has large gamma will have less temperature, because temperature is inversely proportional to gamma. I hope this is crystalline clear. Let's move on to this breaking force and breaking stress. Breaking force and breaking stress. Okay. Breaking force and breaking stress. Now see, my dear NEET aspirants, when it comes to the breaking force, it simply means, let's suppose this is a rod. This is the area of cross section of the rod. You are applying the force over here. The force at which the material breaks is called breaking force. The force at which the material breaks is called breaking force. And always remember, this breaking force is proportional to area of cross section. More is the area of cross section, more is the force required to break. So what I can say, this force will be equals to sigma into A. Now this sigma will be equals to F divided by A. Now this sigma is the constant of proportionality, and this sigma is what we call breaking stress. Breaking stress. Why do we call it the breaking stress? Because it is force per unit area. Force per unit area is what? Stress. Breaking stress is breaking force divided by area. Breaking force divided by area. I hope this is crystalline clear. I hope this is crystalline clear. Guys, tell me. Is this clear? Oh? Okay. Now, guys, the question is, a force needed to break a copper wire having radius r. A force needed to break a copper wire having radius r. The force a force F is needed to break a copper wire having radius r. The force needed to break the copper wire of radius 2r will be, okay, how much force is required to break a radius 2r? Guys, force is proportional to A. This is the breaking force. I can say force is proportional to pi r square. Area is pi r square. So breaking force is proportional to r square. Absolutely, sir. Breaking force is proportional to r square. Okay. Now, this is the relation. We say if r dash becomes 2r, that is 2r, then when it comes to the breaking force, it will become 2r whole square, f dash. So f dash will come out to be 4r square. So F dash will be equals to 4 times of R square is what? F, that is 4F. Answer is 4F. Elastic potential energy. What does elastic potential energy mean? Guys, similar concept I'll be using over here also. Similar concept. What is that concept? See. What is that concept? See. We say there is a rod over here. Its length is L. You are applying the external force F and the rod is elongated by a distance of L, by a length of L. It is elongated. If we elongate a rod by delta L, we have to do the work done. How is this rod being elongated when you do the work done? The work done will be stored in the form of elastic potential energy of the rod. This work done will not be wasted. It will be stored. Like you lift an object from surface to height h, you do the work done. That work done is stored in the form of potential energy. Here work done is stored in the form of elastic potential energy. Okay. And if somebody says, sir, how much is that elastic potential energy or how much is the work done over here? Work done will be simply 1 by 2 force, how much you are applying, into delta L, F into delta L. And this will be the elastic potential energy. So elastic potential energy will be 1 by 2 F into delta L. And this was directly asked in the NEET once. This was directly asked in the NEET once. Okay. Yes. Okay. One more important expression I just want to mention over here. Just a second, guys. See, guys, this is the elastic potential energy that we actually got in this one, that we have gotten in this one. This is the elastic potential energy. Now, what I want you to understand in this particular case is, we say divide both sides by A into L. Divide both sides by A into L. What will you get? Energy divided by A into L. So energy divided by A into L, it will be equals to 1 divided by 2 F delta L divided by A into L. What is energy divided by A into L? Energy divided by volume. Energy per unit volume. When we say energy divided by volume, it means energy per unit volume. Energy stored in the unit volume. Guys, if let's suppose you have a container. How much is the total energy in the container? That is E. How much is the total volume? That is V. How much is the energy stored in the unit volume? That is energy divided by volume. Energy per unit volume. Okay, so energy per unit volume, this is energy density. This is energy density. Energy density. It will be simply 1 divided by 2. 1 divided by 2. Okay. Then guys, this A you can write here, na? Is there any problem if you write this A here? F divided by A, it's one and the same thing. Yes. F divided by A is stress. Delta L divided by L is strain. It is strain. Energy density simply means energy divided by A into L. It is equal to 1 divided by stress into strain. Stress into strain. Absolutely, sir, we can write it like this. Okay. Even you can write it like this also. Energy is equal to 1 divided by 2 stress, strain into volume into A into L. You can write it like this also. I'm showing you all the expressions. Okay. 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 Now, my dear NEET aspirants, take this equation. First equation, energy density is 1 by 2 stress into strain. So we can say U is equal to 1 divided by 2 stress into strain. Can I write it like this also, guys? Can I write it like this also? When it comes to stress, it is equal to Young's modulus into strain. Young's modulus into strain. So here, what is the value of stress? Young's modulus into strain. So you can write U is equal to 1 divided by 2. Instead of stress, you can write Young's modulus into strain. Strain into strain becomes strain square. Strain square. You can also write it like this. Absolutely, sir. Okay. You can write it in terms of stress also. Guys, what is stress? Strain is stress divided by gamma. So U will be 1 divided by 2 gamma. Instead of strain, you can write stress. Okay. Divided by gamma, its square. So 1 gamma will cancel with this. U will come out to be 1 divided by 2 stress square divided by gamma. So this is also energy density. U is what? Energy density. U is what? Energy density. I hope all of these expressions are crystalline clear. I hope all of these expressions are crystalline clear. Come on, guys, give me the signal in the chats if this is clear. Tell me. Okay, see, guys. The question here is a wire of 2 meters in length suspended, a wire 2 meters in length suspended vertically, a wire 2 meters in length suspended vertically, okay, stretches 10 meters when a mass of 10 kg, stretches 10 meters when a mass of 10 kg, sorry, 10 mm when a mass of 10 kg is attached to the lower end. Okay, now guys, and then the elastic potential energy gained by elastic potential energy 1 divided by 2 force into delta L. This will be the elastic potential energy. So we can say E will be equals to 1 divided by 2 force. What is the force acting on this in the downward direction? That is mg. So this will be mg. And then you say delta L. Delta L is given as 10 mm. So 10, okay, m into g into delta L. Okay. So E will be equals to 1 divided by 2. What is the mass? That is 10. What is g? That is 10. What is delta L? Delta L is given as 10 mm. 10 mm into meters will be 10 into 10 raised power minus 3. So E will be come out to be 1 by 2. Okay, because see this 10, 10, 10, 10 with 10 raised power minus 3. 10 raised power plus 3, 10 raised power minus 3. That is 0.5 joule. 0.5 joule. Okay, let's take a look at this question, guys. When a block of mass m is suspended by a long wire, there is a block of mass m is suspended by a long wire of length L. There is a wire of length L, again something like this, its length is L, block is suspended from it. The length of the wire becomes L plus L plus L, L plus L. Okay, its wire length becomes L plus L. Okay, yes. Then what does the question say the elastic potential energy will be? First of all, tell me what is delta L? Delta L means final length, L plus L minus initial length, that is L. This and this will cancel. Okay. Okay, wait. Final length is L plus L minus initial length is L. This and this will cancel, so it will be L. Then the elastic potential energy will be E is equal to 1 by 2 F into delta L. E is equal to 1 divided by 2. Guys, there is a block attached. So what is the force acting on this one? mg. So this will be mg into L. This L. Okay, now the question says energy stored per unit volume in a stretched wire having Young's modulus gamma and stress this. Young's modulus is given as gamma, stress is given as sigma. Stress, in terms of stress, what is the energy density? Here, 1 by 2 stress square divided by gamma. U is equal to 1 divided by 2, 1 divided by 2, U is equal to 1 divided by 2, stress square divided by gamma. So that will be gamma, sigma square divided by gamma. Sigma square divided by 2 gamma. Okay, yes. Now, my dear NEET aspirants, listen to me very carefully. Mechanical properties of fluids. Mechanical properties of fluids. We are done with this chapter, by the way, okay? Let's move on to the new chapter. Chapter 3. Okay. Is this clear? Give me the signal in the chats. Come on. Now, guys, let's move on to this one. Let's move on to this one. Mechanical properties of fluids. Mechanical properties of fluids. Let's begin with this chapter, that is mechanical properties of fluids. Okay, see. First and the foremost thing, what is a fluid? We say that substance which can flow. A substance which can flow is called a fluid. Is called a fluid. That substance which can flow is called a fluid. Example, we have liquid and we say gas. Example is liquid and gas. Okay, now my dear NEET aspirant, we say static fluid. We say, what does static fluid mean? If the fluid is at rest with respect to the container, with respect to the container, if the fluid is at rest with respect to the container, it is considered as static fluid. It is considered as static fluid. Like this fluid is at rest with respect to the container. It is not moving. It is static fluid. Okay. Container may or may not be moving. If container is moving, but fluid inside is at rest with respect to the container, like fluid is not moving with respect to the container, then that will be considered as static fluid. Dynamic fluid, we say that fluid which is moving with respect to the container. If this is a container, fluid is moving with respect to the container, that is called dynamic fluid. That is called dynamic fluid. Then, my dear NEET aspirants, we say density. How do we define density? Density is mass by volume. And we say we can write mass as dm, volume as dv. What is the unit of density? That is kg. What is the unit of volume? That is meter cube. And this you need to remember, density of water is 1 gram per centimeter cube. 1 gram per centimeter cube. Or we say 10 raised power 3 kg per meter cube. Okay. This is the density of oil. 0.8 grams per centimeter cube. Per centimeter cube. And density of oil is less than density of water. Okay. Okay. And then, my dear NEET aspirants, we say this is the density of Hg, mercury. Okay, this is the density of milk, 13.6 for this gram per centimeter cube, 1.04 gram per centimeter cube. Okay, for this Hg, it is 13.6 the density of water. 13.6 the density of water. Okay. Yes. Yes. Then, my dear NEET aspirants, let's move on to the pressure. Let's move on to the pressure. What does pressure actually mean? See, how do we define pressure? Pressure simply means, I want you to understand over here. Pressure simply means force per unit area. Force divided by area is what we call pressure. And this pressure is a scalar quantity. Force per unit area is basically pressure. How much amount of force is acting on unit area? Like this is the unit area over here. I am applying force on this unit area. Okay, I am applying force on this area. How much force is acting on the unit area? That is what we call pressure. Okay, we say it's a scalar. It is a scalar quantity. When it comes to unit, we say unit is Newton per meter square. Its unit is Newton per meter square. Or we say Pascal. Either you say Newton per meter square or you say Pascal. Okay. Yes. Then we say atmospheric pressure, my dear NEET aspirants. How do we define atmospheric pressure? We say pressure due to the atmosphere on the liquid is called atmospheric pressure. Atmospheric pressure due to the atmosphere on the liquid is what we call atmospheric pressure. And my dear NEET aspirants, we say atmospheric pressure is the force exerted by the weight of the air. Like guys, let's suppose this is a liquid. You have over here. Let's suppose this is a liquid in this container. Okay. Now this air from the upper side. So this air has the weight. How much amount of force this air is applying on this per unit area? That is what we call atmospheric pressure. See the definition. Atmospheric pressure is the force exerted by the weight of the air in the atmosphere, pressing down the Earth's surface. So P naught is equal to 1.1 into 10 raised power 5 Pascal. Or we say 10 raised power 5 Pascal. This is 1 atm. So basically, if you have a container, so how much, and there is a liquid inside the container, how much amount of force this air is applying, weight of the force, mg, weight of the force. Okay. How much amount of atmospheric pressure is the pressure exerted by the weight of the air. Okay. In the atmosphere, we say atmospheric pressure is the force exerted by the weight of the air in the atmosphere, pressing down the Earth's surface. Okay. You simply say, if there is an object, we say atmospheric pressure is acting on this due to the air. So pressure due to a liquid, my dear friends, at depth h. Let's suppose this is a container. You are supposed to find the pressure at depth h. If this is the height h, okay, directly remember, my dear NEET aspirants, we say pressure is going to be rho g into h. This is going to be the pressure, that is rho gh. Pressure is rho gh. Okay. Now, guys, it does not depend upon the amount of the liquid. It does not depend upon the amount of the liquid. It does not depend upon the shape of the container. It depends only upon rho g h. H is the height at what depth you are seeing. G is the acceleration due to gravity. Rho is the density. Okay. If the container is open, this is a closed container. This is a closed container. This one. If the container is open, in this particular case, at this point P, when it comes to the net pressure is going to be, we can say, pressure due to atmosphere. Okay. Then plus pressure due to liquid. Pressure due to liquid. Because the atmospheric pressure which acts at the top, it is transmitted. It is transmitted. So here atmospheric pressure will be there and plus pressure due to the liquid. So when I say net pressure in this particular case, what is the atmospheric pressure? That is P naught plus what is the pressure due to this liquid column? That is rho g into h. Rho g into h. Now, if the container is, my dear friends, in this particular case closed, that I told you over here, then pressure will be rho gh only. Atmospheric pressure will be zero because atmospheric pressure will not be transmitted to the bottom, because in this particular case it is this. Okay. Yes. Yes. So if the container is closed, pressure is going to be rho g into h. Now, guys, if the container is accelerating upward, let's suppose this container is accelerating upward. In this case, pseudo force will act. Directly remember, no need to focus on the pseudo force. Directly remember, pressure. Okay, pressure at the bottom. Pressure at the bottom, guys. This is the height h. Pressure at the bottom in this particular case will be P is equal to rho. Now here, when it is accelerating with acceleration A in the upward direction, you'll be writing G plus A. This is called the G effective acceleration into H. Directly remember, if the container is accelerating upward, then pressure is going to be rho into G plus A into H. A is the acceleration of this. If the container is accelerating downwards, in this particular case, pressure at the bottom is going to be rho into G minus A into H. Rho into G minus A into H. If the container is in the free fall means where acceleration due to gravity is G. So pressure in this particular case is going to be, guys, listen to me very carefully, rho into, we can say G minus A into H. So pressure is going to be rho into G minus A. G is also A. So G minus G into H, that is 0. In this particular case, no pressure will act. Pressure will be 0. If it is accelerating downward with free fall, G means 9.8 meter per second square. Okay. Yes. Now, guys, compare the pressure at A, B, C, and D of the given container. Guys, see, at A point, pressure will be less. As you move down, now the pressure of this column will be also added. As you move down, pressure of this column will be added. So what I can write in this particular case, we can say pressure at C and D will be same. That is greater than pressure at B, greater than pressure at A. I think option C. Pressure at A is less than B, less than C is equal to D. Okay. NEET 2002 question, NEET 2022 question. Is this clear or tell me? Quick. Is this clear? Tell me in the chats. Is this clear, guys? Now, guys, take a look at this particular question. Two copper vessels A and B have the same base area. Two copper vessels A and B have the same base area. Okay. But different shapes. A takes the twice the volume of water as that of B. You have two vessels, different base area. Okay. Okay. A takes the twice the volume of water as that of B to fill up to a common height. What does it say? It says that you have two vessels, this and this. Water is filled in this particular case till height h. In this particular base area is different. So here volume is twice till height h. Then which of the following statement is correct? I would say option C. Pressure on base of A and B is same. Why? Because pressure at base depends upon rho g into h. Rho is same, g is same, and height is same. It does not matter how much amount of liquid is present inside the container. That doesn't matter. Pressure only depends upon rho gh. So rho is same for both, g is same for both, h is same for both. Next, if the container is accelerating horizontally, this is the container, it is accelerating horizontally. If it is accelerating horizontally, my dear NEET aspirants, the liquid inside the container, its surface, the surface of the liquid inside the container will make a slope something like this. It will create an angle. It will create this angle theta. Okay. If it is accelerating with acceleration A. Now, if somebody says if the container is accelerating with acceleration A, inside the container, the surface of the liquid is going to make an angle theta with the horizontal. How much is this angle theta? We say in this particular case, you'll be directly remembering. We say this tan of theta is going to be A divided by G. Okay, I would want you guys to directly remember because only this is the concept which is asked from this one. How much is this angle? A divided by G. This tan theta is A by G. How much is the acceleration of the container? G is the acceleration due to gravity. That's it. You don't have to remember anything else. Like there is a question on this one. A vessel contains a liquid has a constant acceleration 19.6 meter per second square in the horizontal direction. Okay. The free surface of water gets sloped. That's what it says. The free surface, this is called the free surface of water. It gets sloped. It creates an angle with the horizontal at an angle. Okay. We are supposed to find the value of, according to the options. Okay. What is we say tan of theta is equal to 19.6. Consider 19.6 as 20. A divided by G, G is 10. Tan theta is A by G. Acceleration of this container given as 19.6. Consider 20. G is 9.8. Consider 10. 10 ones are 10 twos are. So 2 divided by 1. Tan theta is 2 by 1. Theta is tan inverse of 2 by 1. No option. Okay. Do one thing. If this is theta, tan theta is perpendicular divided by base. So perpendicular is 2, base is 1. Find hypotenuse. Hypotenuse is going to be under root of base square plus perpendicular square. That is going to be root 5. Now from this, could you please tell me what is the value of sine theta? Sine of theta is perpendicular upon hypotenuse. So 2 divided by root 5. So theta will be equals to sine inverse of 2 divided by root 5. Now check if the option is matching. Yes, option D is matching. So here answer is not given in terms of tan, answer is given in terms of sine. Sir, is this answer correct? This one. Yes, this is also correct. But option is not matching. Pascal's law. Let's move on to the Pascal's law. What does Pascal's law actually say? Pressure on a horizontal line of a static fluid is same at all points. Pressure on a horizontal line of a static fluid is same on all points. Now see guys, this is a container. Okay. This fluid inside the container is static. It is not moving with respect to the container. If you take a horizontal line, whatever is the pressure at this point P1, same will be the pressure at this point P2. This is the Pascal's law. Okay. Excess pressure applied at any point of a enclosed fluid, at any point of enclosed fluid, is transmitted equally at all points. Whatever the excess pressure you are going to apply, that will be transmitted to all the points equally. So simple Pascal's law is pressure at this point is equal to pressure at this point. Okay. Pressure at this point is equal to pressure at this point. As simple as that. As simple as that. Okay. Yes, this is the Pascal's law. This is the Pascal's law. Okay. Now let's suppose, my dear NEET aspirants, I can show you it like this. Okay. This is the force F1. Okay. This is R1. This is the force F2, and here it is R2 radius. At the top radius is R1, at the bottom radius is R2. Let's suppose we are applying the pressure at the top is F1 divided by pi R1 square, force per unit area. Same pressure on the unit area will be at the bottom. F2 divided by pi into R2 square. Pi into R2 square. Okay, pi into R2 square. And if I say, my dear NEET aspirants, guys, listen to me very carefully. If I say, my dear NEET aspirants, in this particular case, listen. What is the average pressure between top and the bottom? Okay, average pressure between top and the bottom. At the top, we say what is the pressure? That is 0. Let's suppose it's a closed container. Okay. At the bottom, what is the pressure? That is rho gh. What is going to be the average pressure? P average. See guys, P average is going to be pressure at the top plus pressure at the bottom divided by 2. So that is going to be rho gh divided by 2. This is the average pressure. Simply, Pascal's law tells you one thing, that what you guys are supposed to remember. Pressure on the horizontal line of a static fluid will be same. That's it. Questions will be like this only. Now take a look at this Pascal's law question. In a hydraulic jack as shown, the mass of the car is 800 kg. Mass of the car is 800 kgs. Okay. Area A1 is equal to 10 centimeter square. This area is given as 10 centimeter square. This area of cross section. A2 is given as 10 meter square. This is area 10 meter square. Car is placed on this platform over here. The minimum force required to lift the car is. Use Pascal's law. Guys, pressure on the horizontal line will be same. Consider one point here, consider another point over here. Can I say in this particular case, pressure at 1 will be equals to pressure at 2? Yes. So pressure at 1 will be force per unit area at 1 is equal to force per unit area at 2, A2. Okay. Then I can say over here, F1 divided by area at 1, that is 10 centimeter square. So I can say 10 centimeter square is equal to area at 2. It is given as, mass is given as 800 kgs. So this is going to be 800. Okay. Divided by. Now, my dear NEET aspirants, in this particular case, what I can write over here, this is A2. A2 is 10 meters square. So if you write this in the centimeters, it is going to be, that is 10 into 10 raised power 4. Okay. Centimeter square. Okay. Now, my dear NEET aspirants, this is 800 in this particular case force. 800, I would say G. 800 into G. Because F2 is 800 into G. See guys, F1, the force acting on this point. Okay, guys, this is an important question. See, force acting at this point is F1. Just a second, just a second. Guys, just a second, I'll get some water on. Okay. Now, guys, in this particular case, what I must say over here, see, force acting over here is F1. Now, if this platform, this I would say over here, has to basically lift this car, this piston has to lift this car. How is it possible? Weight of this will be mg. So the force must be in such a way, because see here force will be acting, that is weight. So force will be over here weight. Weight is how much? That is m into g. M is how much? 800. And g is how much? That is g, 800 g. Okay. So g is actually 10 meter per second square. So 10 and 10 will cancel. So if you solve this, this will come out to be F1 will come out to be in this particular case 10 centimeter square, this and this will cancel. So this will be F is 8 divided by 10. That will be 0.8 Newton. So means you have to apply just 0.8 Newton of force over here. It is going to lift the car. It is going to lift the car. Is this clear? Is this clear? Then you have a concept over here. It is called U-tube. Okay. It is called U-tube. This is the concept that you need to understand in this particular case. That is called U-tube. See guys, what this concept of U-tube over here is. Listen carefully. Listen carefully. See, this U-tube has basically a two kind of tubes over here, two structures over here. Okay. The liquid present inside the U-tube have different density. This is one liquid, this is another liquid. Okay. Okay. Now, my dear NEET aspirants, in this particular case, we use the Pascal's law. So this is basically, this is open from this side and pressure, atmospheric pressure at the top is P naught. Here also it is P naught. This height over here is H2. Okay. And this is density rho 2. And this goes till height. This height is given as H1. And this is the same horizontal line. Now see what I'm trying to say in this particular case. What I'm trying to say in this particular case is, when it comes to this U-tube, we say pressure on this XY line. Pressure on this XY line is going to be the same, because pressure on the horizontal line in case of a Pascal, according to the Pascal's law, is same. Okay. Okay. Now, my dear NEET aspirants, if I say pressure at 1, listen carefully. If I say pressure at 1, pressure at point 1 is equal to pressure at point 2. Yes, sir, I can say it like that. Because 1 and 2 are present on the same horizontal line. What is the pressure at point 1? You can say, sir, it will be atmospheric pressure P naught. Pressure at this point, okay, pressure at this point, atmospheric pressure P naught. Plus, I would say a rho GH1 because pressure due to this liquid column. Plus rho GH1. It will be equals to pressure at point 2, that is P naught plus a rho GH2. Now, what can you cancel over here? P naught you can cancel in this particular case. Okay. Then this G and G will also cancel out. Okay. And since the density of the two liquids is different, so rho 1 and rho 2. So you can say density of first into height of first. It will be equals to density of second into height of second. So basically, this is what I wanted to show you in this particular case. If you have a U-tube in which two liquids are present, so we can use the Pascal's law over here. Pressure at point 1 is equal to pressure at point 2. Then the question says that density of first is equal to density of, pressure at first is equal to pressure at second. Then the density of first into height of first will be equals to density of first and the height of first. Density of first, height of first is equal to density of second, height of second. Okay. Okay. Yes. Now, my dear NEET aspirants, let's take a look. Let's take a look. The question says in this particular case, a U-tube with both ends open to atmosphere is partially filled with water. This is water. Oil is poured into one side. Oil is basically poured into this side. Okay, oil is poured into this side. Until it stands at a distance of 10 mm. Okay, until it stands at a distance of 10 mm. Okay, above the water level. Until it stands at a distance of 10 mm above the water level. On the other side. This is the final water level. Oil is poured into the one side until it stands at a distance of 10 mm above the water level. On the other side, meanwhile, water rises by 65 mm from the original level. The density of the oil is, okay, we have to find the density of the oil. See, basically, there was already water present inside this. When you filled this side with oil, so we say this water is going to shift. It will rise the level. Now it says that final water level in this particular case, my dear NEET aspirant, this is the final water level till here, final water level. Check, this one is the final water level. So my dear NEET aspirants, final water level goes, this is the initial water level. So from here to here it is 65. So water level goes up by 65 mm. Okay. So how much is the total water level it has gone up from this point? 65 plus 65 is 130. Okay. Then, my dear friends, it says, what is the density of oil? What can I write over here? See, guys. I can say in this particular case, that is, I can write, use Pascal's law. Pressure at point 1 will be equals to pressure at point 2. Pressure at point 1 will be equals to pressure at point 2. Then you say, my dear NEET aspirants, when you apply this, what can you say? Sir, density of 1 into height of 1 is equal to density of 2 into height of 2. Can you write it like this? Okay. Can you write it like this? So I can say, my dear NEET aspirants over here. That is density of 1 into height of 1 will be equals to density of 2 into height of 2. What is the density of 1? That is density of oil into height of 1. Guys. In this particular case, this is 65. And this in this particular case is 10. So how much is this total? How much is this total? This, look at this. This is 140. So this is the height of this 140 mm. 140. So what I can say in this particular case, into 140 mm is equal to density of water into height of this. Height of this is the final level of water till here. That is 130. 65 into 65 is 130. So you can say density of oil in this particular case will be density of water into 130 divided by 140. Something like this. And density of water in this particular case, my dear friends, it is 10 raised power 3. 10 raised power 3 into 13 divided by 14. Okay, so density of oil will come out to be 928 kg per meter cube. Kg per meter cube. Okay. No need to convert this into meters, okay, in this particular case. Okay, because here also it will cancel out now. Guys, tell me in the chats if this is clear. Tell me, is this clear? See. I am simply using the Pascal's law over here. Pressure at point 1 will be equals to pressure at point 2. Okay, so this in this particular case, this, what does it say? What does it say? Oil is poured into one side until it stands at a distance of 10 mm above the water level. So what final water level is still here? Then how much is going to be this? This is 10 mm because oil stands 10 mm above the water level. If this is 10, this is 65, this is 65. So total is 140. That's what I'm saying. So now in this particular case, my dear NEET aspirants, we can say density of oil at this point into height of this liquid will be equals to density of this point, density of this water into height of this liquid. Simply rho 1 into H1 is equal to rho 2 into H2. Okay. Okay. Is this clear? Is this clear? Okay. See. In this particular case, what we can say here. Density of first will be greater than density of second. Why? Because height of first is less than height of second. Simple. If I am saying, see, it is simple. If I am saying in this particular case, rho 1 into H1 will be equals to rho 2 into H2. What does it actually mean? Means if, see, their product is equal, na? What does it mean? It means that if this is more, this has to be less. If this is less, this has to be more. Then only their product will be equal. Clear? Oh? Okay. See, hey, it is clearly visible. This H1, H2 is greater than H1. Okay. So if H1 is less than H2, you can understand it like this, my dear NEET aspirants. If this height is less than this height, then the density of this density must be greater than this density. Clear? Okay. Let's move on to the next one. You have this open tube manometer. Open tube manometer. See, guys, how does this open tube manometer actually look like? Listen to me very carefully. We say simply, when it comes to this open tube manometer, it is used to measure, we say simply, it is used to measure the gas pressure present in the container. It is used to measure the gas pressure present in the container. This is the container over here. Okay. This container has got fluid in it. Okay. This has got gas in it. Okay. And here you have got liquid in this. Here you have got liquid in this. Understand this very carefully. This is the gas present in this one. And here you have got liquid in this. Here you have got liquid in this. Now, my dear NEET aspirant, first case I am saying pressure of the gas is greater than pressure of the liquid. I am assuming pressure of the gas is greater than the pressure of the liquid. Now, what I can say in this particular case, when the pressure of gas is greater than pressure of the liquid, what will you say? In this particular case, this liquid is being pushed. Liquid is being pushed. Why? Because this pressure is more. Okay. So if you take a horizontal line over here, if you draw a horizontal line over here, don't you think that pressure at 1 is equal to pressure at 2? Absolutely, sir. I can say pressure at point 1 will be equals to pressure at point 2. And my dear NEET aspirants, when I say pressure at point 1, at this point, it will be the pressure of gas. Obviously, it will be the pressure of gas. Okay, is equal to. Okay. When I say pressure at point 2, my dear NEET aspirants, at this point, pressure will be due to this liquid column and the atmospheric pressure. We'll be saying that is P naught plus rho GH. Absolutely, sir, without a shadow of doubt, sir. P naught plus rho GH. Okay. This is going to be the pressure of the gas in this particular case. Okay. So we say here pressure of the gas is greater than the pressure of liquid. That's why liquid is being pushed. Here, pressure of the gas is greater than pressure of liquid. That's why liquid is being pushed. That's why in this case, liquid is being pushed. Okay, it's mentioned over here. Now, my dear NEET aspirants, this is case 2. In case 2, pressure of the gas is less than the pressure of the liquid. Okay. Now, here, gas will be pushed in this particular case. Okay, so I will mention in this case, we say here, gas is being pushed. Due to liquid. Your gas is being pushed due to liquid. Okay. Now, my dear NEET aspirants, if gas is being pushed due to the liquid, you see, liquid go high. In this particular case, liquid has gone down because liquid was pushed. Here, gas is being pushed. Gas is going up. So now draw a horizontal line. Can I say in this particular case, my dear NEET aspirants, can I say in this particular case, pressure at 1 will be equals to pressure at 2? We say here, use the Pascal's law, pressure at 1 will be equals to pressure at 2. Now, what will be the pressure at 1 point in this particular case, my dear NEET aspirants? We say pressure at 1.1, it will be due to pressure at 1 point, it will be pressure of the gas. Guys. In this particular case, pressure at point 1, pressure of the gas, plus, we say this one, pressure due to this liquid column. That is plus or rho G into H is equal to. Pressure at 2 will be only atmospheric pressure because it is exposed to the atmosphere. It is P naught. Now, can I say in this particular case, pressure of the gas will come out to be, take it over there, P naught minus rho GH. Absolutely, sir. Okay. Okay. Absolutely, sir. Guys, is this point clear? Tell me in the chats. Is this point clear? When pressure of the gas is equal to the pressure of the liquid. When pressure of the gas is equal to pressure of the liquid. Okay. So P1, draw a horizontal line. When both are equal, we say P1 will be equals to P2. What is the pressure at 1? Pressure of the gas. What is the pressure at 2? Atmospheric pressure. Arey, pressure at 2 is atmospheric pressure only, na? So here, pressure of the gas will be equals to the atmospheric pressure. So 3 cases we discussed in open tube manometer. If we say pressure of the gas is greater than pressure of the liquid, in this case, pressure of the gas will come out to be, you'll be directly remembering P0 plus rho GH. Here, when pressure of the gas is less than pressure of the liquid, pressure of the gas will be P0 minus rho GH. Here, when pressure of the gas is equal to pressure of the liquid, we say pressure of the gas will be equals to the P0 plus. Tell me guys, is this clear? Is this clear? I need the signal from every single student. Next session is going to be class 12th, and next session will be taking on the smart board because today it was having the issue. That's why. Let's talk about ideal fluid. What does ideal fluid actually mean? Fluid dynamics of ideal fluid. See guys, when it comes to the ideal fluid, listen to me very carefully. Duration will be, let's see, 1 o'clock till it'll go till 12 to 1. 2-3 hours more will take. Ideal fluid. See guys, we said that fluid which is non-viscous. Non-viscous means no internal resistance to flow. No internal resistance to flow. That is what we call non-viscous. Okay. Okay. No internal resistance to flow. So when fluid is flowing, there will be no internal resistance. No internal resistance. It is flowing smoothly. Okay, between the two layers, it is flowing smoothly. No internal resistance. Which is incompressible. That is, what does incompressible actually mean? Its volume does not change when pressure is applied. Sir, but volume changes. That's why it is ideal, na? No fluid is perfectly incompressible. It has a streamline flow. What does streamline flow mean? Type of flow with smooth orderly movement in parallel layers with no mixing between them. We say when this is flowing, you do one thing later on, check the ideal fluid, search the ideal fluid into the Google. Okay, let me just a second. I will show you. I was looking for a picture, but that is not showing right now over here. Okay, just directly remember guys, it's a streamlined flow, type of flow with smooth orderly movement in parallel layers with no mixing between them. Velocity of all the liquid atoms at a point is same. So if this fluid is flowing, every point will have the same velocity. All the liquid atoms at every point will have the same velocity. That's why the flow is orderly flow, orderly flow. Okay, that smooth flow, that smooth flow. That's what we call. And it is incompressible. Main point is velocity of all the liquid atoms will be same, and it is incompressible, means on applying the pressure its volume does not change. Okay, that is what we call the ideal fluid. Now see, we need to study the equation of continuity. What does equation of continuity actually say? See, whenever the amount of fluid enters a pipe, this is a pipe, per second, okay, the same amount of fluid must leave the pipe per second. See guys, let's suppose some amount of fluid is entering the pipe. The same amount of fluid must leave every second. If I say in 1 second, some amount is entering. In 1 second, same amount must leave. If the pipe becomes narrow, the fluid must speed up. Fluid must flow quickly, but the amount must be the same. If the pipe becomes wide, fluid must slow down. So basically, what I'm trying to say is that area of first into volume of first. Area into this rate of flow, I can say in this particular case, area into velocity, not volume. So this is the area at this point, and this is the velocity of the fluid at this point. It will be equals to this A2 into V2. So means AV is basically constant. Area into velocity is basically constant. Okay, so dV by dt is constant, and rate of flow in this case is constant. Rate of flow remains constant. Rate of flow remains constant. Rate of flow remains constant. Okay, yes. Now, my dear NEET aspirants, so whatever is the amount of fluid that goes in, same amount of fluid that will come out every second. So I can say dV divided by dt is constant. Okay. Now, listen to me very carefully. Listen to me very carefully. And this is the graph between A versus B. This is the graph between A versus B. Okay. Where area is more, it will go with less speed. Where area is less, it will speed up. Now guys, let's talk about this particular question. An incompressible liquid is flowing steadily through a pipe of variable cross section. Okay. Incompressible liquid is flowing through a pipe of variable cross section. Velocity of the fluid is found to be 20 centimeter per second. Here velocity is 20 centimeter per second. And velocity of the fluid through another cross section of radius 1 centimeter is nearly. Okay, we have to find velocity here. Radius is given. Now guys, tell me one thing. We know, sir, A1 into V1 will be equals to A2 into V2. Area of first, area is pi r square. Pi r. R in this particular case is 2. So that is 2 square. Velocity over here is 20. Is equal to A2, that is pi, into R2 we have to calculate its square, into V2. V2 is 1. Okay, yes. Now my dear NEET aspirants, pi and pi will cancel. This is 2. This is 2. 2 square is 4 into 20 is equal to, I can say, R2 square. This is 80. This is 80 in this particular case. pi r2 square. R2 we are supposed to calculate, na? Okay, R. No, 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 no. R is given. R is given. Wait. I made a mistake. So A2 is pi R2 square. R2 is 1 square. And V2 we have to calculate. Okay. So this will be pi and pi will cancel. So this will be V2. So V2 will come out to be 80 centimeter per second. Okay, what about this one, guys? In this particular case, we say this is the area A1 over here, velocity V1. Here, area A2, velocity V2. So you can use this A into V in is equal to A into V out. The amount of fluid which goes in is equal to the amount of fluid which comes out. What is the fluid which goes in? A2 into V2, A1 into V1. So A1 into V1 plus A2 into V2 is equal to A3 into V3. Is this clear? Is this clear, guys? Then you have this question. Is this clear? Give me the signal in the chats. Tell me, guys, what is the answer to this question? What is the answer to this question, guys? Tell me. An incompressible liquid travels as shown. An incompressible liquid travels as shown in the figure. The speed v of the liquid in the lower range is here. Guys, can I say in this particular case, I need to use the same concept, that is A into V in is equal to A into V out? Absolutely. Now tell me, A into V in, what is in? That is 0.12 is the area. Velocity in is 3 is equal to, what is out? That is 0.12. Okay, is the area out of this one. I'm talking about this area of cross section into this velocity, into I can say 1.5. Okay, then plus 0.18. Okay, into V, because here area is 0.18 into V. Now from this you need to calculate V. V will come out to be 1 meter per second. This is the concept. Okay, this was the concept of equation of continuity. The amount of A into V, the amount of liquid which goes in, the same amount of liquid which goes out. A into V will remain constant. Rate of flow remains constant. dB by dt remains constant. Then you say, my dear NEET aspirants, we say Bernoulli's equation. Okay, Bernoulli's equation. What does Bernoulli's equation actually say? I'll directly tell you to the point. We'll go over here. If a liquid flows through a pipe, this is a pipe, liquid is flowing through the pipe. Then potential energy per unit volume. See, what does the Bernoulli's equation say? If a liquid flows through a pipe, then potential energy per unit volume plus kinetic energy per unit volume. Potential energy per unit volume plus kinetic energy per unit volume plus pressure at any point remains the same. Plus pressure at any point remains the same. What does it say? If a liquid flows through a pipe, then potential energy per unit volume. Okay, first is potential energy per unit volume. That is potential energy divided by volume plus kinetic energy divided by volume plus pressure at any point remains constant. This is Bernoulli's equation. Done and dusted. Done and dusted. Now, first of all, you need to find out, you need to understand what is potential energy per unit volume. That is potential energy divided by volume. What is potential energy? That is mgh divided by volume is V. Okay. Now, guys, tell me, density is equal to mass divided by volume. Okay, density is mass by volume. So, in this particular case, what can you write? What can you write? Density is mass by volume. Okay, so mass you can write as density into volume. Now put it over here. Instead of mass, we can write density into volume, G into H divided by V. V and V will be cancelled, rho G into H. This is potential energy per unit volume, rho G into H. Kinetic energy per unit volume, 1 divided by 2 mv square. 1 divided by 2, what is the mass? That is density into volume into V square. So what will be that? That is rho V cube divided by 3. Okay. Okay. Oh, sorry. Rho 1 divided by 2 rho V cube. 1 divided by 2 rho V cube. Just a second. 1 by 2 mv square. This is the kinetic energy. Okay, divided by volume. Okay, we are supposed to divide with the volume over here. If you divide with the volume over here, wait. So this will be mv square divided by volume. Now, my dear NEET aspirants, how can we write the volume in this particular case? Tell me. Volume in this particular case will be simply, or you can convert this into the mass also. So when you convert this into the mass, you can directly write, I am directly writing in this particular 1 by 2 mv square, you can directly write 1 by 2 or rho into V square. Rho into V square. Okay. Rho into V square. Now, my dear NEET aspirants, what I can say in this particular case, this is the kinetic energy per unit volume. This is the potential energy per unit volume. Okay. Kinetic energy per unit volume, potential energy per unit volume. Okay. Now, my dear NEET aspirants, see what you can do. Here it is volume also. Okay. And this is V square. This is volume. This is volume. Don't get confused. So finally, you will get this equation. Okay. Let me show you. Kinetic energy divided by volume. Don't write V, write volume. Is equal to kinetic energy is 1 by 2 mv square. This is velocity divided by volume. Is equal to, you can write over here 1 divided by 2. Guys, instead of mass, you can write density into volume. Density into volume. Okay. So density into volume into V square divided by volume. Now this volume and volume will cancel. 1 by 2 rho V square. It is basically confusing. Sometimes I also get confused with velocity and volume. So try to write volume itself. Don't write velocity. Don't write V. Okay. In just a second, I'll copy this. Okay, this is kinetic energy, potential, kinetic energy per unit volume, potential energy per unit volume. Now, what does Bernoulli's equation say? At any point, it says potential energy per unit volume, that is rho gh, plus kinetic energy per unit volume, rho v square, 1 by 2 rho v square, plus pressure, it remains constant. That's it. That's it. Now, in this particular case, we are taking 2 points. This point P1, this point P2. So, at point P1, we can say rho gh1 plus 1 by 2 mv square, also you can say 1 by 2 rho v1 square plus pressure at this point 1. If I'm taking this one, I'm applying Bernoulli's theorem at this point and at this point. It will be equals to rho gh2 plus 1 by 2 rho v2 square plus p2. This is the Bernoulli's theorem that you guys need to understand, that you guys need to keep in your mind over here. Okay, these are the two equations of the Bernoulli's theorem. This one and this one. Okay, yes. And one more equation I just want you guys to remember in this particular case, my dear NEET aspirants. Okay, we say divide. So what does Bernoulli's equation say? It says potential energy per unit volume, kinetic energy per unit volume plus pressure at any point will be same. So divide this equation with rho g. When you divide this with rho g, you can say rho g h divided by rho g plus 1 divided by 2 rho v square divided by rho g plus pressure divided by rho g will be constant. Okay. Now what I can say in this particular case, what can I cancel? I can cancel rho g, rho. So what remains over here? H plus v square by 2g plus p divided by rho g is equal to constant. Okay. This is what we call the gravitational head. Gravitational head. This is what we call velocity head. Okay. This is what we call pressure head. Pressure head. We say velocity, gravitational head, velocity head, pressure head, they will be also constant. Directly remember this. I hope you got the Bernoulli's. If this is a horizontal pipe, this was not a horizontal pipe. If the pipe is horizontal, now guys, then we'll take this as a reference line. On the reference line, we assume potential energy to be 0. If potential energy is 0, we say potential energy per unit volume rho gh will be also 0. Absolutely, sir. Then if we apply the Bernoulli's equation, what does Bernoulli's equation say? Rho gh plus 1 by 2 rho v square plus pressure will be equals to 0. So this will be 0. We say in this particular case, pressure plus 1 by 2 rho v square will be constant. 1 by 2 rho v square will be constant. Okay. Okay. I hope this is crystal and clear. So it means if you take 2 points over here, let's suppose this point and this point. So at these 2 points, don't you think that pressure P1 plus 1 by 2 rho V1 square will be equals to pressure P2 plus 1 by 2 rho V2 square. Yes, I can apply the Bernoulli's theorem, something like this. If let's suppose fluid is same, so density is constant. If fluid is same, density is constant. In that particular case, my dear NEET aspirants, can I say P1 plus V1 square will be equals to P2 plus V2 square? Yes, I can write it like this. I can write it like this. Okay. So my dear NEET aspirants, we say when area is less, volume is more. Okay. When area is less, volume is more. Sorry, velocity is more. When area is less, velocity is more. Okay. So V1 is less than V2. This V1 is less than V2. Okay, this you remember in this particular case. Guys, tell me, is this clear? Is this clear? And one more important thing, at this point, area is more, V1 is less. So if V1 is less, P1 will be more. So P1 is greater than P2. P1 is greater than P2. P1 is greater than P2. Tell me, oh, is this clear? Is this clear? Oh, tell me, oh, give me the signal in the chats. Those who are studying with me, let me know. So at this point, I am saying if area is more, V will be less because we know A into V remains constant. If area is more, V is less. If V is less, P will be more. Okay. P is greater than P1 is greater than P2. We will complete all the chapters. Smash the like button. Now, guys. Now, guys. So can I say in this particular case, so in a horizontal pipe of fluid, if the speed increases, see, if the speed increases, speed will increase here where area is less. If speed increases, we say pressure will be less. Yes. So if the speed increases, then low pressure is created. Absolutely, sir. So the graph would be something like this. Graph would be something like this. Pressure versus distance. Now take a look at the question of JEE 2020 in this case. A fluid is flowing through a horizontal pipe of varying cross section with speed. Okay. at a point where pressure is P Pascal, at a point where pressure is P Pascal, and another point where pressure is P by 2 Pascal. Here pressure is P by 2, here pressure is P. Its speed is V meter per second, here speed is V. If the density is rho, then V will be. Okay, if the density is rho, then V will be. Guys, tell me, this is a horizontal pipe, use Bernoulli's equation. Bernoulli's equation. What does that say in case of horizontal pipe? Pressure plus 1 by 2 or rho V1 square will be equals to pressure P2 plus 1 by 2 or rho V2 square. If you know the concept, you can apply in one single go. Pressure at first point is P plus 1 by 2 rho, density is rho. V1 is U square is equal to pressure at this second point will be P by 2 plus 1 by 2 rho. What is the V2 square? V2 square is V square. Okay. What you can do in this particular case, my dear NEET aspirants, take this P by 2 here. So P minus P divided by 2, it will be 1 divided by 2 rho V square minus 1 divided by 2 rho U square. So P minus P by 2 is P by 2 is equal to 1 by 2 rho V square minus U square. This 2 and this 2 will be cancelled. Okay. So what I can write over here, P will come out to be rho into V square minus U square. We are supposed to find the value of V. Take it over there. P minus U square, P plus U square. Okay, first. P divided by rho, then this plus U square will be equals to V square. Now take this V will be under root of rho P divided by rho plus U square. This is the answer. This is the velocity here. Venturi meter. Now guys, Venturi meter, it is an instrument used to measure the rate of volume flow. How much volume is flowing? It is an instrument used to measure the rate of volume flow. It works on the principle of Bernoulli's equation. Rate of volume flow means area into volume. What is the rate of flow in this particular case? Guys, as we know, see, if I say this is a, let's suppose, pipe over here. And in this particular case, at this particular point, it is connected something like this. And here, area of cross section is given as A. Okay, this is the velocity V1 at this point, velocity of fluid. Here, area of cross section is capital A, velocity of fluid is V2. And this height over here is H2. Now, my dear NEET aspirants, in this particular case, what we are supposed to learn is that it is used to calculate the rate of flow. Rate of flow means area into velocity. That is what we call rate of flow. How do we define rate of flow? Area into velocity. Like previously, I told you here, equation of continuity. What does it define? Rate of flow remains constant. Rate of flow is rate of flow. Rate of flow means A into V. A into V means rate of flow. Area into velocity. Okay. Now, my dear NEET aspirants, in this particular case, when I say a rate of flow here, everybody knows that, sir, A into V1 will be equals to A into V2. Call it V0. And this V0 is what we call rate of flow. A rate of flow. This V0 is what we call rate of flow. Now, my dear NEET aspirants, I will be directly telling you the equation over here. How do we find the rate of flow in this particular case? That will be 2G into H1 minus H2 It works on the principle of Bernoulli's equation, but I will not be applying over here. That will take a lot of time. Directly remember 2g into h1 minus h2. h1 is this height, h2 is this height. Okay, it will be equals to v naught square. V naught is the rate of flow. Then it will be 1 divided by this a square minus 1 divided by this a square. This is going to be the equation of this Venturi meter. And if you want to calculate the rate of flow using this particular instrument, then you will have to use this particular equation. That's it. Sir, where does this equation come from? This equation comes from when you apply the Bernoulli's equation in this one. That's it. That's it. Okay, where V naught is basically the rate of flow in this particular case. Is this clear? Is this clear? Okay. There is a question which was asked in, guys, directly remember, this is an instrument which is used to measure the rate of flow. And how do we measure the rate of flow? It works on the principle of Bernoulli's equation. We have applied the Bernoulli's equation. Finally, we got this expression which you need to remember. Rate of flow means area into volume. Whatever is the rate of flow here, same will be rate of flow here. But here velocity will be less, here velocity will be more because area is less. So this is the final equation of Venturi meter. Okay. Now guys, the Venturi meter works on the principle of, I would say in this particular case, principle of Bernoulli's equation. Okay. Now let's take a look at the question. And in the shown Venturi meter, fluid velocity at 2 points. Fluid velocity at 2 points. Here velocity of the fluid is v. Here velocity of the fluid is 2v. Okay. Are indicated. What is the difference in the levels of the liquid in the tube? Okay. At 2 points. You have to tell me, guys. This is the tube. Here in this particular case, liquid is at height h1. Here in this particular case, liquid is at height h2. We have to find what is the difference in this h1 minus h2. We have to find h1 minus h2. This is the question. Now, can I say in this particular case, my dear NEET aspirants, we recently studied g into, what did we study? Equation of Venturi meter, 2g into h1 minus h2, okay, it will be equals to 2g into h1 minus h2, it will be equals to v naught square, it will be equals to v naught square 1 divided by a, 1 divided by a square minus a square, 1 divided by this a square minus a square minus 1 divided by a square. This is the equation that we recently studied. Now tell me, my dear NEET aspirants, since area is not given in this particular question, okay, so area is not given in this particular question, do one thing, use the Bernoulli's equation only. Use the Bernoulli's equation only in this particular case. What does Bernoulli's equation say? P1 plus rho 1 by 2 rho V1 square will be equals to P2 plus 1 divided by 2 rho V2 square. Okay. When it comes to the P1, pressure at point 1, it will be a rho GH1 plus, because guys, pressure at this point will be pressure due to this liquid column, rho GH1. Pressure at 2 will be pressure due to this liquid column, rho GH2. 1 by 2 rho V1 square, 1 by 2 rho V1 square. And what is the velocity at this point? Velocity is given at point 1, velocity is V. 1 by 2 rho V square is equal to P2 or rho GH2 plus. Why did I use the Bernoulli's equation directly? Because area was not given if I use the equation of Venturi meter. So 1 by 2 rho and it is 2V whole square, that is 4V square. Okay, sir. What else I can do in this particular case? So now guys, I think what can be cancelled? What we can cancel over here? Rho, 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 and this rho. So here, GH1, take this over here, GH2, it will be 4V square minus V square divided by 2. Okay. Okay, this is 4V square divided by 2. Okay, 4V square divided by 2 minus V square. Yes. So G will be common. H1 minus H2 is equal to 1 by 2. You can take common. 4V square minus V square is 3V square. Okay, okay, okay. So H1 minus H2 will come out to be, I can say, 3V square divided by 2G. Yes, this is the answer. This is the answer. Okay. Is this clear? Is this clear? Tell me, guys. Let's move on to the velocity of efflux. Okay. Now see, guys. When it comes to the velocity of efflux, consider a container over here. Okay. And make a hole of area A in it. Make a hole of area A in it. Here I have made the hole of area A. The velocity with which the liquid comes out of the hole. The velocity with which the liquid comes out of the hole. The velocity with which the liquid comes out of the hole. Okay. The velocity with which the liquid comes out of the hole is called the velocity of efflux. A container, make a hole. The velocity with which the liquid comes out of the hole is called the velocity of efflux. Okay. Also, the level of the fluid, when the fluid comes out, we say this level of the fluid will decrease. It will decrease with the velocity V naught. Also, the level of the fluid inside the container also goes down with the velocity V naught. Okay. Now, guys, this will come out with a velocity U. Let's suppose it is U. Now, in this particular case, you have to tell me, sir, how much is going to be this velocity of efflux? I'll be directly mentioning in this particular case, guys. So this velocity of efflux is going to be U is equal to under root of 2 P1 minus P2. P1 is, this is the point 1 and this is the point 2 here. This is the point 2. At topmost point, it is the point 1. P1 minus P2, pressure at the top, pressure at the hole, divided by rho plus, I would say, 2G into H. Okay, where height, H is the height, H is this height. From this hole till the top, this is the height. This is going to be the velocity of efflux. Now, my dear NEET aspirants, in this particular case, if the container is open, let me at this point, if the container is open, if the container is open, if the container is open, see, guys, in that particular case, pressure at 1 will be equals to pressure at 2 will be equals to atmospheric pressure. Here also it is exposed to the atmosphere. At this point exposed to the atmosphere, at this point exposed to the atmosphere. Velocity of efflux in that particular case will be, that is under root of 2 into P naught minus P naught divided by rho plus 2G into H. P naught minus P naught will be 0. Okay. Okay. So 0 by something is 0. So U will be under root of 2GH. This will be the velocity of efflux in that particular case. Okay. Now, one more important thing, my dear NEET aspirants. Let's suppose this is a container. You have made a hole over here. You have made a hole over here. At what height? I would say height H. Okay. Now this fluid comes out with a velocity of under root 2 g. This is the open container. So how much time it follows the projectile motion path? How much time it is going to take from here to here? That's the time of flight. So we say, if somebody says how much is going to be the time of flight in this particular case, you say under root of 2 into h minus h divided by g. Sir, h minus h is what? This is height h, small h, and total height is capital H. This will be how much? H minus h. G is acceleration due to gravity. If I say how far it will go, this is range, how far it will go. This range, how far it will go. This water, so this liquid. So range in this particular case, you will be directly writing 2 under root of h minus h into h. Okay. This is going to be the range in this particular case. This is going to be the range in this particular case. Okay. This is the range. And my dear NEET aspirants, range is going to be maximum. Range is maximum. Remember this directly. Range will be maximum. Okay. When hole is created at midpoint h by 2. Remember this directly. Okay, when it is created at midpoint h by 2. And in that case, maximum range will be equals to h. Maximum range will be equals to the height of the container in that particular case. Okay. Come on, tell me in the chats if this is crystalline clear. Is this clear? Now guys, let's take a look at this question. A tank is filled with water. A tank is filled with water. Take a look. A tank is filled with water. To a height h, a tank is filled with water to a height h. A hole is made on one of the walls. A hole is made on one of the walls. At depth d, hole is made at depth d. Below the water surface, the distance x from the foot of the wall at which the stream of the water coming out of the tank strikes the ground is. Okay. It says you guys are supposed to find the value of this range. Okay. So distance x from the foot of the wall, the distance x from the foot of the wall coming out of the tank strikes the ground will be x. You are supposed to find range. You are supposed to find, guys, in this particular case. Simple. Tell me, what is going to be the value of range? You have recently studied range will be in this particular case 2 into under root of h minus h into h. So R will be equals to 2 into under root of h minus, instead of small h, it is given as d into d. Okay, into d. So you can write it like this: 2 into h minus d into this is small d or capital D into d, and whole raised power 1 by 2, because value of root is 1 by 2. This one. Okay, this I'll give you the homework. This you will be doing from your end. Now, force on a container. Force on a container. See, guys, one thing I just want you to remember in this particular case, this is a container over here. Okay, this is a container over here. Liquid is coming out of the force with a velocity v, density is rho, area of cross section is a. If the liquid comes out of the pipe, this is a pipe, then the force on the liquid will be, how much is the force acting on the liquid? Okay. Directly remember, my dear NEET aspirants, this force is going to be rho A into V square. This force is going to be rho A into V square. This is the force. Where A is the area of cross section, V is the velocity of liquid. When it comes to A, it is area of cross section. Okay. When it comes to V, it is velocity of liquid. It is velocity of liquid. A is area of cross section, B is velocity of liquid. Okay. Now, my dear NEET aspirants, listen carefully. There is a concept which I would like to show you. Rho A into V square. When the liquid comes out of the hole, let's suppose there is a container. Liquid is coming out of the hole. What is the force acting on the liquid? Rho A into V square. Now, some liquid, if some liquid is going in, some liquid may flow in the backward direction. So why? In order to conserve the momentum. It is not like, sir, liquid go only out. When the bomb explodes, one part of the bomb goes in the forward direction, another one goes in the backward direction to conserve the momentum. When you fire a gunshot, bullet goes in the forward direction, gun is being pushed back to conserve the momentum. So we say when this liquid comes out of this hole, so some portion of the liquid goes in the backward direction to conserve the momentum. So whatever is the force on this liquid, same will be the force on this liquid. Same will be the force on this liquid. Okay. Yes. So same is going to be the force on this liquid. And we say, my dear NEET aspirants, this is the force on the container. We consider this is the force on the container. Okay. So we say force on liquid inside will be considered as force on the container. Why? Because that liquid is present inside the container. That is the reason I'm telling you that is the force on the container. So force on the container, that is going to be a rho A. It is coming out with U square. So rho A U square. As simple as that. Rho A U square. Yes, sir. Now, my dear NEET aspirants, if I say as, when it comes to the value of U, what is the value of U? Under root of 2gh, velocity of efflux. Recently you studied, na? Put it over here. So force on the container, it is going to be a rho A. Instead of U, guys, you can take the root over here, it will become square. So U square will be 2gh. So that is 2g into h. This is the force on the container. Yes. This is the force on the container. This is the force on the container. You can keep this in a box. Now, if I say, if the container is present on a frictionless plane, then it moves backward. Very obvious, na? This is a container. This is present on a frictionless plane. Force on the container is backward. So if there is no friction, it will move backward. But what if the friction is there? Now, minimum amount of friction required to keep the container at rest. Minimum amount of friction. If I say how much should be the minimum amount of friction so that the container remains at rest, it does not move back. Minimum amount of friction are required to keep the container at rest. Minimum amount of friction required to keep the container at rest. What is the minimum amount of friction required to keep the container at rest? See guys, in this particular case, we can say that minimum coefficient of friction will be 2A divided by this A. I'll not derive it, but I would want you guys to remember this directly. Okay, so what is this A? See guys, I'll make you understand. This is the container, huh? So here, what is the mu minimum required? Friction. This is the hole. This hole has an area A. This hole has an area A. Okay. 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 And area of this is A. This is A. This is area A. Okay. Is this clear? Is this clear? So this is the minimum. So in this particular case, you guys need to remember this force on the container, minimum amount of friction required to keep this at rest. Okay. And this force over here. Let's take a look at the question. Let's take a look at this question. This is the JEE 2021 question. A cylindrical vessel is kept on a horizontal surface, area of base area A. A hole of small area A is made at its bottom. The minimum coefficient of friction required, minimum coefficient of friction necessary to prevent the container from sliding. Array yaar, mu minimum, that is 2A divided by A. Okay. In this particular case, you have a large tank has two holes in it, in its wall. One of a square of side A and another depth X. At a depth X, one is having the A square side A at depth X from the top, while the other is a circular hole of radius R, other is circular hole of radius R at a depth of 4x from the top. This is a depth of 4x from the top. When the tank is completely filled with water, the quantities of water flowing out per second, from both the holes are same. Okay, the amount of water coming out of this is equal to the amount of water coming out of this. That's what it is saying. Per second, every second. Then the value of small, this R is, we are supposed to find the value of R. Guys, simple concept we need to use over here. AV is given as constant. Because it is saying from there only, na, velocity, the rate of flow, the same amount of liquid is coming out from both the holes. So that will be A1 into V1 is equal to A2 into V2. So A1 is basically area of first, that is A square, into velocity of efflux V1. Array, with what velocity fluid will come over here? Velocity of efflux. Okay, in this hole, this is V1 and this is V2. So this will be under root of 2G into H. H is X. Okay. Okay, this is area is given as A. 2G into X is equal to A2. What is the area of this guys? Its radius is given as R. Okay, that is 4 pi R square. 4 pi R square. because here this has the side A, so square. So how much will be the area? Side square. Area into velocity. And here velocity of efflux will be under root of 2g into 4x. 2g into h. Okay. Now guys, do the calculation from your end. R will be equals to A divided by under root of 2 pi in this case. Okay, you can do the calculations from your end now. R will be equals to this A divided by 2 pi. Now we say viscosity. What does viscosity actually mean? What does viscosity actually mean? Is this clear? Okay, what does viscosity actually mean? See guys, when it comes to the viscosity, viscosity is defined as the measure of fluid resistance to the flow. Viscosity is defined as the measure of fluid resistance to the flow. Okay, guys, when the fluid flows, when this block moves, there is a resistance created, there is a friction created, so that it does not flow, which opposes the relative motion. Yes, similarly happens, same is the case in case of fluid. When the fluid flows, we say between the two layers there is a friction created, that is called a viscosity. Okay, consider two liquid layers flowing with different velocities. This is the liquid layer 1. It is having velocity v0 plus delta v. This is having liquid layer 2, its velocity is v0. So if there is no relative motion between the two layers, there will be no friction. So two liquid layers, they are moving with different velocities, so the atoms of this will attract the atoms of this, they will create the force, intermolecular force. Due to that, friction will be created. Okay, so it is the fluid friction, cohesive force between the two liquid layers. These two liquid layers are attracted to each other. They do not want that another liquid layer should move. So they create a force, friction. That is what we call viscosity. Like here, this wants to go forward, but on this friction is acting in the backward direction. Now this wants to go forward. Okay. So if in this particular case, okay, so friction, if on this friction is this, friction on this will be this. Okay. Is that clear? Is that clear, my dear NEET aspirants? So basically, when you have two liquid layers, okay, so we say the friction created between the two liquid layers, that is called viscosity. That is going to be the viscosity. Now, my dear NEET aspirants, if I say, what is the equation of viscosity over here? Let me just tell you. See, so how do you define viscosity? Two liquid layers attract each other with cohesive force. Due to that, they do not want that other liquid layer should move. They attract each other. So this friction, this resistance is called viscosity. Okay. Now, my dear NEET aspirants, when it comes to the cohesive force between the two liquid layers, okay, I'll write over here. Cohesive force between two liquid layers. So this will be F is equal to this neta A delta V divided by L. F is the cohesive force. Neta is the coefficient of viscosity. A is the area. Okay. Okay. And then you say in this particular case, delta V divided by L. Okay. Delta V divided by L. Okay. Yes. This is delta V by L. So this is V naught. This is having velocity V naught plus delta V over here. This is having V naught. And L is the separation between the two. This gap between the two liquid layers. Gap between the two liquid layers. Okay. Where N is what we call coefficient of viscosity. Coefficient of viscosity. Okay. Even we can write this N will be, that is F divided by A. Okay. And you can take this in the denominator, delta V divided by L. Okay. Delta V divided by L. You can write this coefficient of viscosity like this also. Okay. Yes. Okay. Yes. This is also the coefficient of viscosity. This is the coefficient of viscosity over here. Now, my dear NEET aspirants, one more important thing I just want to say. Okay, let's move on to this particular question first. Let's move on to this particular question first. A plate of area is equal to this 0.1 meter square placed on a flat surface and is separated from it by a thin film. Okay, this is the plate. Okay, it is placed on a flat surface and is separated from it by a thin film of oil. See guys, this is a plate, this is the surface. So between the plate and the surface there is a thin film of oil. It's 10 raised power minus 5 meter thick, whose neta coefficient of viscosity is 1.5. Okay, this is a oil. The force required to cause the plate to slide on the surface at a constant speed of this. So if we want this plate to slide, how much force is required? How much force is required? Guys, see. If I say I am applying force on this, this is the external force. Okay. What is going to be the force which will hold it from motion? Sir, that is viscous force. That is the cohesive force. Okay, how much cohesive force is created? Arey guys, this is cohesive force, F cohesive. In this particular case, we say F cohesive will hold it from moving. So if I say this force becomes greater than this force, then the plate is going to move. Or if this force external becomes equal to cohesive force, then the plate will move. So we say in this particular case, external force must be equal to F cohesive. Then only the plate is going to move in this particular case. And that is neta A delta V divided by L. Okay. Now tell me, F will come out to be, what is the value of neta? 1.5 is given in the question. See here. Okay. And then area of film, area. Okay. Area of the plate. That is how much? 0.1. 0.1 is 1 divided by 10 meter square. Delta V. And the thickness of the film is 10 raised power minus 5. That is D. Okay, delta V by L. D is given as, thickness is given as this. This is D. Because L in this particular case is the 10 raised power minus 5. Okay. Delta V is the speed. Delta V is the speed. With what speed it is moving. So this is given as into delta V is given as how much? 1 mm per second. That is 10 raised power minus 3 upon 10 raised power minus 5. Okay. Solve this, my dear friends. It will come out to be 15 Newton. Okay. This was the question asked in the NEET. This is the question which you can solve from your end. Simple. Here also you need to apply F is equal to neta A delta V divided by L. You need to find the value of coefficient of viscosity in this case. Simple. Force is given, everything is given, just you need to apply. Now we have the Stokes law. Now what does Stokes law actually say? It tells us the force on a solid spherical object moving in a liquid. See guys, you have a solid spherical object, it is moving in a liquid. Solid spherical object is moving in a liquid. When a solid spherical object is moving in a liquid, my dear NEET aspirants, okay? When a solid spherical object is moving in a liquid, okay? In that particular case, we say force acts on this. Force, when you try to swim inside the liquid. So due to the liquid, force will act on you, due to which you are not able to move. So that forces, that is the force over here, okay? That is the force we need to find out. If I say, what is that force? It tells us that is the Stokes law. If I say how much is that force, you'll be simply saying, sir, that force will be 6. That force will be 6 pi neta R into Vt. R into Vt. Okay. Okay. So neta is the coefficient of viscosity. R, okay. R is the radius of the spherical object. Vt is the terminal velocity with which it is moving. Okay. Vt is the terminal velocity with which it is moving. In vector form, we can write it. Vector form, we can write it. This force will be equals to 6 pi neta R Vt. R Vt. Okay. Yes. Now, if I say what is the relation between force and terminal velocity, it is directly proportional. So more, see. Terminal velocity is with which velocity it is moving in the liquid. Spherical object is moving in the liquid. And force is the force applied by the liquid on the solid object. Now, can I say when a person tries to move faster or try to swim faster? Okay. Okay. We say the viscous force will be large. If you try to move faster inside the liquid, it will be difficult for you. Now move slowly, it will be easy for you. Okay. So if terminal velocity is large, viscous, this force in this particular case will be large. Force on the solid object due to this. Now we have to find the terminal. Now we have to learn the terminal velocity. Terminal velocity, then you have surface tension, contact angle, capillary rise, capillary fall, and we are done. Okay. Now guys, let's understand the terminal velocity. Let's understand the terminal velocity. Okay. What does terminal velocity actually mean? We say when a spherical object is dropped from certain height inside a liquid. Okay. Due to mg, its velocity will increase. When an object is dropped from certain height inside a liquid, due to mg, its velocity will increase. But due to viscous force, due to which viscous force will increase? Object, you release it inside the liquid, it will fall, velocity increases. And we know force is proportional to velocity. Okay. Now, my dear NEET aspirant, in this particular case, due to this mg, its velocity will increase, due to which viscous force also increases. After some time, this F becomes equal to mg. This viscous force F becomes equal to mg. Okay. And net force becomes zero, obviously, because net force is zero, upper force, downward force, same. Acceleration will be zero. When acceleration becomes zero, velocity becomes constant. This constant velocity is what we call the terminal velocity. This constant velocity is what we call the terminal velocity. Okay. With which the object moves, this is what we call the terminal velocity. So this constant velocity with which the object moves is called terminal velocity. It is called terminal velocity. Okay. And my dear NEET aspirants, if you ask me how much is this terminal velocity, you say Vt is equal to simply 2 into r square. Then we say sigma minus rho into g divided by 9 neta. You need to remember this directly. Okay. Now I'll tell you what is this, what is this, what is this. And this was asked in NEET directly. We can say r in this particular case will be, guys, that is a radius of spherical object. Spherical object. Sigma is the density of the object which is flowing inside the liquid, density of object. Okay. We say rho is the density of liquid. Okay. And we say neta is coefficient of viscosity. Coefficient of viscosity. Okay. What else do you have over here? G is the acceleration due to gravity. G is the acceleration due to gravity. And you can say this terminal velocity is directly proportional to r square. Okay. Radius of this. Now, if I say what is the graph between terminal velocity with distance time? Now, my dear NEET aspirants, initially, see, if the object is released, if you release an object inside the liquid, it will fall. We say its speed will increase speed. Initially, its speed is zero. Initially, if you release an object, we consider its speed zero. That's why graph starts from the origin. So, but its speed will increase, and after some time it becomes constant. That's why graph is this. This becomes constant. Okay. If the object is thrown, when the object is thrown, then initial velocity is not zero. So initially it has some velocity. Now see, it will go like this. So it will fall. But after some time it becomes constant. Terminal velocity is constant. So it will fall. When you throw an object inside the liquid, it will fall. Viscous, as it goes down, viscous force increases. So after some time, mg becomes equal to viscous force. This velocity becomes constant. Okay. If the object is thrown with less speed, if you throw an object with less speed, in that case, velocity will not be large. Large velocity graph is this. Less speed graph is this. Graph. It does not start from zero. And it becomes constant. And when it comes to the acceleration, if you throw and when an object is released, it has acceleration. Oh, yes or no? It has acceleration. Acceleration due to the gravity. So we say this acceleration will decrease because acceleration has to become zero, na? That's why. Because when it achieves terminal velocity, that is constant. So that is only possible when acceleration is zero. So this is the graph of acceleration. Acceleration has to be zero when it achieves the terminal velocity. Simple. I hope these graphs are crystalline clear. I hope these graphs are crystalline clear. Okay. A small sphere of radius r falls. See the question. A small sphere of radius r falls from rest in a viscous liquid. As a result, heat is produced due to a viscous force. The rate of production of heat. Okay, the rate of production of heat when the sphere attains its terminal velocity proportional to. Okay, when the sphere attains its terminal velocity proportional to. Rate of production of heat simply means power. Okay, simply means a rate of, I'll write over here, rate of production of heat. What does it mean? Power. It simply means power. And power is simply force into velocity. Force into velocity. So power is going to be, in this particular case, my dear NEET aspirants, what is the force? Force is the viscous force. That is 6 pi neta r into terminal velocity into this v, into this v. So v into v becomes v square. So power is proportional to r into v square. Because 6 pi neta, this is constant, v into v becomes v square, r into v square. Now, in this question, what does the question say? Small sphere of radius or falls from a rest into a liquid, reduces heat. Okay, the rate of production of heat will be, okay. Now tell me, will be proportional to, rate of production of power will be proportional to what it says. We say as, when it comes to the terminal velocity, we know it is proportional to r square. Recently, I told you, terminal velocity is proportional to r square. If terminal velocity is proportional to r square, you can put it over here. You can put it over here. So power is proportional to r into, from this equation, first I am saying r into velocity square. Instead of terminal velocity, I can write r square whole square. Okay. So power will be proportional to r raised power 4, r raised power 5. Rate of production of heat is proportional to r raised power 5. Okay, let's talk about this question. The viscous drag acting on a metal sphere of diameter 1 mm. Okay. Viscous drag means viscous force. Falling through a fluid of viscosity 0.8 with a velocity of 2 meter per second is equal to. It is saying an object falls into the liquid. How much viscous force is acting on this? Viscous force will be 6 pi neta r into terminal velocity. So viscous force will be 6 pi is 3.14. Okay, neta is given as 0.8. That is 8 divided by 10. Okay, radius is given as 1 mm. 1 mm. Okay, diameter is 1 mm. Radius is half of the diameter. So that will be 1 by 2 of diameter. 1 mm means 10 raised power minus 3 meters. Into terminal velocity is given as 2. So if you solve this, it will come out to be 15 into 10 raised power minus 3. NEET 2023 question. This was NEET 2018 question. Surface tension. Okay. Surface tension. Okay. Now guys, I think we need to take a break. Let's take a break of 10-15 minutes. Okay. Then we'll start the surface tension. Let's take a break. Break till 12 a.m. Okay, now guys, let's move on to the surface tension. Let's move on to the surface tension. Okay, let's move on to the surface tension. What is surface tension actually? See guys, see guys, see guys. We write it like this. It is the skin on the surface of a liquid. Because of this, molecules on the surface of a liquid are pulled inward by the other molecules. Let's suppose this is the surface of the liquid. So, molecules of the surface of the liquid are being pulled due to other molecules which are present inside the liquid, due to which they create some sort of skin over here. Okay. So, we call this as surface tension. We call this as surface tension. Okay. Okay. My dear NEET aspirants, we say this creates a tight, I would say, elastic layer at the top. Okay. Or you can say it is the force created on the unit length of the surface. Guys, see. This is the surface. If you take a unit, I would say, length over here in this particular case, how much is the force created on the unit length? Okay, that is what we call the surface tension. Wait. Let me make you understand with this. Let's suppose if I am placing a rod inside this liquid. Okay. The surface of the liquid applies a force on the rod. These are the atoms of the rod. Okay. The surface of the liquid applies the force on the rod, due to which surface tension holds the rod tight with the surface. So basically, surface tension is created on the surface of the liquid. If you place an object over here, it will be attracted, it will be pulled by this surface tension, due to which it holds the rod on the liquid. Okay. Simply, it is how much force is created on the unit length of the surface. You can understand it like this. So this surface tension is force per unit length, or this force is equal to surface tension into length. You can understand it like this. Okay. Now, my dear NEET aspirants, when you consider a rod, how much is the surface tension in this case? How much force on the rod? How much will be the force on the rod? Sir, force is surface tension multiplied by length. Now see, when you put the rod inside the liquid, we said this portion of the rod will be in contact with the liquid atoms. So they will attract these atoms. They will apply the force on these atoms from this side. So that's why we are taking this length. And from this side also, they are in contact with, with the atoms of the liquid. So that's why they are applying the force on both sides. So that's why we are taking the length over here 2L. Okay. What about this one? We say here, force on the disk. So F is equal to this, the disk. F is equal to surface tension into. Now, my dear NEET aspirants, what is going to be the circumference of this disk? That is going to be 2 pi r. Okay, because when you talk about the disk, we say outer portion of the disk, this portion of the disk, these atoms of the disk are in contact with the surface. Okay, so due to surface tension, we say force will act on this. Then, my dear NEET aspirants, if you consider a ring, in case of a ring, we say outer portion of the ring is in contact with the liquid, and inner portion of the ring is also in contact with the liquid. So if you find the surface tension in this particular case, we say F is equal to S into, I would say 2 into 2 pi r. Sir, why 2 into 2 pi r? Because for this one, we can write 2 pi r. For this one, we can write 2 pi r. So F will be equals 2 into 2 is 4 into S into pi into r. This one. 4 into S into pi into R. I hope this is crystal and clear. In case of an angular disk, my dear NEET aspirants, if you want to find the surface tension, you can find your force. Force will be equals to surface tension into, guys. For this inner one, these are the atoms contact with the surface, with the liquid. These atoms are in contact with the liquid. You can say S into 2 pi into R. Okay. Then plus S into, guys, listen to me very carefully. For this, these atoms are in contact. So 2 pi into capital R. So you can take S into 2 pi common. 2 pi common. So it will be a small r plus capital R. Small r plus capital R. Okay. Is this clear? Is this clear? Tell me, guys. Is this clear? Oh? So due to the surface tension, we say it will be difficult for us to pull the disk out of the water. Because imagine when you put a disk inside the water, then you want to pull the disk out of the water. It will be difficult. Why? Because the atoms of the disk are in contact with the surface of the water due to the surface tension. Due to the surface tension, they are attracting the atoms of the disk, or they are attracting the rod. I hope you got the feel of this one. Now, let's suppose you have this one. A square of side frame of length L, a square of side frame of length L, okay, floating on the surface of a liquid of surface tension T, okay. Yes. The force required to pull out the frame from the liquid. How much force we need to apply so that we can take the frame out? Sir, force will be the force that we need to, that is required to pull out will be, guys, if I say how much is the force required to pull out this angular disk, sir, this much. Why? Because this is the force acting on this disk due to the surface tension. If you apply the same amount of force in the outward direction, you can pull this out. If the outward force is less than this force, you cannot pull it out. So we have to apply the same amount of force. So can I say in this particular case, F will be equals to force on one rod. What is the force due to surface tension on one rod? Force on one rod. How much will be that? F is equal to S into 2L. And if I say force on four rods, F is equal to 4 into S into 2L. Simple. So F will be equals to, in this particular case, that is 8S into L. F will be in this particular case. What is the surface tension in this particular case is given as T. So that is 8T into L. 8T into L. Okay, what about this one? A thin flat circular disc of radius 4.5 centimeter is placed gently over the surface of water. It is placed gently over the surface of water. If the surface tension of the water is 0.07 Newton meter inverse, then the excess force required to take this out. Once again, the same thing. S is equal to, sorry, how much force is required? The force will be, must be the same as the force applied by the surface tension. S into L. This force will be simply, that is S into 2 pi into R. Okay. This force will be simply, what is the surface tension in this particular case given as 0.07? That will be 7 divided by 100. Okay. Okay. Because there's a disk. In case of a disk, we say S into 2 pi R. And then we say 2 into pi is 3.14 into radius is given as 4.5 centimeter. That is 4.5 into 10 raised power minus 2. And solve this. This will be 19.8 into 10 raised power minus 3. This is the NEET 2024 question. Then you have the contact angle. Okay. Then you have the contact angle. See guys, it is the angle where solid, liquid and air meets. That is the contact angle. Like, let's suppose a drop of water, a drop of liquid is placed on this surface. So this is air, this is liquid, and this is the surface. Now see, when a drop of water is placed on the surface, when a drop of water is placed on the surface, okay, when a drop of water is placed on the surface, then the angle between the surface and the curve of the droplet is called the contact angle. This is, see. The angle between the surface, this is the surface, and the curve of the droplet, this is the curve of the droplet, okay? This is what we call the contact angle. Okay, this is what we call the contact angle. Now, my dear NEET aspirants, in this particular case, this theta is greater than 90. When theta is greater than 90, we say this droplet will not separate on the surface. It will not make the surface wet. See. It looks like it is in contact with the surface only at one point. Okay, so the droplet stays round. If theta is greater than 90, the droplet stays round. It will not separate. It will not make the surface wet. If theta is less than 90, like over here, if the droplet has already separated on the surface. If theta is less than 90, guys, see, this is the surface and this is the curve, angle between the curve of the droplet and the surface is contact angle. So if theta is less than 90, we say the droplet is separate on the surface. It will make the surface wet. Even on the same NEET 2020 question was asked. A liquid does not wet the solid surface if the angle of contact is, I would say, greater than 90. Okay. The wettability of a surface by a liquid depends primarily on contact angle. NEET 2013. Is this clear, guys? Tell me. Is this clear? Tell me, guys, quickly. Now you have capillary rise. Okay. Just a second. Okay. Now, guys, take a look. What does capillary rise actually mean? See, guys. We say when a thin glass tube is dipped into the water. When a thin glass tube, this is a thin glass tube, when it is dipped into the water, okay, the water climbs up inside this tube. The water climbs up inside the tube on its own. This rise of water is called a capillary rise. Guys, you have a container. You put the tube inside the container. Water will rise up. When the water will rise up, so this rising of water on its own inside this tube, that is what we call the capillary rise. Okay. Now, it will rise till height h. If somebody asks you, sir, what is the value of this height? So you'll be saying h is equal to 2s, okay, divided by rho g into r. And S in this particular case is surface tension. Surface tension. Okay. And R is the radius of curvature. This. Radius of curvature. Radius of curvature means if this would become a circle, how much would be the radius of that? R is the radius of curvature. Radius of curvature. Okay. G is acceleration due to gravity. And rho is density. Everybody knows. Everybody knows rho is density. And my dear NEET aspirants, in terms of contact angle, okay, and radius of the tube, in terms of contact angle and radius of the tube, okay, listen to me very carefully. Radius of the tube would be this. This is the radius of the tube. And this R is the radius of curvature. This is different and tube radius is different. I can say in this particular case, this H will be, that is 2S cos of theta divided by rho G into R. My dear NEET aspirants, this one. Sir, contact angle, where it is make? See guys, this is the surface. This is the contact surface. Okay. This is the basically shape formed over here. This is the shape formed by the water. This is the shape formed by the water. Concave shape. Okay. And in this particular case, my dear NEET aspirants, if this is the shape formed by the water, we say angle between this curve and this surface is what we call the contact angle. That is what we have studied recently, my dear NEET aspirants. And in terms of contact angle, this is where theta is the angle of contact. S is the surface tension. Rho is the density, acceleration due to gravity, radius of the tube. Capillary rise, capillary fall, capillary fall. Now guys, see. Capillary fall is the downward depression of a liquid. Capillary fall is the downward depression of a liquid. This is the container. Capillary fall is the downward depression of the liquid inside a thin tube, inside the thin tube. Okay. Okay. When a thin tube is dipped inside mercury, this is the mercury, okay, this liquid. When a thin tube is dipped inside a mercury, the mercury level goes down inside the tube instead of rising and forms a convex shape Over there it was concave shape. Here. So basically if you take, instead of water, you'll be taking mercury, then you dip this tube, then the level of the water will go down. So, and it will form a concave shape. Okay. And this is what we call the capillary fall. How much it is going to fall in this particular case? What is the height of the fall? So you'll be saying this height in this particular case will be, that is 2S cos of theta divided by a rho G into R. Okay. This is in terms of contact angle. Okay. This is in terms of contact angle, my dear NEET aspirants. Okay. I believe this is also clear. And in this particular case, contact angle is greater than 90 here. Clearly it is visible. This is the curve. This is theta. This is the surface. This is the contact angle in this particular case. Absolutely, sir. Absolutely, sir. Few more points you guys need to remember in this particular case. See guys, what is that? Okay. See guys, what is that? See guys, in this particular case, what you guys are supposed to do is, you guys are supposed to remember one thing. There was a question I had put. Okay. Okay. See. You guys need to remember one thing. That is, when it comes to this capillary fall, this H is inversely proportional to R. H is inversely proportional to R. Okay. What is this R? R, you know, it is the radius of the tube. Where R is the radius of tube. Okay, yes. And my dear NEET aspirants, one more important thing. We say potential energy of the liquid rise. Okay, that I'll add over here. Capillary rise. Okay. If let's suppose somebody says potential energy of a liquid rise. Okay. Potential energy of liquid rise. The liquid which has gone up, how much is the potential energy of this? You simply say there is one relation over here. Guys, see. There is one relation over here. There is one relation over here. That is, we say U is equal to mg into h. Okay. We say U is equal to, or directly, what is important in this one? What is important in this one? This potential energy is proportional to r raised power 0. That means this potential energy does not depend upon r. This is what I wanted to say. This potential energy of this capillary rise, the liquid of this capillary rise, it does not depend upon the radius of the tube. Simple. That's it. Because this was the question once asked in NEET 2020. Okay. And one more important thing. We say mass of the liquid rise. M is directly proportional to R. This, and this expression you need to remember. If I say there is a container, you are putting a tube inside the container. Okay. We say the liquid will rise. If the liquid rises, somebody says, sir, this liquid will rise up to how much height? You'll be saying, sir, this. What is the relation between H and R? Inverse relation. Okay. Second, we say, my dear NEET aspirants, this U is inversely proportional to R naught. We say potential energy of this liquid rise, of this liquid column, does not depend upon the radius. And this M, mass of the liquid rise, is directly proportional to R. Tell me, guys, is this clear? Is this clear? Is this clear, or give me the signal in the chats? Okay. In NEET 2020, do you know what was asked? If mass is doubled, if radius is doubled, if the tube is having more radius, it will pull more water. It will pull more water up. If it pulls more water up, so mass of the liquid rise is going to increase. Simple, na? So we say if R is doubled, means this radius of this tube is doubled. We say M is also doubled. NEET 2020, this question directly. That's why I told you these equations in this one. Okay. Now, guys, we have the chapter 4. Thermodynamics. Okay, let's dive into thermodynamics. Now, guys, let's move on to the topic that is thermodynamics. Let's start from the scratch. Okay. See, guys, first and the foremost thing that we need to understand in this one, that is what we call work done. That is what we call work done. Okay. Let's suppose there is a container over here. This is a container, and there is a piston, kind of piston, you would say over here. Okay. Now, my dear NEET aspirants, let's suppose if I say in this particular case, due to the see, this is the cover over here, piston over here. In this particular case, this gas is applying the pressure on this one. This gas is applying the pressure on this one. If I say due to the pressure of the gas, volume of the gas changes. I'll write over here. Due to the pressure of the gas, volume changes. Due to the pressure of the gas, volume changes. Due to the pressure of the gas, volume changes. So we can say that so work is done by the gas. So work is done by the gas. And if somebody asks you how much is that work done, you say P delta V. Say P delta V. Due to the pressure of the gas, we say volume changes. So work is done by the gas. So how much is that? P delta V. And that work done is pressure of the gas into V final minus V initial. So can I say from now onwards, sir, how do we define work done in thermodynamics? If pressure is applied on a system due to which volume of the system changes, okay, so we say this moves from here to here. Here volume was VI, here volume is VF. So I would say work is done. Absolutely, sir, work is done. Okay. Now in this particular case, if I say final volume is greater than initial volume, in that particular case, work done will be positive. If final volume is greater than initial volume, work done will be positive. Let's suppose this is 10 minus 5. 10 minus 5 is 5 plus 5. Okay. So work done is positive. It means volume is increasing. It means expansion of the gas. Expansion of gas. We say if, listen carefully, final volume is less than initial volume. If final volume is less than initial volume, in that case, work done will be negative. Because 5 minus 10 is minus 5. Final volume. That is what we call work done will be negative. That is what we call volume is decreasing. Okay. In that case, that is compression of gas. Compression of gas. That is how we define the compression of the gas. I believe this is crystal clear. And one more important thing, work done does depend upon the path. Work done depends upon the path. Okay, this I'll show you after some time. Now see, if the pressure is variable, guys, when the pressure was changing the volume from this point to this point, Constant pressure was acting on the system. In that particular case, you can apply this formula when pressure is constant. If pressure is variable, in that particular case, we find small work done. Then find small work done. Then find small work done. Okay. So my dear NEET aspirant, small work done will be simply dW is equal to PdV. PdV. Large work done is W is equal to P delta V. Small work done is PdV. Small work done is PdV. Okay. Yes. Absolutely. Okay. And to find total work done, we integrate both sides. Integration of dW is equal to integration of PdV. What is the integration of dW? That is total work done is equal to integration of PdV. This is how we find the total work done. Okay. Okay. Like dV is the small change in volume. Okay. Yes. Area under PV graph. If I say what is area? Area will be integration of PdV, because area is simply integration of whatever is on y-axis, whatever is on x-axis, dV. Now, what is integration of PdV? That is work done. I told you recently. So work done in this particular case means simply, that is area. So if you have to find work from pressure volume graph, then you'll be finding the area. Now, let's take a look. In the following figure, a certain mass of gas takes 3 paths. 1, 2, and 3 from state A to state B. See, guys. At this particular point, we say gas is having, I'll tell you what does a state mean. At this particular point, gas is having pressure P1, volume V1. Here it has pressure P2, volume V2. So when I say pressure P1, V1, volume P2, V2, we say state of the gas has been changed from P1, V1 to P2, V2. The state of the gas has been changed. If the state of the gas has been changed, my dear NEET aspirants, listen carefully. We say work has been done. How can you change the state of the system? Sir, initially it was having pressure P1 and volume was V1. Then volume changed from V1 to V2, means work has been done. So how much work is done if it goes along this path, this path, this path? Work done in this particular case will be area under the curve. Now guys, tell me, this will be the area under first graph. This is W1. And area under second graph will be this entire, this one. This much area. And area under this curve will be this much. With x-axis, we always check area. So can I say in this particular case, area under 3 will be area under 2 will be area under 1. This is greater. So work done in along third path is greater than work done along second is greater than work done along first. Option C. Let's suppose the question is something like this, guys. Take a look. If the pressure of a gas is given as P is equal to 2V cube, find the work done by the gas from V to 2V. Guys, pressure is variable over here because pressure depends upon volume. So P is 2V cube. P is variable. If you have to find the work done, you say work done is equal to integration of P dV. Work done is equal to integration of P dV. So you simply say work done is equal to integration of pressure is 2V cube and then we say dV from V to 2V. From V to 2V. Okay. From V to 2V. Okay. Now guys, work done in this particular case will be take this 2 out. What is the integration of V cube? That is V raised power 4 divided by 4. That is V to 2V. Okay. So work done in this particular case will be 2 1s are 2 2s are. So 1 by 2 V raised power 4, my dear NEET aspirants, put this. First, you will be putting the upper limit, then lower limit. So this will be 2V whole raised power 4 minus V raised power 4. So work done will be 1 divided by 2, 2V, 2 into 2 into 2. 2 raised power 4 is 16. 16 V raised power 4 minus V raised power 4. So work done in this particular case will be 1 by 2. 16 V raised power 4 minus V raised power 4 is 15 V raised power 4. Okay. So this is the work done in this particular case when pressure is variable. What else do you have? Okay. Work done depends upon the path. This point is important. Work done depends upon the path. Now, my dear NEET aspirants, if I say a gas changes the state from A to B, here the state of the gas is P1, V1. Here the state of the gas is P2, V2 along this path. How much is the work done over here? We say work done is this much area. Work done along AB is this area. Let's call this as A. And when the gas travels along the same path, we say again the same area. Work done along BA. It is again the same area. Okay. So could you please tell me in this particular case, what will be the net work done? That will be 0. Okay. In this particular case. Okay. Okay. Yes. Because if you find, see, work done is equal to P delta V. Work done is equal to P. Delta V is final volume minus initial volume. So initially you started from point A. Again you reach point B. So we say P into final volume is V1. Initial volume is V1. So work done in this case is 0. That's why I am saying area in this case is also 0. Okay. Work done in a loop. 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 Now, my dear NEET aspirants, when you say work done in a loop, listen carefully. We say pressure volume. Let's suppose a gas changes the state from here to here. What is the pressure of the gas here? P1. What is the pressure of the gas here? P1. But volume here is V1, here volume is V2. So state is changed. This is a cyclic process. When I say work done along AB, listen to me very carefully. Listen to me very carefully. Work done along AB. Okay. So that is going to be this much area. That is going to be this much area. This is work done along AB. Okay. And my dear NEET aspirants, if I say this is work done along AB, okay, it is going to be positive. Why? Why? Because when you move from A to B, final volume V2 is greater than initial volume, because V final is greater than V initial. Absolutely, sir. And in this particular case, pressure is constant. Pressure is constant. And P1 is greater than P2. P1 is greater than P2. Pressure is large. If I say work done along B and C, it will be 0. Why? Because delta V, change in volume, is 0. Guys, from B to C, same volume, change in volume is 0, work done will be 0. P delta V is 0, work done is 0. If I say work done along CD, it is going to be negative, because V final is less than V initial. Because if you move from this point to this point, V2 is greater than V1. So V1 is less than V2. Final volume is this, less than this. And here pressure is also, this work is done at low pressure. So P2 is less than P1. This work is done at low pressure. Okay. Now, my dear NEET aspirants, if I say work done along AD also it will be 0. Why? Because delta V is 0. Change in volume along AD is 0. Okay. Now, if I say what is the net work done? Net work done. You say work done along AB path. This work done along AB path minus work done along CD path. Minus work done along CD path because this work done is negative. So this is going to be area of area, this area, this entire area of ADEFCB, ADEFCB, yes, minus, when you write work done of along this, so that is going to be this much area, that is area of DEFC, area of DEFC. I hope this is crystal and clear. I hope this is crystal and clear, my dear NEET aspirants. I hope this is crystal and clear. I hope this is crystal and clear. Tell me, guys. Sorry. This is given as well. Okay. Please don't cry. P1 is greater than P2. Along CD, P2 is less than P1. P2 is less, na? In CD, P2 is less than P1. This pressure is greater than this one. What? It is correct. It is correct. Now guys, let's move on to the system and surrounding. Let's move on to the system and surrounding. See guys, something which is under observation is called a system. Something which is under observation is called a system, and everything around or except system is surrounding. Something, if we are, let's suppose there's a container. We are studying this container, pressure of this container is this, volume is this, expansion is taking place, compression is taking place. So means there's a system. Everything except the system is surrounding. Okay. Open system. That system in which mass as well as energy can be interchanged with the surrounding. That system in which mass as well as energy can be interchanged with the surrounding. Here, mass is also coming out. Okay. As well as energy can be interchanged with the surrounding. That system in which mass as well as energy can be interchanged with the surrounding. That is called an open system. Example is an open pan of boiling water. When water boils, it leaks. Energy comes out as well as the matter also comes out. Okay. Mass also comes out. Closed system. That system in which mass cannot be interchanged, but energy can be interchanged with the surrounding. Example is a sealed pressure cooker. Heat can enter or leave, but mass cannot. Okay. This is called a closed system. Isolated system. That system which is completely isolated, neither energy nor matter can be exchanged with the surrounding. We say an ideal thermos flask like this. It does not exchange the heat. Okay. No heat, no mass is exchanged. It keeps the, we say, chai or the water warm inside it for a longer time. So we assume it's an isolated system. Then we say boundaries. A boundary is a real or imaginary surface that separates the system from the surrounding. So what is the boundary here? This one. It separates the system and the surrounding. A boundary separates the system and the surrounding, my dear NEET aspirants. Okay. A boundary is a real or imaginary that separates the system from its surrounding. Adiabatic boundary. What does adiabatic boundary mean? That boundary which does not allow the heat transfer between the system and surrounding. If I say the boundary is adiabatic, perfectly insulated walls like this one, it does not allow the heat transfer from system to surrounding. So it does not allow the heat transfer. Heat does not come out of this. So this is perfectly insulated walls of the system. Isothermal boundary, a boundary that maintains constant temperature and allows the heat transfer needed to keep the temperature unchanged. So if I say basically a boundary which allows the heat transfer. Let's suppose there's a boundary. Heat transfer is possible. It is allowed in order to keep the temperature constant, in order to maintain the temperature. That is isothermal. Adiabatic means it does not allow the heat transfer at all. No heat is transferred. A reversible process. If the process changes the state of a system, and if path followed by the process can be retraced back, then the process is said to be reversible. Now guys see. Let's suppose in this particular case, a state, we say, of the system is changed from P1V1 to P2V2 along this path. If the system attains the same state once again using the same path, then we say the process is reversible. Simple. If the system changes the state along this path, something like this, now it wants to attain its state back by using the same path. This is what we call in this particular case the reversible process. If It is a process that changes the state of a system. If path followed by the process can be retraced back, it can retrace, it can move back along the same path, then it is reversible. If the system can attain the same state by following the same path, it is reversible. What is irreversible? If let's suppose a system has here pressure P1 V1, P1 V1, it moves from P1 V1 to P2 V2 along this path, then it can go back to the original state using this path. So here path is not retraced. If the process changes the state of a system and if path followed by the process cannot be retraced, it is called irreversible process. This is irreversible process. It does not attain it the same state through the same path, but another path. Is this clear? Is this clear? Is this clear? Tell me, guys. Okay, now guys, cyclic process. If the initial and final state of the system is same, then the process is said to be cyclic. Like if a system changes state from P1 V1 T1, pressure is P1, volume is V1, temperature is T1, to P2 V2 T2, then it moves back to the original point. It attains the same state once again, P1 V1 T1. Then this process is called cyclic. Sir, what is the definition of reversible and irreversible and cyclic? Irreversible means if the process follows the same path once again. Irreversible means if the process does not follow the same path. Cyclic means we say initial state must be the same. Initial and final state must be the same. Okay. Then we say zeroth law of thermodynamics. What is zeroth law of thermodynamics? See guys, we say according to this law, if A and B are in the thermal equilibrium, you have a system over here. Okay. We say if A and B are in the thermal equilibrium and B and C are in the thermal equilibrium, B and C are also in the thermal equilibrium. What does that mean? That means, my dear NEET aspirants, temperature of A, we say if temperature of A is equal to temperature of B, both are having the same temperature, that is what we call thermal equilibrium. Okay. And temperature of B is equal to temperature of C. B has the same temperature at C, B is in thermal equilibrium with C, then temperature of A is also equal to temperature of C. Then A and C are also in the thermal equilibrium. That's what it is saying. If temperature of A is equal to temperature of B, temperature of B is equal to temperature of C, then temperature of A also equal to temperature of C. So we say A and C are also in the thermal equilibrium. I can say something like that. Okay. Then we said degree of freedom. Now see, what does degree of freedom actually mean? Degree of freedom simply means it is defined as the number of independent directions in which a particle can move. Number of independent directions in which a particle can move. Okay. Or the number of independent ways in which a molecule can have kinetic energy. Okay. Like example, monoatomic gas. Monoatomic gas means, I would say, helium, argon, neon. Now in this particular case, my dear NEET aspirants, you have this monoatomic gas, single atom. This can move along x-axis. So here, this is 1 degree of freedom. It can move along y-axis, 2 degree of freedom. It can move along z-axis. So total is 2 degree of freedom. Sir, when it comes to rotation, my dear NEET aspirants, we say it has 3 translational degree of freedom. Translational DOF. So F is equal to 3. And when it comes to the rotation, guys, let's suppose this is the mass. If it is rotating around x-axis and it is present on this one point, sir, if it is present on the axis itself, its moment of inertia will be 0. Its moment of inertia will be 0. So moment of inertia of monoatomic gas is 0 about x-axis. Okay. So we say moment of inertia about, I would say, x, y, z is 0. X, Y, Z is 0. So my dear NEET aspirants, this has total DOF, total degree of freedom. F is equal to 3 only. So it has translational degree of freedom 3, a rotational degree of freedom, that is 0. Because we say when this mass revolves around this x-axis, it has 0 moment of inertia because it is present on the axis itself. Even along y-axis also, it has 0 degree of freedom. Even along z-axis also, it has 0 degree of freedom. So it is not rotating about x, y, and z. Okay, so it has only translational degree of freedom. Then guys, if we talk about diatomic gas. Diatomic gas means N2O2 H2, which has 2 atoms. Now, it can move along x-axis. Okay, it can move along y-axis, it can move along z-axis. So translational degree of freedom has 3. Now see, these 2 atoms are present on x-axis. So moment of inertia about x-axis is how much? 0. Because if the masses are present on the axis, then moment of inertia will be 0. So if you place on y-axis, then moment of inertia along y will be 0. But if you are placing about x-axis, moment of inertia about x is 0, but about y it will be non-zero, about z it will be non-zero. This can rotate about y and z. So rotational degree of freedom will be 2. Total degree of freedom is 5. Okay. Now at higher temperatures, we add 2 more vibrational degree of freedom. At higher temperatures. So at higher temperature, we can say degree of freedom total is 5 plus 2 plus 2, that is 7. No, sorry. Total is 5. 5 plus 2 is 7. Total is 7. Total is 7. At higher temperature. Okay. Then we say triatomic gas. Triatomic linear. Linear means which are on one line only. This also has a rotation. First, we'll talk about translational. Translational degree of freedom is 3. It can move along x-axis, y-axis, z-axis. And when I say rotational DOF, that is 2. Okay. Rotational degree of freedom is also 2. Okay. So total degree of freedom is 5. Because about x-axis, their moment of inertia will be 0. About y and z, it will not be 0. Polyatomic. Okay. It is polyatomic, can be triatomic non-linear also. SO2, which has a structure something like this. NO2. Okay. NO2. Now in this particular case, my dear NEET aspirants, we say translational degree of freedom over here is 3. A rotational degree of freedom over here is 3 also. Because right now, it can rotate about x-axis also, y also, z also. So it has degree of freedom about X, Y as well as Z. Okay. So total degree of freedom in this particular case is, total DOF in this particular case is 6. Total degree of freedom in this particular case is 6. Okay. At higher temperature, it will have, at higher temperature, it has N vibrational degree of freedom. Sir, N is what? N will be given in the question itself. Okay. So we won't decide it. It won't, they will give you the in the question itself. So at higher temperature, what is the degree of freedom? F is equal to 6 plus N. Okay. At ordinary temperature, normally we say degree of freedom is 6 for triatomic non-linear. Okay. This was the degree of freedom. So degree of freedom basically defines in how many ways a particle can have kinetic energy. So rotationally, we say kinetic energy is actually 1 by 2 I omega square. If moment of inertia about x-axis is 0, so what is the kinetic energy about x-axis? That is 0. That's why we do not add this kinetic. We do not add this degree of freedom. We say degree of freedom about x-axis is 0. Give me the signal in the chats, guys, if this is clear. Okay, now guys, let's move on to the concept that is called the internal energy. Let's move on to the concept that is what we call internal energy. See guys, how do we define internal energy? How do we define internal energy? We say internal energy of the gas is the total energy contained inside the gas because of the motion and vibration of its atoms and molecules. Due to the motion of the gas molecules and due to the vibration of the gas molecules, it has energy stored in it. That is called the internal energy. Okay. Then it says, all this microscopic motion gives them kinetic energy. All this microscopic motion, vibration plus motion gives them kinetic energy. And in some cases, little potential energy due to intermolecular forces. Okay, the two atoms have intermolecular forces. Due to that, potential will be there also. So total energy is, or internal energy is kinetic plus potential. We say for an ideal gas, we assume there is no intermolecular force between the atoms and molecules. So potential energy of an ideal gas is zero. So but internal energy is only the kinetic energy. Okay. Now guys, internal energy is only the kinetic energy. Listen carefully. Internal energy is only the kinetic energy. Take a look guys. Let me derive some of the relations over here for you so that you would be able to understand. Sir, internal energy is, this is the internal energy. Now, if I say, my dear NEET aspirants, we say more is the temperature, more will be vibrations, more will be kinetic energy, more will be internal energy. So I'll be simply saying this internal energy U is equal to 1 by 2 kBT. T is the temperature. We say Kb is the Boltzmann's constant. Boltzmann's constant. Okay. Kb is the Boltzmann's constant. And T is the temperature. T is the temperature. More is the temperature, more will be the internal energy. Yes, sir. Now, my dear NEET aspirants, can I say this expression is valid for all the molecules? Okay, we say monoatomic, diatomic, triatomic, for every gas. Okay. Now, if I say, my dear NEET aspirants, potential energy, internal energy due to n molecules, I would say internal energy due to n molecules. Internal energy due to n molecules. That will be simply 1 by 2 kb n into T. 1 by 2 kb n into T. Okay. Now, my dear NEET aspirants, we say this is the internal energy due to n molecules. One more important thing. We say internal energy due to n molecules due to f degree of freedom. Sir, what is this? See guys, if a molecule moves along x direction, it has 1 degree of freedom. It has one kinetic energy, 1 by 2 mv square. So due to this 1 degree of freedom, it will have one kinetic energy. It will have kinetic energy along x. If it can move along y, it will have kinetic energy along y. If it can move along z, it will have kinetic energy along z. So if it has f degree of freedom, what does that mean? That means it has kinetic energy along f degree of freedom. Are yes, sir? Yes. If I say degree of freedom is 3, means it can move along x, y, and z. So what does that mean? That means it can have kinetic energy along x, y, and z. So that's what I'm saying. Potential energy due to n molecules, due to n degree of freedom, due to f degree of freedom, that will be 1 by 2 f kb n into T. Okay. This is the internal energy of a gas due to n molecules due to n degree of freedom. This is the internal energy of the gas due to n molecules. Okay. Due to n degree of freedom. Due to n degree of freedom. Okay. Yes. Now guys, listen to me very carefully. Listen to me very carefully. Listen to me very carefully. We say, as you guys will be remembering, this Kb, Boltzmann's constant, is R divided by Na. Remember this directly. R is what we call the gas constant. Okay. And Na is what we call Avogadro's number. Avogadro's number. Okay. R is gas constant and Na is Avogadro's number. Okay. Now, my dear NEET aspirants, what I can say in this particular case, so potential energy will be 1 by 2 F N. Okay. 1 by 2 Fn. Fn. Instead of Kb, can I write R divided by Na, yes, and temperature is T. Yes, I can write it like this. This will be also the potential and this will be also the internal energy formula. Now guys, we can say this N will be equals to N divided by Na. What is N? N is number of moles. Guys, remember these terms. Number of moles is N is what? This N means this small n. This capital N means it's a total number of molecules. Total number of molecules. Okay. And Na is Avogadro's number. So you can say, so this energy will be 1 by 2 NFRT. This is the most famous equation which we use. So this is also important. Okay. This you guys need to keep in your box. This you guys need to keep in your box. Okay. So all of these relations are actually important. All of these relations are actually important. Okay. I believe all of these equations are you guys will remember. Okay. Give me the signal in the chats, guys. I will be completing your syllabus, Phoenix syllabus by 15th of March. I have told the students already, okay? Please don't worry about that. We have only 6 to 7 chapters left. Rest we have completed. Now, guys, one more important thing I just want to discuss over here. One more important thing. We say molar heat capacity. For 5 minutes, please remember this directly. We say molar heat capacity is simply Cv is equal to Fr divided by 2. Degree of freedom gas constant divided by 2. Okay. So put this over here. Fr divided by 2. You'll get this internal energy as N. Fr by 2, it is Cv. Okay. N Cv. And then we say over here delta T. Okay. Sir, why did you mention delta T over here? See. If I say, see guys, I'll show you. See, we say if temperature changes, we say U changes. How do you write that? We say delta U will be 1 by 2 NFR into delta T. Change in temperature is equal to change in internal energy. So delta U you can write NCV delta T. NCV delta T. Important equation. Important equation. Okay. This is the internal energy in terms of molar heat capacity. Sir, what is molar heat capacity? I'll tell you after some time. This is the internal energy in terms of molar heat capacity. Okay. I hope all of these equations are clear. Okay. One more important thing I just want to say. Guys, internal energy per molecule. Internal energy per molecule. What is internal energy per molecule? That is internal energy divided by total number of molecules. Okay. Total internal energy divided by total number of molecules. I'll write over here U divided by N. What is this U? 1 by 2. We say N 1 by 2 N F and F KBT and F KBT. This was the original form, na? NF KBT NF KBT. Okay. Divided by N and N will cancel. So this will come out to be 1 divided by 2 N KT. This one also you need to remember. Next, guys, we say this is the internal energy. Okay, this is the internal energy of one molecule, because when you divide with total number of molecules, it will give you internal energy of one molecule. Okay, yes. If you say internal energy per degree of freedom, internal energy per degree, this is internal energy per molecule per DOF. How will you do it? That is U divided by F. 1 by 2 NF KB into T divided by F. F and F will cancel. U divided by F will come out to be 1 by 2 N KBT. This is the internal energy per degree of freedom. Internal energy per degree of freedom. So these are the equations in the internal energy which you guys need to remember in thermodynamics. Let's take a look at this. This is the question which was asked in NEET 2000, I would say 20. The average thermal energy means internal energy for a monoatomic gas where Boltzmann's constant this. Okay. For monoatomic gas, what is the value of F? That is given as 3. Okay, F is 3. So internal energy will be 1 by 2 KBT N into F. This is the internal energy. So U will be 1 divided by 2 KB into T. Monoatomic means number of molecules 1, total number of molecules. F is 3. So U is 3 divided by 2 KBT. NEET 2020. The ratio of kinetic energy of HE gas molecules to O2 gas molecules will be, guys. When we talk about HE, what is the degree of freedom? Okay. For this HE, it will be 3 because it is monoatomic. For O2, it is diatomic. For a diatomic, what is the degree of freedom? That is 5. And my dear NEET aspirants, we say when it comes to, okay, we are supposed to find ratio. Kinetic energy is proportional to degree of freedom. Because degree of freedom defines the kinetic energy. No? If a particle has 3 degree of freedom, it has kinetic energy in 3 ways. So we say kinetic energy of He is monoatomic, kinetic energy of O2 diatomic, that is F, 3 divided by 5. The ratio of average translational kinetic energy of He gas molecules to O2 gas molecules. Okay. He to O2. Okay. Translational. Okay. The ratio of translational kinetic energy. Guys. Kinetic energy translation is directly proportional to degree of freedom. Okay. Guys, what is the translational degree of freedom for He? 3. What is the translational degree of freedom for O2? That is also 3. A translation it is saying, it is not saying the ratio. In the uppercase, ratio of kinetic energy was saying. Your ratio of translation it is saying. So kinetic energy of He divided by kinetic energy of O2, it will be 1:1. Same na, 3 divided by 3 is 1:1. Because degree of translational degree of freedom, it is same. Now guys, let's talk about specific heat capacity. Specific heat capacity. Okay. Let's talk about specific heat capacity. What does specific heat capacity actually mean? See guys, we say it is the amount of heat required to raise the temperature of 1 kg of substance by 1 degree Celsius. If you have 1 kg of substance, you want to raise its temperature by 1 degree Celsius. So the amount of heat that is required is what we call the specific heat capacity. Like water requires more heat to raise its temperature. Metal heats up quickly and cools down quickly. So water has high heat capacity as compared to the metal spoon. So how much amount of heat is required to raise 1 degree of a substance? Some substances may require more heat to raise 1 degree. Some substances may require less heat to increase 1 degree substance, 1 degree Celsius. So we said this specific heat capacity, we denote it with S. We write it, it will be dQ is the heat required divided by dt, dQ by dt into M. M is mass, M is the mass. S is the specific heat capacity. S is the specific heat capacity. M is the mass. Then heat capacity. What does heat capacity actually mean? Heat capacity means it is the amount of heat needed to raise the temperature of an object by 1 degree Celsius. Here it is to raise the temperature of 1 kg. Here it is to raise the temperature of an object. This is the object, this is the object. If you want to raise the temperature of this object by 1 degree Celsius, so that is heat capacity. It tells us how much heat an object needs to warm up. Okay. It depends upon the entire object. It does not depend upon like 1 kg and all. So we say C is equal to dq divided by dt. We write it like this. We say as we recently studied, as S is equal to dq divided by dt into m. S is equal to dq divided by dt into m. So can I say, take this over here, dq divided by dt in this particular case will be m into s. So what is dq by dt? That is C is equal to m into s. Okay, C is equal to m into s. This is the relation between C is heat capacity, S is specific heat capacity. Heat capacity. Specific heat capacity. Okay. Okay. Like my dear NEET aspirants, a big pot of water needs a lot of heat to warm up as compared to a cup of water. Okay. Okay. So it has large heat capacity. Like if you take a cup of water and a big pot of water requires large heat to increase by 1 degree Celsius. Cup of requires less. So the big pot of water has large heat capacity. How much heat is capacity it has? Molar heat capacity. It is the amount of heat required to raise the temperature of 1 mole. It is the amount of heat required to raise the temperature of 1 mole of substance by 1 degree Celsius. 1 mole of substance by 1 degree Celsius. It tells us how much heat is required, how much heat 1 mole of substance needs to warm up. Okay. So we don't say mass over here. Over there it was how much amount of heat is required to raise the temperature of 1 kg. Here it says 1 mole. So we say in this particular case, this is Cm is equal to dq divided by dt into n. N means the number of moles. N means the number of moles. Okay, N means the number of moles. Okay. Now, if you say over here, guys, do one thing. Multiply both sides with m. So, what I'll do over here is multiply both sides with m. Cm is equal to dq by dt into n into m divided by m. We say as what is S? S is equal to dq divided by dt into m. Recently studied, na? S is specific heat capacity, dq by dt into m. So can I not say, guys, instead of this dq by dt into m, you can write S. So Cm will be equals to S divided by n into, we say, m. Okay. 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 Now guys, in this particular case, if somebody says, what is this m? M is the total mass of the gas. Okay. If somebody says, what is this n? Number of moles. Number of moles. Okay. So you can write it like this also. You can write it like this also. M divided by N. It is equal to M. M is molar mass. M divided by N is equal to M. M is molar mass. Okay. So put it in this equation. So Cm will be equals to M divided by N is M into S. So Cm is molar heat capacity. S is specific heat capacity. M is the molar mass. So from here, S is equal to Cm divided by M. You can write it like this also. So these are the equations of molar heat capacity. Now guys, okay, it was mentioned on this slide. Now see, types of molar heat capacity. Molar heat capacity at constant volume. Molar heat capacity at constant volume. That is CV. First, we'll discuss molar heat capacity at constant volume. See guys, when we talk about the molar heat capacity at constant volume, what does it mean? It is the amount of heat required to raise the temperature of 1 mole of a substance by 1 degree Celsius. When the volume of the gas is constant, when the volume of the gas is kept constant, this is important. It is the amount of heat required to raise the temperature of 1 mole of substance by 1 degree Celsius. When the volume is kept constant, here volume is kept constant. The gas is heated but is not allowed to expand. Gas will not expand over here. Okay? Yes. And we call it CV. We call it CV. We call it CV. And then we say, my dear NEET aspirants, molar heat capacity at constant pressure. It is the amount of heat required to raise the temperature of 1 mole of substance by 1 degree Celsius when pressure is kept constant. In this case, pressure is kept constant. So this is Cp. And if somebody says, what is the relation between Cp and Cv? You say Cp minus Cv is equal to R. Cp minus Cv is equal to R. R is universal gravitational, universal gas constant. Universal gas constant, and value of R is 8.314 joule mole Kelvin. Okay, yes. Now what is molar heat capacity? Molar heat capacity we recently got, Cm is equal to M into S. So can I write it over here? We say as Cm is equal to M into S. So we can put it over here. M into Sp minus M into Sv is equal to R. Take this M there. Sp minus Sv is equal to R by M. What is Sp minus Sv? Sp is the specific heat capacity at constant pressure, specific heat capacity at constant volume. Okay, I'll mention it, guys. I will write over here. Sp is specific heat capacity at constant pressure. When I say Sv, specific heat capacity at constant volume. At constant volume. M is the molar mass. Okay. I hope this is crystalline clear. I hope this is crystalline clear. Also, guys, remember this expression also. Cp divided by Cp will be gamma. Sir, what is this gamma? Gamma is adiabatic exponent. Remember this, we'll study it after some time. Gamma is adiabatic exponent. Okay. In terms of degree of freedom, we say this gamma is 1 plus 2 divided by f. Remember these expressions. Gamma is 1 plus 2 by f. Adiabatic exponent is 1 plus 2 divided by f also. Okay. So guys, you need to remember two equations, this one and this one. This is specific heat capacity at constant pressure and volume. This is molar heat capacity at constant pressure and volume. Let's take a look at this question. Let's take a look at this question. To find the degree of freedom, the expression, which one is valid? Oh, 1 plus 2 by f. Okay, we say gamma is equal to 1 plus 2 divided by f. So this will be gamma minus 1 is equal to 2 divided by f. So this will be 1 divided by gamma minus 1 is equal to f divided by 2. Take it over there. F will be equals 2 upon gamma minus 1. 2 upon gamma minus 1. Option first. Okay, now see guys. Is this clear till over here? Oh, tell me guys in the chats. Okay. Now see, let's talk about this one. Let's talk about this one. See guys, let's suppose nature of the gas is monoatomic. What is the monoatomic degree of freedom? 3 translational, we say 0 rotational. Total is 3. Value of Cp, Tr divided by 2. Okay. Value of CV is 3R divided by 2 in this particular case. Okay. Okay. So this will be remembering 3, and this will be CP is 5R divided by 2. 5R divided by 2 in this particular case. Okay. Now see guys. Value of this CV is FR divided by 2, my dear NEET aspirants. Okay. So see. When we say, where is this? Yes, molar heat capacity at constant volume. Molar heat capacity at constant volume, CV, we simply say it is FR divided by 2. Okay, degree of freedom, gas constant divided by 2. When I say molar heat capacity at constant pressure, we say guys, see, we say Cp minus Cv is equal to R. So Cp will be equals to R plus Cv. So if you remember, if you get the value of Cp, you will get the value of Cv. If you get the value of Cv, you will get the value of Cp, gas constant plus that. Okay. Like my dear NEET aspirants, in this table, if I am saying, this is the value of Cv. For monoatomic, what is degree of freedom? 3. So you'll be putting degree of freedom 3 over here. So it will come out to be 3R by 2. So you got the value of 3R by 2. You'll be putting over here. Then you know Cp is equal to Cv plus R. Okay. Now in this Cv, you'll be putting 3R by 2 plus R. So it will become 5R by 2. So this is 5R by 2. And what is the value of gamma for this? Gamma is Cp by Cv. Cp is 5R by 2, 3R by 2. This and this, it will come out to be 5 by 3. Array sir, it is simple. Yes. So directly remember, for monoatomic, degree of freedom Cp, Cv, gamma. For diatomic, degree of freedom Cp, Cv, gamma. Triatomic, linear, all these. Okay. So this you can do it from your end. I have told you here how you can exactly do it. Now see this question. This question is important. The molar specific heat at constant pressure for an ideal gas is 7R by 2. Okay. So molar specific heat means Cp is given as 7R by 2. Okay. The ratio of specific heat at constant pressure to that of constant volume. Cp divided by Cv, they are same. Molar heat capacity at constant pressure. Okay. Divided by constant volume. If Cp is given as this, we know that guys, Cp minus Cv is equal to R. Cp is given. So Cp plus R will be equals to Cv. Yes. So that is 7R by 2 plus R will be equals to Cv. That is 9R by 2 is equal to Cv. Now put it over here. Cp is okay, it will become minus. Oh. I made a mistake here. Wait. See, what you do in this particular case is Cv will come out to be Cp minus R. So this is 7R by 2 minus R. It will be 5R by 2. Now Cp divided by Cv. Cp is 7R by 2. This is 5R by 2. 2 and 2 will cancel. R and R will cancel. So that is 7 divided by 5. Okay, what about this one? For a certain gas, the ratio of specific heat capacity, specific heat is given by gamma. For a certain gas, the ratio of specific heats is given by gamma is equal to 1.5. Then Cp for this gas will be. Okay. Guys, see, We say Cp minus Cv is equal to R divided by M. Okay. Okay. Okay, don't use this directly. Do one thing. In this particular case, do one thing. You can simply say over here, for a certain gas, the ratio of specific heats is given by, okay. We say Cp divided by Cv. Guys, Cp divided by Cv. Where is the formula? Cp by Cv is equal to gamma. Cp divided by Cv is equal to gamma is given as 1.5. That will be 3 by 2. Yes. Gamma is 3 by 2. Then it says that what is the value of Cp? Okay. Cp we are supposed to find out. Now, guys, we say in this particular case, my dear NEET aspirants, what I want you guys to do is, gamma is given as this. Gamma is given as this. What else can we do over here? So we are supposed to find Cv. Before that, guys, if I say gamma is equal to 1 plus 2 divided by f, this is the formula we have recently studied. So we can say gamma minus 1 will be equals 2 divided by f. So f divided by 2 is equal to 1 upon gamma minus 1. What can we do? As we say Cv is equal to Fr divided by 2. Cv is equal to Fr divided by 2. Okay. So we can say Cv is equal to F divided by 2. Instead of F divided by 2, what can we put? 1 by gamma. So R upon gamma minus 1. Yes, R upon gamma minus 1. Yes. So it will be R upon gamma is 3 by 2. Minus 1. So Cv will come out to be R upon 3 by 2 minus 1 is 1 by 2. So this will be 2R. Cv came out to be 2R. Now Cp minus Cv is equal to R. Take it over there. So Cp will be R plus Cv. So that is 2R plus R will be equals to 3R. This is the answer to the question. This I'll give you as homework. This you will be doing from your end. Okay, gas mixture. Let's talk about gas mixture, guys. Let's talk about gas mixture. When two gases mix with each other, it is called a gas mixture. When two gases mix with each other, it is called a gas mixture. Okay. Now, first and the foremost thing, my dear NEET aspirants, we say this gas has number of moles N1, molar heat capacity at constant volume CV1, molar heat capacity at constant pressure Cp1, gamma 1 is the adiabatic constant, adiabatic exponent, F1 is the degree of freedom, T1 is the temperature. Similarly for this. Now we have, when they mix with each other, we are supposed to find, first of all, Cv mix. What is the molar heat capacity of the mixture at constant volume? N1, it will be N1 Cv1 plus N2 Cv2 divided by N1 plus N2. Okay, yes. Cp mix. Okay. Cp mix. Molar heat capacity at constant pressure mix. N1 Cp1 plus N2 Cp2 upon N1 plus N2. Simple, done and dusted, this one. Then if I say what is the degree of freedom of the mixed gas mixture? F mixture will be simply N1 F1 plus N2 F2 upon N1 plus N2. Okay, then what is gamma mixture? N1 gamma 1 plus n2 gamma 2 upon say n1 plus n2, n1 plus n2. Okay, yes, we say gamma mix is equal to Cp mixture divided by Cv mixture. Yes, we can write it like this also, because gamma is Cp by Cv. Or you can write it like this also, 1 plus 2 divided by F mixture. Yes, sir. Even you can write temperature of the mixture also. That is N1 F1 T1 plus N2 F2 T2 upon, we can say N1 F1 plus N2 F2. This is the temperature of the mixture. I have told you all the things which you can see over here. Now guys, if 1 mole of monoatomic gas gamma is equal to 5 by 3 is mixed with 1 mole of diatomic gas gamma 2 is equal to 7 by 5, then the gamma for the mixture it is saying, guys, monoatomic, okay, for monoatomic, what is the value of F1? That is given as 3 degree of freedom. For diatomic, what is the given of F2? Diatomic is for F2 is how much? 5. Degree of freedom is 5. Now in this particular case, when I say degree of freedom of the mixture, that is N1 F1 plus N2 F2 upon N1 plus N2. Okay. So that is going to be N1. Monoatomic means single atom. 1 into F1. Okay, gamma is given. We are supposed to find gamma of the mixture. Okay. That's cool. We'll find gamma of the mixture also. Chill. So 1 plus what is F1? That is 3 plus diatomic is 2. Okay, N2, it is 1 mole. Sorry. 1 mole. 1 mole is given. N1 is 1, N2 is 1. Because in the question, what does it say? 1 mole of monoatomic is mixed with 1 mole of diatomic. So 1 into 5 divided by N1 plus N2. Okay, this will be 8 divided by 2 is equal to 4. You got this F mix, degree of freedom mixture. Now gamma mix will come out to be 1 plus 2 divided by F mix. 1 plus 2 divided by. What is the value of F mix, guys? That is 4. 4 into 1 is 4 plus 2 is 6 divided by 4. That is 2, 3. That will be 1.5. Answer in this case is 1.5. This is your homework. First law of thermodynamics. What does first law of thermodynamics actually say? Is this clear? Is this clear? Now, first law of thermodynamics, guys. First law of thermodynamics. What does first law of thermodynamics say? If heat given to the system, if heat is given to the system, if we give heat to the system, okay, it can be used to increase the internal energy or to do the work done. So heat given to the system, it can either be used to increase the internal energy or we say work done. So dq is equal to du plus dw. This is what we call the first law of thermodynamics. Imagine gas in a cylinder with the piston. You have a gas in a cylinder with a piston. If heat is given to the gas, the gas becomes hot. So its internal energy increases. The gas also expands and pushes the piston up. So work is done. So here internal energy is increased as well as piston is being pushed. So work is also being done. Now guys, we say work done to the system. Listen to me very carefully. If I say work done given to the system, this will be taken as positive. These are the sign conventions. Remember these. Heat taken from the system. So dq is negative. When you take heat from the system, dq will be negative. Increase in the internal energy. So du is positive. Decrease in the internal energy. We say du is negative. Work done by the gas. That is dw is positive. If gas expands, we say dw is positive. Work done on the gas. We say gas compresses. We say work done is negative. We say work done by the gas. When gas does the work, we say gas expands. So work done is positive. When work is done on the gas compresses, work done is negative. Okay, decrease in internal energies, du is equal to negative. Increase in internal energies, du is equal to positive. Heat given to the system is negative. Heat taken from the system is negative. Heat given to the system is positive. These are the sign conventions you have to remember. Now see, take a look at this particular question, guys. See, in this particular case, a system is provided with 200 calories of heat and work is done by the system on the surrounding is 40 joules. Okay. A system is provided 200 calories of heat. Okay. See, dq is given as 200 calories. We say 1 calorie is equal to 4.2 joules. So we say 200 calories is equal to 200 into 4.2 joules. That will be 840 joules. This is dq. Okay. A system is provided this much of heat. The work done by the system is 40 joules. Work done by the system is 40 joules. dw is equal to 40. Then the internal energy is, guys, we say dq is equal to dw plus du. First law of thermodynamics. Heat given to the system is stored in the form of internal energy plus work done. So this is 840 is equal to, this is 40 plus dw. Okay. Okay, this is du, du. Take it over there. So du will come out to be 800 joules. Okay. What about this one? An ideal monoatomic gas carried along the cycle ABCDA in the show. The total heat absorbed by the processes. We are supposed to find total heat absorbed by the process. Now guys, see. It's a cyclic process. In cyclic process, because this is a cyclic, in cyclic process, okay, we say dq is equal to dw. In cyclic process, dq is equal to dw. Okay. In cyclic process, we say dq is equal to dw. So when I say work done is equal to area of the loop. Okay. Guys, in case of cyclic process, we reach the same state once again. If you reach the same state once again, pressure is same, volume is same, temperature is same. So means in this particular case, change in internal energy will be zero. So all the work heat will be waste in the form of work done. So work done is area of the loop. Okay. So in this particular case, that is going to be the area of the loop. So now, my dear NEET aspirant, see, as I told you previously, work will be done in this case. In this case, work done is zero. In this case, work done is zero. Work will be done in this case. Now see, when I say work done due to this, that will be this area. Then I say work done due to this, that will be this area. So what is the net work done? Total area minus this area, that will be area of the loop. Directly remember, work done is area of the loop in cyclic process. Okay. Now what is the area of the loop over here? That will be, guys, so this is how much V naught. 2V naught minus V naught is V naught. This is how much? 3P naught minus P naught is 2P naught. So length into breadth. So work done will be, dW will be 2P naught into V naught. So 2P naught V naught will be dQ. Thus dW is dQ. I hope this is also clear. This question I am giving you as homework. Please do check it from your end. This one. Now you have thermodynamic processes. Okay. Now you have thermodynamic processes. Okay. Thermodynamic processes are very important. Okay. Just a second, guys. Just a 2 minute of rest. Okay, let's start this, guys. Let's start this, guys. Okay, thermodynamic processes. Okay, okay, let's take a look. First process is isothermal process. Understand this very carefully. Okay, an isothermal process is a process in which temperature of the system remains constant. In which temperature of the system remains constant throughout the process. Even though heat may be released, heat may be absorbed or released. Heat may be absorbed or released, but temperature remains constant. That is what we call the isothermal process. Example is slowly compressing or expanding of gas in a cylinder. See, guys. See, guys. We say in case of isothermal process, I'll just write over here. Temperature is constant. Okay. Temperature is constant. Now, my dear NEET aspirants, for an ideal gas, we say internal energy remains constant because for an ideal gas, internal energy depends upon temperature. If temperature changes, internal energy changes. So I would say if temperature is constant, delta T is zero, change in temperature is zero. So change in internal energy will be zero. Okay, so I would say internal energy remains constant. Internal energy remains constant. Okay, internal energy remains constant. Now, my dear NEET aspirants, we say it is a slow and reversible process. It is a slow and reversible process which can be taken to the initial state at any point of time. Which can be taken to the initial state at any point of time. Okay. Now, guys, first law of thermodynamics for isothermal process, we say delta Q is equal to delta U plus delta W. In case of isothermal process, change in internal energy is zero. So we say delta Q is equal to delta W. So means all the heat supplied in isothermal process is will do the work done. It will not store the internal energy. Now, my dear NEET aspirants, ideal gas equation. We say as of now, remember ideal gas equation is PV is equal to nRT. Directly remember this. P is the pressure, V is the volume, N is the number of moles, R is universal gas constant, T is temperature. Now, in this particular case, N, R, T, these are constants because temperature remains constant. R is universal gas constant, number of moles is constant. So we say PV is equal to constant, pressure into volume is equal to constant. We say pressure is inversely proportional to volume. So what does that mean? That means P1 V1 will be equals to P2 V2. Okay. P1 V1 will be equals to P2 V2. Now work done in an isothermal process. Guys, directly write. Work done, how much is the work done in an isothermal process? When we say work done will be nRT. If a system is doing isothermal process, how much work is done? nRT log to the base E. We say V2 minus V1. Directly remember this. I'll not be deriving over here. Or we can say W is equal to nRT log to the base E. We can write P1 minus P2 because volume is inversely proportional to pressure. That's why we can write P1 minus P2. So you can write W is equal to, if you want to convert this to the log to the base 10, 2.303 nRT log to the base 10. We say P1 divided by P2. Or you can write 2.303 nRT log to the base 10. I can say V2 divided by V1. I can say V2 divided by V1. Okay. This is isothermal process. Now, graphs of isothermal process. First off, temperature versus volume. Sir, temperature is constant in isothermal process, yes. Pressure versus volume. Pressure is inversely proportional to volume. Okay, this is the pressure versus volume graph. And temperature will remain constant throughout in this case. Volume is increasing, expansion, but temperature is constant throughout the process. Here, temperature T1, 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 T1 at any point. Pressure versus temperature. You need to make temperature constant. That would be something like this. Okay. And this is pressure versus volume. You can make it like this also. If volume is decreasing, isothermal process can be like this also. In case of compression, compression means in case in which volume is decreasing. Here volume is increasing, this expansion. Temperature is here also constant. Then we have isochoric process. In case of isochoric process, my dear NEET aspirants, we say isochoric process, that thermodynamic process in which volume of the system remains constant. Volume does not change throughout the process. Volume does not change throughout the process. Now guys, if volume remains constant, see, we say if volume remains constant, I'll write over here. So we see if volume is constant, what is the value of dV? dV is 0, change in volume is 0. If change in volume is 0, pressure is, work done is P dV, pressure into delta V. So dV is 0, so work done in this particular case is 0. Okay. Now if you use first law of thermodynamics, delta Q is equal to delta U plus delta W. What is the value of delta W in this case? That is 0. So we can say in this particular case, my dear NEET aspirants, delta Q will be equals to delta U. Delta Q will be equals to delta U. So means all the heat given to the system will be stored in the form of potential energy. Whatever the heat you give to the system will be stored in the form of potential energy. Yes. So ideal gas equation is PV is equal to nRT. Now here N is constant, R is constant, volume is constant. So can I say pressure is directly proportional to temperature? So I can say P1 divided by P2 is equal to T1 divided by T2. Absolutely, sir. Okay. Okay. Yes. Yes. I believe this is also clear. Now guys, let's talk about isochoric process. In case of isochoric process, we say that thermodynamic process in which volume remains. Which one is this? Okay, isochoric is here. Okay. It has come once again. Okay, let me delete this slide. Okay. Now see graphs for isochoric process. Volume is constant. We say pressure is directly proportional to temperature. Okay. So my dear NEET aspirants, we say graph between pressure and temperature will be straight line. And graph must pass through the origin. This graph must pass through the origin. It must pass through the origin. So means when temperature is 0, pressure is 0. Okay. And in this particular case, we say PV is equal to nRT. P divided by T is N divided by NR by V. Now guys, P divided by T, that is P divided by T. So what is the slope of this graph? Slope of this graph is pressure upon temperature. That is perpendicular by base. So pressure upon temperature is slope, and slope is NR is constant. Slope is inversely proportional to 1 by volume in case of PT graph. If I say TP graph, what is the slope here? Guys, PV is equal to nRT. Here T divided by P will come out to be V divided by NR. So what is the slope in this graph? What is the slope? Slope will be T divided by P, perpendicular by base. So T by P is slope, and that is T by P is directly proportional to volume. Slope is directly proportional to volume. And graphs of isochoric, temperature versus volume, make sure you make the volume constant. Volume versus temperature, make sure you make the volume constant. This is constant volume. Compare the volume in the 3 graphs over here. Okay, you are supposed to compare in the volume in 3 graphs. It is TP graph, guys. It is TP graph. Okay. In case of TP graph, we can say Slope is equal to volume. The one which has more slope will be having more volume. Clearly you can say V1 is greater than V2 is greater than V3 because slope of V1 is greater than V2 is greater than V3. Okay. Then comes the isobaric process. Isobaric process means that thermodynamic process in which pressure remains constant. Isobaric process means in which pressure remains constant. Okay. So my dear NEET aspirants, if pressure remains constant, if pressure is constant, can I say change in pressure is going to be zero? Absolutely, sir. Work done in isobaric process. We say work done will be P delta V. So work done will be P into final volume minus initial volume. Okay. I can say in case of isobaric process, dq is equal to du plus dw. Okay. Yes. So means heat given to the system can be stored in the form of internal energy as well as work done. Ideal gas equation, we say PV is equal to nRT. V is equal to nR divided by P into T. So nRP is constant. So volume is directly proportional to temperature. Okay. So V1 by V2 is T1 by T2. Okay. Now guys, one more important point in this particular case. Since some portion of the heat is stored as internal energy, so the fraction of heat used, see guys, in this particular case, heat is stored in the form of internal energy and work done. We say fraction of heat used to store as internal energy. What fraction of heat is used to store as internal energy? That is du by dq. It is 1 by gamma. Gamma depends upon the gas. For different gases, gamma will be different. So accordingly, they will decide what portion of heat they will store in the form of internal energy. It depends upon gamma. Okay. It depends upon gamma. Fraction of heat used to store internal energy. That is du by dq. That is 1 divided by gamma. Gamma depends upon the gas. Then we say fraction of heat used to do work done. What is the fraction of heat that is used to do the work done? Okay. So that is dw by dq. 1 minus 1 by gamma. If this is the fraction of heat used to store internal energy, what will be the fraction that is used to do the work done? 1 minus 1 by gamma. Okay. Or you can write it like this also. Okay. Okay. Ratio of du by dw. So du divided by dq. This is the fraction of heat used to store the internal energy upon dw by dq. Fraction of heat used to do the work done. 1 by gamma upon gamma minus 1 upon gamma. Gamma cancels. 1 divided by gamma minus 1. This is dq will also cancel. This is du divided by dw. Now graphs of isobaric process. In case of isobaric process, pressure is constant. So P in PT graph, P is constant. VP graph, P is constant here. In case of VT graph, it would be something like this. Volume is directly proportional to temperature. Because we studied, okay? And in this case, if I say what is the slope? Slope is V divided by T. Now from here, if I say slope is, see, PV is equal to nRT. What is the slope here? V by T. So V divided by T is equal to nRP. So all the three are constants, okay? V divided by T. Okay. In this particular case, what I can say, this is the slope. So slope is equal to V divided by T. Okay. So V, okay, that's why I got confused, huh? So we can say V divided by T is equal to nR divided by P. So V divided by T is the slope. So slope is inversely proportional to pressure. Slope is inversely proportional to pressure. Okay. So the one which has got more slope has less pressure. And here slope is directly proportional to pressure. In case of TV graph, slope is directly proportional to pressure. In case of VT graph, slope is inversely proportional to pressure. Now this is the question over here. In case of VT graph, slope is inversely proportional to pressure. We can say slope is inversely proportional to pressure. The one which has more slope will be having less pressure. So P1 is less than P2 because slope of P1 is greater than slope of P2. Okay. This question is your homework. You'll be doing this from your end. The PV diagram for an ideal gas in a piston in cylinder in a thermodynamic process shown. The process is pressure is constant. In which case pressure is constant, guys? Isobaric. Isobaric. Compare P1, P2 and P3 in this particular case. Guys, what is the slope here? Slope in this particular case is T divided by V. Okay. Okay. Slope is now PV is equal to nRT. So T divided by V will be equals to P divided by nR. So slope is directly proportional to pressure. The one which has got more slope has more pressure. So P1 is greater than P2 is greater than P3. This is your homework. You will be seeing this from your end. Now you have adiabatic process. Now you have adiabatic process. Adiabatic process is the process in which no heat enters or leaves the system. No heat enters or leaves the system. The temperature changes only because of the work done, not because of the heat transfer. Heat transfer is zero. It is because of the work done. It is a fast and irreversible process. Example is bursting of tire. When tire bursts, the compressed air inside escapes very quickly. Okay. The process happens so fast that there is no time for heat exchange between air and surrounding. So simply adiabatic process, that process in which there is no heat transfer. Temperature changes because of the work done. It's a fast process and irreversible. Okay. We say first law of thermodynamics. dq is equal to dw plus du. dq is 0. Okay. So dw will be equals to minus du. Okay. So work is done by the gas on using its internal energy. What does it mean? Work done is negative. Work done, work is done by the gas. Work is done by the gas on using its internal energy. On using its internal energy. So internal energy decreases. So internal energy decreases. So here we say PV raised power n is equal to constant. Guys, directly remember this in this particular case. We say PV raised power n is equal to constant. Okay. And TV raised power gamma minus 1 is equal to constant. This is the relation between temperature and volume in case of adiabatic process. This is the relation between upper one, pressure and volume in case of adiabatic process. Okay. Okay. And one more important relation. Okay. That is P raised power 1 minus gamma, T raised power gamma is equal to constant. This is the relation between pressure and temperature in case of adiabatic process. These three you guys need to remember. Slope of PV graph in case of adiabatic process. See guys, when it comes to the slope in case of adiabatic process, it is gamma times slope of isothermal. Gamma times slope of isothermal. So slope of adiabatic is greater than slope of isothermal. Let's suppose if you have two graphs, which one is adiabatic? This one, because it has large slope. Slope at this is adiabatic, this is isothermal. Slope of this is minus P by V. Slope of this will be minus gamma times of P divided by V. Because slope of adiabatic is minus gamma times of P by V. Gamma times of slope of isothermal. Guys, can you hear me, guys? Tell me, can you hear me now? Can you hear me? Can you tell? Yeah. Okay, wait. Let me finish this. Let me finish this. Wait. From could you please tell me from which topic you which one from where I was audible? Is this done? Is this done? Is this clear? Tell me. Is this clear? Is this clear? Tell me. Tell me, is this from where you are exactly saying? Could you please tell me from which topic I was not audible? Okay. Let me clear this. Let me clear this. See, when it comes to the slope of PV graph in case of adiabatic curve, we say slope of adiabatic graph is gamma times the slope of isothermal. It is gamma times the slope of isothermal. Listen carefully, guys. It is gamma times the slope of isothermal. It is gamma times the slope of isothermal. Okay? Yes. Now, my dear NEET aspirants, we say whatever is the slope of isothermal curve, whatever is the slope of isothermal curve, same will be the slope of adiabatic but gamma times. So can I say slope of adiabatic curve is greater than slope of isothermal? Slope of adiabatic is greater than slope of isothermal. Now see, if this is the isothermal curve, what is the slope of isothermal curve? Minus P divided by V. What is the slope of adiabatic? Minus gamma times of P by V. I can say it like this. Minus gamma times of P by V. So we say slope of this will be greater and will be negative. This is the negative slope. Slope of this will be less. Now see, gamma for monoatomic is greater than gamma for diatomic is greater than gamma for triatomic. So slope of monoatomic is greater than slope of diatomic is greater than slope of triatomic. Now, if you make the graph over here, see, we said this will be isothermal graph. This will be for triatomic and large slope will be for monoatomic. Why? Because gamma for monoatomic is large. So slope will be large as compared to dia, as compared to tria, as compared to isothermal. Okay. I hope this is crystal and clear. I hope this is crystal and clear. Then, my dear NEET aspirants, we say work done in an isothermal, in an adiabatic process. So this is work done in adiabatic process P2V2 minus P1V1 into 1 minus gamma. P2V2 is the final state. P1V1 is the initial state. 1 minus gamma. Okay. Yes. This is going to be the work done in an adiabatic process. Okay. And in case of compression, we make the graph something like this. This is isobaric, isothermal. This will be adiabatic. This will be adiabatic. Okay. Okay. Yes. Now guys. Then I solved this question. Let me solve this once again. Let me solve this once again. Let me solve this once again. A monoatomic gas at pressure P1. Okay. A monoatomic gas at pressure P1. Okay. When I say monoatomic gas, you can simply say, sir, for monoatomic gas, we say degree of freedom will be 1 plus 2 divided by F. F is 3. 1 plus 2 divided by 3. Gamma will be 5 by 3. Now, in case of adiabatic process, we can say PV raised power gamma is actually constant. So means P1 V1 raised power gamma will be P2 V2 raised power gamma. So we have to find, okay. Then my dear NEET aspirants, we can say a monoatomic gas at pressure P1 V1 is compressed adiabatically. 1 by 8th of its original volume. Volume is decreased by 1 by 8th. What is the final pressure? P2 we are supposed to find out. Okay. So can I write over here, guys, P2 we have to find. So P2 will be P1 into V1 divided by V2 raised power gamma. So P2 will be value of P1 is P1. V1 is V and compressed finally to V by 8. Raised power gamma. Gamma is 5 by 3. This and this will cancel. So P2 will come out to be P1 into this will be 8. That is 5 by 3. So P2 will come out to be P1 into 8 is 2 cube into 5 by 3. 3 and 3 will cancel. 2 raised power 5 is 32. P2 will come out to be 32 of P1. Is 32 of P1. Then my dear NEET aspirants, this was the question. PV graph. This graph is having pressure constant, so isobaric. This graph is having volume constant, so isochoric. This graph will be isothermal. This will be adiabatic. We know slope of adiabatic is greater than isothermal. Now you have to match. Now you have to match process 1, process 2. And this is homework. In which of the following heat is neither absorbed nor released by the system? That is adiabatic process. Okay. Adiabatic process. Two cylinders A and B equally capacity are considered. Okay. Okay. Are considered or are connected to each other via a stopcock. Okay. So 2, this is B, are connected to each other via stopcock. A contains an ideal gas at standard temperature and pressure. B is evacuated. The entire system is thermally insulated. The stopcock is suddenly opened. The process will be, guys, when it says thermally insulated, so heat transfer will be 0. Heat transfer is 0 means which process? Adiabatic process. Adiabatic process. I believe this is crystalline clear. I believe this is crystalline clear. Okay, let me just show you these also. This is also important from this one, that is graph convergence. Let me show you these questions from the graph convergence, and we are done with the thermodynamics. This is the last topic. Okay, this is the graph convergence. Guys, see, if somebody asks you convert this PV graph into PT graph, see what you will do. First, try to look at this AB. First, try to look at this AB. In AB, we say pressure is constant. I'll just write over here. When I say AB, pressure is constant. If pressure is constant, we say PV is equal to nRT. Okay, PV is equal to nRT. Now, we can say pressure is constant, number of moles constant, R constant, so V is proportional to T. So V is proportional to T means if volume increases, temperature increases. Now, you have to make the graph. For AB, volume is increasing, temperature is increasing. volume increasing, temperature increasing. Temperature is increasing in this direction. This is AB. So it is exactly similar to this, yes. Now take a look at BC graph. This BC graph, it has constant volume. B to C, volume is constant. So use PV is equal to nRT. Volume constant, number of moles constant, R constant. So P is proportional to temperature. Pressure increases, temperature increases. So we say if this is PT graph, pressure increase, temperature increase. So graph would be this. This is increasing, this increase, this increase, this increase. And make sure you need to make the graph in such a way so that it passes through the origin. Because PT, in case of PT graph, if you need to keep volume constant, then it must pass through origin. Okay, this will be the graph. Here P is directly proportional. Then in case of CD graph, again in case of CD, what is constant? Pressure. In case of CD graph, pressure is constant. If pressure is constant, PV is equal to nRT. So pressure is constant, volume is directly proportional to temperature. Okay, so volume increases, temperature increases. Volume decreases, temperature decreases. So in CD graph, I can say volume is decreasing, so temperature must decrease. So temperature is decreasing in this direction. Okay, so it should come back. It should not go like this. It should come back because then only temperature will decrease. Then AD graph, again volume is constant. AD graph, volume is constant. So PV is equal to nRT. If volume is constant, pressure is directly proportional to temperature. So if pressure decreases, temperature decreases. Now tell me, in this graph from D to A, we can say pressure is decreasing. So volume must decrease. So volume will decrease. Sorry, pressure is decreasing. So temperature must decrease. Temperature will decrease in this case. Okay. 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 And volume must remain constant. You need to decrease the graph in such a way so that volume remains constant. Volume remains constant only when the graph passes through the x-axis, passes through the origin. This is the graph. Similarly, you can make this graph from your end. This is your homework. This is your homework. Okay. Or let me show you this also. See guys, when it comes to AB, my dear NEET aspirant, this is pressure versus temperature. Okay. Pressure versus temperature. I can say pressure is directly proportional to temperature because this is a straight line. Pressure is directly PV is equal to nRT. When is pressure directly proportional to temperature? When volume is constant. Now, sir, you have to make the graph in such a way, PV graph in which volume is constant. This is volume. Volume is constant. Okay. Then I would say in B and C graph, pressure is constant. B to C, pressure is constant. So PV is equal to nRT. If pressure is constant, volume is proportional to temperature. So if volume decreases, so if temperature decreases, volume must decrease. Now, here temperature is decreasing. So volume must also decrease. So volume must decrease. And pressure must remain constant. The pressure is constant and volume is decreasing. Then in this case, we say temperature is constant. So we say when temperature is constant, guys, PV is equal to nRT. So pressure is inversely proportional to volume. So graph will be this. Graph is isothermal. I hope this is crystal and clear. I hope this is crystal and clear. After this, you have kinetic theory of gases. Okay. So I think, guys, it is not possible to finish the next chapters in this one. So I think it will require one more one shot. It will require one more one shot. So I think we will be ending the today's session. Okay. Thank you. It will require one more one shot, guys, in which we'll be completing the rest of the chapters because it is not possible. Okay. Is that cool? Chalo, guys, that's all for today.